Word. Okay, I'm here to introduce Laila, who's going to talk about world building, but she is allowing me a few minutes to introduce world building itself from the technical. I want to create a technical foundation, and she'll introduce a creative one on top of that. So, hello to the world. Let's look at the world that we're currently in. Right now, there's tons of game worlds. 3D is not the only kind of game world. It's not even my favorite, but it's the one we're talking about now. In the 3D world, in the game, we build objects, and the objects have surfaces, and it's very Euclidean geometry, and it's a lot of work. These are like, we're in the age of sculpture. You sculpt these things, and there's a lot of engineering that goes into sculpture, a lot of thought. Rodin had to make sure that this wouldn't topple over, it support its own weight, you can move it, you can, build it. Now, unlike us, doing all this work to create a 3D world, the diffusion models are like the pointillist painters back in, in France and in La Mancha. The models sitting in a garret drinking absinthe and painting little dots. And it is impressionism. Doesn't have a geometric world view. It has a sense of the world and guesses dot by dot what should be in it. And this is a 2D image, but in 3D, this is my first slide code. It creates what we call Gaussian splats. Gaussian splats being dots. Dots that have, a size and ellipticity and color. And we can go through and look at them all. And this is a very crude model of the world, and it makes a very crude image. But if we were to use a real diffusion model, we would get a real nice picture. But it's done the same way. This is a world of dots, and probabilistic dots at that. This is Nanobanana, did a good job. Oops, I did too fast. This is, so this is demonstrating that it's not just an image, it has some sense of the way people in the image would move. It doesn't have a sense of their geometry, but it doesn't know what they look like. And it's able to keep consistency frame to frame. So you think that maybe these models are as good in the game as the models we're used to. And not quite yet. And I'll show you, they don't move the same way. Here's how an object moves in the game. This is a really highly intentional engineered object. It's got, it's made out of lots of little polygons that describe its surface geometrically, little Euclidean triangles, and very few of them, the absolute minimum to make it look good, to make it, we have the nose and need lots of them, but on the chest don't need very many, and they're engineered so that when the object bends, when the elbow bends, for example, it folds nicely because the vertices are in the crease of the elbow. It's a whole art form and engineering form of that. And then, of course, it looks good because you can put color on it, and you can put in, all different surface qualities. But so you might say, well, let's just let's create a point cloud, Gaussian splat model, and then reduce it, using marching cues or Poisson math that I don't understand, to find the surface, and then voila, we model something. And there's a product called meshing, that's what made this guy, who looks pretty good. Until you dig in. This is great, directly meshing, a few words of prompt. But if I were to look at how the vertices are here, there are 40,000 triangles here. There were 4,000 on that beautiful animated peasant. And this guy doesn't even have fingers, and he doesn't even have legs. That's 40,000 for a very, very crude outline. And if it was only 40,000, you'd say, well, it's not very performant, but maybe if it was my hero object character, it would be okay, but it's still not okay. Because, they're just randomly across the surface, or they're regularly across the surface. They're not describing the actual way something moves or bends. This will break, or stretch, or pinch if you try and put bones into it and rig it. So, we're not ready for that yet. And also, meshing is not really that great at kinetic character. I tried to get the Apple guy quicker, and his ass is facing the front, and his legs are going the other way. But that's not too important.
So that's coming from the Gaussian flat 2?
That's from
mesh?
Yeah, that was meshing, first doing a bad job of the Gaussian flat, and then doing a horrible job of turning it into a mesh. This, however, is Worldbuilding, which is a really beautiful job of creating worlds, which is what Laila's going to explain and demonstrate. And the things to bear in mind here is that this is a beautiful static. It's a world you can move through, but it's a world that until you overlay it or underlie it with another set of geometry that explains where, let's say, walkable surfaces are, it's not a world you can play with. And if you want to put characters in it, you're not going to be able to use this tool to create characters. But it can make a very rich environment. The next step, the world that's frighteningly on the horizon, is this one, which is Genie 3. The difference between world that built you this world, and you ran the splats through your render, and they were just fine, on your normal GPU. And if you put 3D, normal 3D in there with it, this is every frame is being generated just like when Midjourney was doing that animation, just at its head. This is the same thing. It has a pretty good idea the way cats move and the way rotors move, and it's generating each of these frames in real time from one prompt, and you're playing it in real time, and 8 high-powered graphics chips in Google's data center are running full time to play your game, which is very expensive right now. It costs about a penny a second, which is a lot of money. When you do that. But let's look at the reaction of the world to existence of Genie 3. Genie 3 comes out, and the stock of Take 2 drops 20%, and the stock of Unity drops 50%. It perhaps overreacting. Well, I know my own sense of my own value dropped a bit, knowing that someone can just create a game by saying, I want a game, and someday they'll get it. So I don't want to panic. So hello, new world, not yet. A penny a second is $36 an hour. No game is worth an F16 simulator is worth $36 an hour. No other game is. But Moore's law is at our backs, so it's coming. Eventually, soon. So we can get crushed by this wave, or we can listen to Laila explain how she's surfing on top of this.
Hey, just call him. Definitely want your phone?
We're supposed to be timing this out. I forgot.
Hey everyone.
Hello.
Hey.
Hey, my name is Laila. It's nice to see you all today. Hope you guys are having a great time here. Thank you, Doug, for the amazing introduction. I want to start this off by saying I am not a game artist. I am background is in filmmaking, storytelling, that nature. So we're all storytellers here today. I found this extremely. This is fun.
It only goes to the live stream. It's not for the room.
Oh, okay, cool. I found world models extremely interesting. Like I said, my background is in filmmaking, and I was doing that for a long time, a little while. And from what I found is that I crave something more from film. I feel like just sitting there in a theater, you're not able to touch anything. You're not able to. It doesn't feel as tangible as I would like it to feel. And so I started to delve more into installations and immersive experiences because I feel like that's closer to getting things, making things more tangible. And so that is also why I found world models so interesting. So what you guys are going to see right now, this is a splat I made in the World Labs. We're going to navigate through it as the presentation goes on. So I intentionally left it back. It's pretty crazy, but yeah, we're going to keep it going from there. All right. What's the next slide? Okay, like I said, different entry point. I am not a traditional game artist. I am just a storyteller and a new media artist. I think that these tools are allowing more artists to delve into the sort of gamification of their work, but also a more immersive version of their work. Also, I feel like the word immersive gets thrown around a lot, so I'm not just trying to throw it around as a buzzword, but I do feel like we are getting closer to it. Okay, two kinds of worlds. Okay, Doug mentioned both of these worlds. He mentioned World Labs, and he mentioned Genie 3. And like he said, Genie 3 is running more off of it in the data centers and all that jazz. World Labs is running online, but it's not an actual game engine. You're just developing the worlds that you want to build. And then you would put that into your Unity or Unreal or Blender and clean it up. So yeah, Genie 3. You only get 60 seconds to navigate this world. And I'm going to show you guys what that's like in like a minute. But essentially, this is how it looks. You have Genie 3. You get to try Project Genie. And I'm going to explore now. And then from here, I'm able to see all the worlds that people have created. So we have, this person has this world, there's a backyard racetrack, this is a roller ball, silver spear. Oh, I don't know. I'm not. I didn't mean to click on it, but we can see this one. And yeah, it only gives you, when you create your world, you only have 60 seconds to fully go through this world. And yep, now you only have 60 seconds. So I can use this on the, you see right here, I have to use that in order to move the character. On the other side, where it's like up, down, left, right, that's what moves the camera. So I want the ball to go this way. So I'm moving it by pressing this. Now, this is cool. Again, I only have 60 seconds, and I didn't really mean to click on this world, but I guess it's a world filled with yellow balls and a silver sphere in this. And yeah, I'm just navigating it. Again, you guys see that bar at the top that's showing me how much time I have left. And I don't have much time left in this world. Not literally, but God forbid. But yeah, I don't have, a lot of time to play with this. And so once it's over, it will ask you, hey, do you want to download the video? I don't know if anyone has seen that on Twitter or YouTube, but they'll show you essentially them navigating the world. This is how they're able to do that, and then just download the video. But what I want to do is I want to create a world. I want to create my own world. And so this is sort of how it starts off. You get to select your environment. What does your world look like? In character, describe your character. Is it a person, animal, object, or something else? And I really like this because when you're telling stories, these are kind of the things that go in the back of your mind, especially when you're setting some sort of environment. How do I want my character to operate? What world are they operating in? Are they in the city? Are they in the country? Are they in 50 years from now? Are they in the 1920s? What does this world look like? And I think that this is kind of not necessarily giving you the full capabilities, but it's kind of exciting that you get to use your words to come up with this descriptive language for what you want a world to look like. So, environment. I'm a collaborative person when it comes to these things. So, what should the environment be? Anybody want to shout something out?
Academic, a college classroom.
Candy shop.
Okay.
Candy shop's better. Candy shop's better.
Candy shop. All right. Who's our character? What's the character? Is it an object, a person?
Platypus.
Platypus. You were giving something I don't know if I could spell. I think I spelled it right.
Y-P-U-S. Plat. Y. P-L-A-T-Y.
I also don't know how to spell that.
P-L-A-T-Y-P-U-S.
So it's T-Y?
T-Y. It's Perry.
No, I think it's P-U-S.
U-S, yeah. P-U-S.
You guys.
No, I kind of want to get that initial platypus before anyone else gets
All right, it's Perry the platypus. Okay, candy shop. Do we want to give any more descriptions about this candy shop?
Infernal.
All right. Anything else? No?
The universal concept is the speed of dark.
It's got slides.
Okay, slides.
You mean like slides you can slide down?
Yeah.
Oh, I said sides.
And also PowerPoint slides.
We didn't
But
even think about Candyland. You guys remember that game?
Yeah.
Oh, yeah.
Okay, I'm gonna put in Candyland too.
Say shoots and ladders then, that's.
Yeah, shoots and ladders.
but it's a candy store.
I'm sorry.
C-H-U-T-S.
Alright, guys. Alright, this is our candy shop, Inferno, slide, shoots and ladders. I don't know what's going to happen. I really am scared. Should we do third person or first person?
Third.
Okay.
Let's see
Third
the fun.
person. Alright.
Oh.
Wait, I think it's. Oh, wait, I think when it pops up like that, that's what we got. Alright, let's create a sketch. So it's essentially going to render this, take a little time. Yeah. So while that's going on, you can also add things too. Okay, let me show you. But you can add images. So if I wanted to have given a reference, I can do that. But right now it's just kind of building this world and it feels like a black hole. The abyss. And yeah, we're going to let that do its thing. Now I'm going to keep over here so that keeps going. So while that's going on, I want to talk about World Labs. Okay, so World Labs. World Labs, if anyone's not familiar, is a tool that came out. It's been out for a little while, but the most recent update to it, Marble, came out towards the end of last year. And the creator of World Labs, her name is Fibble. She is known as the godmother of AI, and she speaks a lot about how people think we're very close to AGI because of all these capabilities that we have currently. But really, she says that AI doesn't have reasoning. It doesn't understand depth. So it can read literature, it understands that, but it doesn't also understand texture and context of what's around it. So she feels that this is a good solution for that. So essentially utilizing these tools to help spatial reasoning, spatial models, all that jazz, kind of extend. And so I'm going to show you that while we're waiting on something. Create with Marble. So I have some things I've already created with Marble. So a lot of these are just taking stills for. So for instance, this is actually an art installation that I did and for the city of Atlanta. So this is it right here. And so I plugged that image into World Labs. And then I was like, okay, well, let me have an entire world that I can just navigate. And people can now, if they come to my site, they can actually not only see my exhibit, but they can also see the world I want my exhibit to actually live in. Because my piece of work is not just this singular piece of work. It's a world I'm trying to build. So, yeah, this is one example. We can also create something here too, but yeah, this is one example. This is another example. This is also from an image, and then I plugged it in here, and then it gave it this sort of, kind of like, it's in a room with multiple. What I've also found is that this is a terrible job with people in it. So if you use this tool, do not have people in the image that you utilize because it's going to make them look kind of wild. Let me see if I can find something. For instance, this is a picture of, it's not a person, but this is a picture of my uncle's dog. His name is Deuce, and this is not really how his house, my uncle's house looks. From here, yes, but on that left side, no. And so you see how Deuce has his like leg all crazy, and this poor dog. Yeah, he's all kind of like that. And then as you go out, you see that you're no longer in the world. You start getting out of this world. And I really think that's kind of, I think it's kind of cool. But it's all fragmented. It's very scattered. Yeah, so these are just different examples. This is another example. This is a picture of my grandparents, and I was like, "Ooh, that'd be cool if I could make a memory." That's not what happened at all. It pretty much gave me this very, look at that. Can you guys tell that it was trying to kind of put my grandma, I think that's what, my grandma's body there has this thing here, and has all these chairs over here. So I don't even know if this is really how it looked, but I wasn't there. They were very much over here. But yeah, it kind of, look at the foot. You see that? It's crazy. So yeah, it doesn't do a great job of that. But I will say I did like it. Well, this is a picture with me in it, so I guess it did all right. But like, I look different. Look at that. It fakes you out. You think it's me from my photo, but really it's not. And it adds this lady in here. That girl was really there. Nobody was really there. So yeah. Anywho, just want to show you guys how it looks with people. But I think as far as like showing your exhibit as an artist, I think that's kind of cool. But let's see if we can imagine a world. So we're here. What do we want here? What's our world?
You want to compare candy shops?
Ooh, compare candy shops. Oh wait, let's go back here. Actually, I didn't even. Oh.
Whoa, there's
Oh my gosh.
Infernal.
Let's create the world. Alright, let's create this world. We'll let this load and we'll go through this tonight. That's actually, this kind of looks horrifying. But I'm gonna use this.
Oh, wow.
There you go.
Yep. You can jump. That's the space bar. Wow! So I'm moving the camera as I move the character.
Why is it good with demonics?
I know where I'm going. Oh my god! Why am I scared? It's not even that real. It's not even. I'm not really. I like watching gameplays. People play scary games. I cannot play them myself. I cannot do it. Oh, okay, cool.
Where's the candy?
I was wondering.
No
You
candy.
want the candy.
You
We're
are.
eating Inferno, so no candy. Maybe it's like,
Wait.
okay, so yeah, that is the end of our world. Okay, I'm going to download this so we can have it. Yeah, that'd be cool for later. But yeah, and then we can keep creating worlds, and you can remix. We could have remixed that world. Like I said, we can add. Okay.
Add candy.
We can add images. I do not have a candy image. What do I have?
Your grandmother.
What is it?
You put your grandmother.
Don't put your grandmother in there.
My grandmother. I know this is. Okay, let's take this. I don't even know. I think this is a controller.
Mm-hmm.
On a controller. Wait, dang, it's, all right, here we go. Bacteria. Bacteria on a controller, that's just what we'll have. And this time I'll do it in first person. And let that world create. And, oh, that's pretty fast. I didn't expect me to do that. Okay. Let's see. Oh, so it totally changed everything I had. And look at here's my little bacteria. Oh, I thought that was the other thing. Oh. It's interesting that bacteria is like this ball of light.
That bacteria seems way too soon.
I know. Like Osmosis Jones or something.
Yeah.
Interesting. Maybe I can follow this other thing. Where's that going? I just feel like anywhere. Okay. Okay. I don't even know where the controller is. I don't even know how to get back to it. That's the end of it. Our journey. So you get these 60-minute sort of interactions. I'm going to download this one too. So let that download. Great. Let's go back to Marvel. Okay, so we had from Genie, we had a candy shop.
Infernal.
And we also
Slides.
Chutes and ladders. All right, great. And so the cool thing about World Lab is that you can insert videos in here, and you can also insert 3D models, and then you can insert images. And so if you have multiple perspectives of a space, you can insert those in here, and then it'll try its best to come up with reasoning for what the depth of that space looks like. So while that's generating, because it might take a little minute, keep going. Okay. So the hybrid stack. What I've been seeing, let me bring this over here. What I've been seeing is there's this guy. He's the lead design at World Labs, and he has created this entire pipeline for using World Labs. So you create the world in World Labs, then you use Spark.js, 3D.js rendering pipeline, 3.js in Rapier, real-time interaction and physics. So he made this entire world in World Labs, and then cleaned it up. And then something else that he's been doing is he's actually been utilizing Claude Code to actually code all of this for him. So he can develop the world, but instead of having to get into the technicalities of actually coding and setting things up, he's using Claude Code to run these coding languages. And it's actually really cool him speaking about his different pipelines. I think I can show you guys more examples of what he's building. This isn't necessarily a world, but he did this really cool thing where you could put the world in a box. He used APOL, RP APOL. If anybody doesn't know there, I forget that. What else? Yeah. So he's done a lot of cool things. And I just think that's such an interesting pipeline shift. And so I wanted to bring that up. Okay, what does this mean for artists? Okay, so again, going back to this, I think that artists now are at this really cool time where we can actually start thinking about the worlds that we build not as just films, not as just literature, but actually giving them depth and reasoning similar to how game artists are already doing. And I think that that is actually really exciting territory to be in. And yeah, I'm just excited to see what worlds people do decide to build. I know right now it seems janky, it seems like all this stuff, but the fact that we're getting closer to actually having this depth for different things that we've built is really, really exciting. Okay, so let's get the slide. So yeah, basically that is the end of my piece. Hold on, I want to see if the Marvel thing loaded. It's still loading, so it's all right. But that is the end of my presentation. So thank you very much.
You talk about cleaning it up. How do you clean it up?
I've seen people clean it up in like Blender or Unreal Engine. Like I've seen them take these flats. Like actually, I'll show you guys because we can actually do my list. So this is something I created in World Labs, and I mean you see how this is crazy. And people are essentially cleaning these up, or they're using a tool called SuperSplat, and they're placing it in there. SuperSplat is an open source tool. So yeah, that's one example. Anybody else? No? It's okay.
Thank you, Laila.
Thank you.
Good morning, everyone. I'm really proud today to introduce Satish Santi. Satish is with us from AWS, where he serves as a principal analytics specialist solutions architect. He's actually one of our hometown heroes, just living a few minutes from us here at KSU. And he has 2 decades of experience in building data assets and leading teams to solve complex problems, including ones that involve data platform programs for banking and insurance clients globally. I want to make a note about this presentation and also the presentation that Satish will do later today. So for this presentation, we're super proud to be partnering with AWS as a sponsor for Transformer 2026. And one of the things we're most excited about is bringing in this type of expertise, this type of problem-solving acumen that Satish is bringing to us. And to just preview what's happening later this afternoon, Satish will also be providing a workshop. And this workshop has a little bit of homework attached, where if you want to participate in the workshop later this afternoon at 3 p.m., you need to create a builder ID in advance. And in order to do that very quickly, you can just go to the workshop on the schedule on the website, and it'll have a little click for how to set up your builder ID. You can also go to taig.dev website/AWS for all the information. With that, I'd like to welcome Satish Santi.
Hello everyone, hope you had a great event yesterday and you'll be having a great event today. And thanks for the introduction. This is a different world. How many of you are data analysts or deal with data? Okay, a few hands, okay, great. So, but it gives you a different perspective what goes behind the games. This session talks about how you can do game analytics. Let's understand a bit more on how the world is changing in this space. We'll start with a persona. Let's assume you are a game analyst and that's your persona. The first thing is you are given a task to analyze a game which you never played. It's pretty possible when you get into organizations, you will be given tasks to analyze games you never played, you never seen. So what do? This is your first challenge. You don't know anything about the game. Naturally, what you do, you will go ahead and do some search and understand the game, probably learn about that game, 200 level knowledge, and get some basics about what are the players in the game, how the game is played, how the game is won, and all those details. But is that good enough for you to perform game analytics? The answer is no. So what you need to know is, you need to know about the metadata of the telemetry that is generated by the game. You need to know the metrics. You need to know how the different parameters play out by different players to know who is performing better. Do you need to do any tuning? And what are the bugs involved? So for doing all that analysis, you need to know about the metadata. And it doesn't end there. You also need to join your data with other data sets in your organization. So alone, the game telemetry alone will not solve the problem for you. You also need to know the metadata of other reference data that is available in your organization. So your natural response is, okay, I have a data model, I'll check the data model. And how many of you know what is the data model? Okay, great. If I'm using some terms which are completely not known to you, please stop me. We would like to make it, more relevant to you. Okay, so you'll check the data model. But based on my experience, and most of us who are in analytics world and data world for this, data models are not always up to date. And that too in the current world, with the way the data is drifting, keeping data model and relying on data models is not a dependable source for you, right? And technical metadata, operational metadata, business metadata, you have so many sources, but you cannot rely on them completely. And I'll share my personal experience. I was working for a bank and somebody named a table as Bob_table. What exactly is Bob_table? Nobody knows in this world what is Bob_table, right? So that's the kind of metadata we are dealing with, and that's reality. Don't assume the world is perfect there. So what do? This is exactly the problem we are planning to discuss in this session. How you can work with data sets which does not give you much information, but still you need to perform analytics on top of it. If I need to put everything in one single sentence, how the world is shifting, particularly around game analytics, not just game analytics, any analytics, right? It's no more dashboards, it's no more canned reports, it's no more interactive reports, right? It is a conversation. So you need to have tooling and skill sets to have a conversation with your data, not query the data or write programs around it. That's all. I'll not say very old. We have people still using mainframe, so I'll not say very old. But it is definitely not the way the world is moving forward. So let's learn how you can have conversation with your data. I'll talk about a solution so that you understand the whole technology in the context of a use case with a perspective, right? You are all gamers. I saw the prior presentations. You are so high-tech team. It's like a different world for me. How many of you know League of Legends? Probably yeah, I can understand, right? It's like probably a very basic game for you, but it's a big game for somebody like me who comes from a different world. So I'm using that as an example. Let's say the game is played, the telemetry is generated, and the kind of telemetry that gets generated is you have 2 teams and they have 5 champions, and each of them try to win over the other's nexus. That's how the game is played, right? So all that telemetry data is coming in. The first thing you see here is Amazon Kinesis data streams. It's a service offered by Amazon to pull the data from a variety of streaming sources and load it into different targets. And the first target I'm showing here is a Amazon Redshift, which is a cloud data warehouse used by organizations to process petabytes of data. It's a massively parallel processing cloud data warehouse engine. And many customers use that for game analytics. All the data, the telemetry data comes real time into Redshift. And once the data comes in over there, can you start analyzing the data? The answer is no, because telemetry data needs to be paired with other data sets in your organization. Then that adds value. Something like your players' prior history, their bonus packages or payments, or it could be something like how they played in last season. All those metrics comes into play, and they will not come via your telemetry data set, right? They'll be coming through different sources. So you need a path with which you can get the data from apps, devices, and other data structures into your data warehouse. Right? And typically in analytics world, the way we do that is we will collect all these kinds of data sets into cloud storage like S3, and then we will load it into your data warehouse. In this case, it's Redshift. Going back to our persona, you as a game analyst, you don't need to do any of these things. This is mostly already streamlined. You have pipelines created, the data is coming in, and everything is collected in your database. That's the starting state for you. Then what you need to do? You need to have conversation with your data. That's the whole purpose of this section, right? And there are different tools available for you how you can effectively do that conversation. So I'll be talking 2 of those tools. The first one is Amazon Bedrock. How many of you know what is Amazon Bedrock? Okay, only one. All right, then we should do good job in gaming industry to tell you what are the tools available to you. So Bedrock is a fully managed serverless service which will help you to create generative AI applications. So you have access to different LLMs, and LLMs I'm sure you must be knowing it, right? What is an LLM? Okay, great. So you have access to Amazon native LLMs and other open, other third-party LLMs like you have DeepSeek, OpenAI, Gemini, Meta, all kinds of LLM models are available for you to just use it without you not worrying about infrastructure. But that's what Amazon Bedrock is in a very quick introduction. And then there's another tool I would like to introduce is Amazon Quick. It is a generative BI platform. Traditionally, it was used by organizations. Even now, organizations use it for BI, business intelligence dashboards, reports, canned reports. Let's say somebody played a game in a season. You want to present what is the revenue out of that game in that season. Is it better than prior season or not? All those reports are generated using Amazon Quick. And Quick is transformed recently with all generative AI buzz, right? To give you interactive abilities and conversation abilities where you can create chat agents on the data with just click of one button. Right? It made it very, very easy for you. We'll see a demo. So that's the solution we will walk you through. So the first one is a stream telemetry, where you get the data from different devices and you collect that to Kinesis data streams and load it into your database. So I got a little demo here. We can see what is Kinesis data generator. So I cannot play the game here live. So I kind of created used a data generator which will stream the data into Kinesis stream. So let's go ahead and run that. I'm just logging in, AWS user, and this can be anything, right? It's just simulation of the game. The first thing you should select here is in which region you are operating. AWS operates in different regions, and I've selected US East one. It automatically populated game telemetry as a source, and these are the different metrics. I'm just giving a template and generating a random data there. And so you have champions and their metrics, and you click on send data. So now the data is going into your Kinesis data stream where it is collected and pushed to Redshift. And these are some SQL statements. You don't need to know the syntax. All I'm trying to tell you here is with just 2 SQL statements, you can create a pipe which can automatically refresh the data and pulls it from the stream. If I keep checking if the data is there, okay, it's not there yet. If I keep running it, start seeing, yeah, I have 1800 records. If I refresh again, let's see 400. So the pipe is working and it keeps pumping the data, and you will put the basic metadata, whatever the metrics you put it in the template, and if you run a simple select star on that, you will see, okay, this is the game ID, when it was created, duration, season, and this is all generated data, may not be real data. It's just for the purpose of this demo, I generated this. Okay, now we have the data landed in your cloud data warehouse. The next step is getting the other reference data. What are the tools available for you to get additional data from any SQL engines or from other apps? It's a pretty straightforward one. There's nothing very complex about it, right? All you need to do is just run 3 copy statements which will copy the data from S3. So there are 3 different sources here. I loaded all the data, and if you just run select star, it will show you the different players information, what is the champion ID, the title, the summoner level, and all of that, right? I'm not putting more emphasis on these because for this group, this is not the main thing, right? Because this is already prepared by a data engineer for you. You don't need to worry about it. So we are just combining champion IDs and names with simple SQL statements. And if I run to see how the data looks like, you will see that, okay, I have champion ID, champion name, and the summoner level, and all the other telemetry. So far, it's just to tell you how data comes in. You may not be too much involved in this exercise, but you need to understand this, how the data comes in. Right? So data is prepared, and not a lot of aggregation or not of joining, nothing of that sort happen. It's a plain data which you pull from different sources. The real fun starts here, conversation. This is where you may want to understand what is possible in the data world. The first thing is Amazon Bedrock. The console you are seeing right now is Amazon Bedrock basic standard console, which you log in. If you log into AWS, you see all of this. The way you make your data available to an LLM is through knowledge base. We use the word knowledge base. Knowledge base is essentially, do you understand what is RAG? Okay. So it's like you need to give a context of your data to a large language model. If you don't give context, it will just operate with the trained data, whatever the data it is trained with, it will give you generic answers. But if you give your own data to an LLM, then it will be contextualize it and work on your data and make it much more relevant to you, right? So that's exactly what we are doing by giving knowledge bases. What I did in this demo is, whatever the data we pulled in from Kinesis data streams, the telemetry data that we generated, and other reference data as a data set to an LLM, and start talking to it. Right, so I'm scrolling down, that's where the knowledge bases are. I already configured the knowledge base. If If you look at it, it's Teams telemetry, and then it is telling that this is a knowledge base name, status is available, and the source is Redshift, and this is the Redshift cloud data warehouse. Right? And there are so many other knowledge bases you can create. Usually, whenever we pump in new data, you should always sync your data with latest and greatest, and you can automate it completely. You don't need to do through console. You have Lambda functions and different ETL pipelines which will automate the process of constantly syncing your data, so you always query latest data. The sync process is complete. Let's go ahead and talk to the data. So you need to select a model which will help you to understand that data and put it in perspective. There are Amazon models, and then for this demo, I'm picking one of our partner model, Anthropic Cloud Opus 4.5. Just apply. It's ready for you to query. So let's ask the first question. So how many games are played in season 2? I'm not writing any code. I'm not writing any SQL. I'm just talking to my data, right? So there are 228 games played this season. It automatically generated a SQL for me. If I want to look at it and understand it, I can do that. So let's understand, can you give me list of distinct seasons and the number of games played in each season? So again, go and query the data. Let's see what we get back. Okay, there are 9 seasons. 7, 8, 9 seasons have more games than 1 to 6. It also gave insights, not just plain data, it gave you an insight. If you query, you will get only the data. Now we are getting into the team level details. We understood the seasons. So you want to know which team won most number of games in season 8. Okay, season 8, team 2 had the most with total of so and so, and this is the sequence. Right? Okay, let's drill down further. You understood seasons, you understood teams. Now let's get to the player level details. Right. So which champion has the highest stamina level and how many games the player played? So if you can relate to it, now it is going across data. It's not only telemetry data, it is going against your reference data also. And it got back, Jana is a player with maximum level as 29 and those 205 games are played. Now I would like to understand what is the total duration of Jana across all seasons. Again I'm going with multiple data sets here. Okay, the total duration is 3 million seconds approximately. Let's break it down by different seasons. I think that's the next prompt I passed it on. Let's see. Yeah. Can you give a breakdown of game duration of Jana by season? Yeah. Okay, it's thinking. Alright, came back and it says season 1 the longest game duration and season 2 has shortest duration and the average duration is also. So what I'm trying to tell is by this demo you can understand that you didn't write any SQL, you didn't write any code, you're just talking to your data. That's the tooling it is evolving towards. And the responses are also in natural language. Though you see a structured response like rows and columns, at the bottom you also have insights given to you in a natural language. If I am a game analyst, I really love it. But if I'm a business user, it's much more helpful for me, right? So that is what we would like to try. Before I show the next demo with Amazon Quick, which will be probably 3 minutes, I would like to pause here and see if you have any questions on this experience.
How do you verify your data? Great to have a conversation, but how do you verify that?
Great question. So Bedrock has ability for you to provide explainability and also accuracy of the responses. So all that is baked into Amazon Bedrock in terms of observability, right? Both in terms of your build activity and also in production. You can have real-time observability of is your model drifting, how much accuracy you have. So if you ask me, am I getting 100% accuracy? If your data is consistent, you will get 100% accurate. But if your data is kind of fuzzy, you may not get it.
We actually had a very good conversation yesterday with the KSU esports team, and part of it focused around the tools, the AI tools for League of Legends. And one thing that they said was that they didn't feel these were valuable for the players because the players didn't know the right questions to ask. They needed to have them with a coach's guidance. Do you see a way for these to help guide a user toward understanding what information they should be getting out of all this data?
You helped me actually for the
Okay,
next demo.
good enough.
Right? The next tool will help you to provide those leading questions like, hey, this is your game. Do you want to analyze this information? It will help you what questions you should ask your team. Particularly for me, somebody who doesn't understand this word, it's very helpful information. With that, Pablo, you have a question?
That's okay.
So let me go to the next demo, and that question will anyhow get answered. Okay, this is the console for Amazon Quick. It's a typical BI tool console. At the bottom, you will have the standard dashboards and data sets, and at the top, the new generation of capabilities like chat agent, spaces, and you can do research and create business flows. So that's how the world is evolving. The way we provided data to Amazon Bedrock was through knowledge. But for Quick, how you provide, you create data sets. These data sets, you will hook it to your cloud data warehouse, in this case Redshift, and that will be available for you to start querying it. So let me go ahead and start with Amazon Quick. You can create chat agent. It's just telling the different capabilities. Let's go ahead and create a chat agent. Yeah. And all you need to do is you need to provide a persona for the chat agent. So I'm telling you, you're a game analyst, you need to analyze League of Legends game telemetry data and click on generate. I spelled it wrong. Let's see what it will do. It will give instructions also to the agent based on very loosely given prompt. I don't need to be a perfect prompter here. So it said, you're a professional game analyst and you have deep expertise in interpreting gameplay metrics. It is telling the agent this is how you need to think, and then it automatically hooked the data set that is available for it. It understood I'm talking about League of Legends, and it picked LOL game telemetry, and if you click on launch chat agent, it is available for you. Let's ask a question. See, at the bottom you see all the questions it is showing and giving you the lead. You don't need to necessarily start with a question. You can use an existing question. Here I'm asking, can you give me a summary of games played in season 2? In this persona, you see the thought process it is going through, like how it is querying the data, what metrics it is collecting, and what data sets it is scanning through. All that chain of thought is clearly visible to you in the chat window. So once it completes the analysis, it is coming back with results. Okay, this 228 games are played in season 2. And let me pause here so that you can have a good look at the insights and we will start. Alright. So those many games are played, and what are the different metrics? I don't know much about these metrics. Probably you can easily relate to those metrics. The key part is the insight. It is saying that it's a season 2 is a very competitive play. There's very competitive matches were played, and there is a intent to secure first objectives, and that inference is based on first narrative being achieved slightly more frequently than first blood and first stop. See the kind of insight it is giving on your data without you writing any kind of code. And I don't know, I didn't say that you should understand this metadata, and I didn't provide any metadata to it. I didn't say what is T1.champide means, what is T1.baron means, T1.kill, nothing. So it automatically, based on its LLM knowledge, it plugged it complemented that with the data set that I gave and gave the insights to it. And at the bottom, to answer your question, you can see that, hey, would you like me to analyze specific champions information, or do you want me to compare season 2 with another season? It is giving you those leading questions. If you don't know what to ask, you can just follow the conversation and it will guide you through how you can learn about the data. So let's go ahead and ask one more question. So I'll go with its suggestion. I would like to compare season 2 metrics with, let's say, season 8. Let me go ahead and ask that. I think that's the next question I asked in the demo. Yes. Yes, please. I usually respect AI chatted. So I say, please, I don't use that word. Please, thank you. I follow same nice speech here too. Please compare season 2 metrics and season 8 metrics. So doing all that analysis. What are the metrics it analyzed for season 2? Same thing is doing for season 8. Right, so it should come back pretty quick. Okay, so based on telemetry data analysis, compared season 2 and season 8, if you remember the data, season 8 has more games. That's what it is telling us. Season 8 has more games, and the overall scale of the games played increased, and the duration is also increased, the game length. He's telling that objective importance has changed, high volume of games, but the average duration remained. And it's again asking, do you want me to compare team 1 performance with this team 2 performance across all these? You can keep talking and you can keep going with the analysis and give a perspective. At the end, you can ask this tool to create a report which you can send it to your executive. Let's say you were given the task of analyzing this game, you understood different metrics, and you work with LLM to understand the way the game was played. At the end, you need to produce a nice dashboard. That also you can do, and you can keep working it as if your buddy. Right? So I'll conclude here. If you want to learn more in this space, we have a blog on how you can use these technologies for game intelligence. And this is a solution which we built and given to all our customers so that they can have a head start and they don't need to spend a lot of time in setting up all these pipelines, right? So they can get started with their core business, like how I saw in the prior session. Right? So with that, I conclude. Thanks again for giving us the opportunity. Really, really appreciate your time. So I can take any questions. I'll be here for the next session. If you have any questions.
So I've used a lot of traditional RAG before, and one of the problems I ran into is the hallucination factor of asking for something that's not in the data or in any of the resources. Do you guys have any secret sauce in there to keep it from, like if you asked it like, well, how many Ferraris were played in League of Legends? And then it would just be like, oh, that's the great question, 30. Where there are no Ferraris. Do you guys have anything for protections against that?
Yeah, that's a great question. And this is a standard question we get from enterprises, particularly not from games. Games also we get this question, finance industry, healthcare industry. They're super concerned about what guardrails we have in place. Amazon Bedrock even quick. Amazon Bedrock has a feature called guardrails. The name of the feature itself is guardrails. So you can say that what it should not go beyond your data sets, and if it is, how it should respond to it. So you have the ability to define the boundaries for it. Even if we tried that question, what you asked, it will say, sorry, I don't have this data, because I asked it to limit the responses based on my data. Yeah. So the blocks I gave you will help to understand more how you can implement those guardrails. Thank you.
So the natural progression from that, if I were to hand that to a designer and say, here you go, they look at it and go, yeah, this character ABC needs better balance, so their OP for whatever reason. Can you tweak the data, essentially say a what if scenario, like how would we balance this data in order to create a more even gameplay or even up the matches? So right now you're showing pure analytics, but can you do any projections?
Yes, you can do. That's where LLM goes with its own trained data, not your organization data. It's for all this data that I used here, when I was doing more analysis, it was telling, hey, your data set has some anomalies. Do you want to regenerate and augment that generated data with additional data sets that are available in the market? So from different universities that are public data sets available, it wanted to augment my data and make it much more realistic and enhanced. So it will give me a projection as well as If there are any gaps in data, you can suggest alternatives to me as well. And you can also ask goal-seeking questions. You can say, how can I add additional bonus packages for, let's say, champion to have more stickiness with the game? Let's say on this data set, you identified that champion 3, game duration is so low, the affinity to the game is so low. You can ask, how can I make the game duration increase for champion? Then you can look at the player history and what actually excited that player when the player jumped from one level to another level, or is the player stuck at some place, and it can give you a recommendation that probably you can offer this, and that will help the player to move forward and get more excitement around this. Yeah. Probably I may not have given you the right example, I'm not a gamer, but I just wanted to give
That's close enough. It was about, yeah, the idea was, how do we, if we were to create it, can you project what the data set would look like if we made this tweak?
Probably we can play that. If you have break time, we can do that on the
Yeah, I had a very quick question. So you use the example of the multiplayer online game, right? But have you tried this tool on, like a self-contained story-driven game, for instance, or where the data that you get is more like the choices people make rather than
Please repeat the question for the mic.
Would you like to probably come over here and repeat the question so people can?
Yeah.
Absolutely.
So I just don't want to say something which is incorrect with the terms and terminology, because your folks, when they hear the recording, they should get the right question.
So very quickly, my question was, you've used the example of a multiplayer online game. And most of the data that you're using here has to do with player stats and all of that. I'm wondering if you've also tried using this tool on a game that is more self-contained, for instance, where, I am thinking, because that's what I study, right? But like story-driven games where people make choices, and like, can you use this kind of tool to analyze this data, which is not about player statistics, but it's more about like, what do players do inside of the game?
That's a great question. Probably I may need a bit more input from you, right, to answer that question. So when players make those transformations or the traces you talked about, again, I only understand the data world. How that translates into data? Is it like gets stored into some text or images? How does that get stored?
Well, so usually they would make a choice, right? So you would have like, oh, do you want to do this or do this? So I'm guessing it gets stored. I don't know. I usually run my research on like participants, right? So I don't have access to the data.
Got it.
Because it's usually owned by private.
So I'll talk about my experience working with some of the well-known gaming customers, how this transfers. They get data from different game studios, all this data comes in. And not everything is like the stats you talked about. It's not like so much numbers, right? We get data like a voice, we get images, we get videos. Some of our partners, I saw a demo by Razor.ai, must be familiar with some of you. They capture some video clips of the game and they send it to us and asking, can you analyze this video clip and suggest, is this game having any bug, or is the player cheating the game, or is there any teleportation there? All that analysis comes, the feed comes via images and videos too. And these models that I showed you, they can process that. So yeah, not just plain data. It can process variety of sources. Thank you so much. Thank you. All right. Hopefully, I'm still on time. Thank you all very much. Thank you.
All right, so Timothy Johnson is not a stranger to our Siege and GGDA events, but he's not been around for a little while. We're glad to have him back. I know you're going to talk a little bit about what you've done in the past, but I want to talk about part of why we brought him here. People talk about AI tools being used to separate people, make people feel more distance, create less social experiences. But what has been great about all of Tim's work in the game industry that I'm familiar with is it's always about creating more social experience, whether it's been his work with Will Wright, about creating a very social, gamified situation, or what he's been doing since with Discord. And we had him show off some of his earliest Discord games in the GGDA servers, bringing together a lot of our people to enjoy them, play together, and interact in a cooperative and not so cooperative way. His have been great tools and games for bringing people back together. So I think that exactly what Tim does with games is a great argument against the idea that AI by itself is what keeps us apart. It's how we use the tools and what a good game designer can do with them that makes all the difference. And with that, Timothy Johnson.
Well, thank you very much, Andrew. Good morning, everyone. Thank you for joining us on a Sunday morning and after a very late night. Timothy Johnson, I used to live here, as Andrew just mentioned. I moved to the San Francisco Bay Area about 13, 14 years ago. And I'm here to talk about how to run AI games at scale and not go broke. And I'm going to tell you a little bit of a story of what I've been up to and how much money I have spent. Okay, so quick agenda here, intro. We're going to talk about catching lightning in a bottle, which is what everyone wants. The scaling challenges we had with it, keeping up with player demands, the future of gaming, and then maybe I'll say thank you. Can I just hit this? I can. So I am the CTO of a company called Little Umbrella. We're a startup out of San Francisco. We started about a year and a half ago, and we kind of had a breakout game as me and two other co-founders. I've been in the startup game for a while. I've been making games in California for a very long time. I know a lot of people. We were able to get off and running, VC funded, and we're now in year 2, and we're on game number 5. Previously, before I got into this enterprise, as Andrew mentioned, I went out to California to work with Will Wright. He had just left EA and he started Stupid Fun Club, and he said, "Why don't you come build weird toys with me?" So that's what I did. I left that and went to WB Games, where I was technical director for about 5.5 years. Worked on some really cool stuff, Harry Potter, Lord of the Rings games. Actually worked on the sequel to Shadow of Mordor. I got to work on Nemesis System a little bit. We all griped about how it's patented. None of us liked it. That was not our call. And the Westworld game was like, I don't know about you, but I love season 1 of Westworld. I'm so glad they never made any other seasons. And working on that game was really cool, got me thinking about robots. And then in 2019, Will, this is a little bit of a history lesson, Will called me and he said, "Hey, and a year and a half ago, Google did something impossible." And that's actually what our little event here is called, Transformer. Google had come up with the Transformer that actually made everything that's happening now kind of possible. And so he had always wanted to create a simulation of yourself. He wanted to make The Sims be super real. So I left Warner Brothers and started Gallium Studios, and we started working on Proxy. Proxy was a simulation of yourself. The idea is that you would feed it your memories and that it would build a model of you. We had this gigantic graph database. We worked with Stanford engineers. We did all sorts of really cool stuff. And at the time, in 2019 and then 2020, we were actually contributing. We had a couple of data scientists on the team. We were contributing back to OpenAI back when it was OpenAI. We worked on the Da Vinci model. And GPT-3 was like the coolest thing that we had ever seen. We chased this for a very long time. Will spoke as a keynote at Siege. Andrew was cool. We did lots of stuff. Unfortunately, it's one of those games that was so big and so massive that a startup couldn't pull it off. And so, Will, a little meme here for you. Tell me how the simulation's going. Good. Now tell me in 2 words. Not good. So ended up leaving there, and then kind of at the end of my time with Gallium, I was CTO of Gallium, I started thinking about Discord really, really hard. They had just added the ability to have bots. They had just added all sorts of really cool things. And I really thought that was going to be like the future of gaming. I talked to Andrew about it, and actually, here we are. So he brought me out here for DreamHack, and this was like the pilot program of what you're about to see. So we just kind of set up games within Discord itself, playing games within Discord. At the time, it was like / command based. It was pretty rudimentary, but the cusp was coming, which would be Discord activities. And then shortly after that, about 5 months after DreamHack, we launched Death by AI. Death by AI, this is our lightning in a bottle. We released it on Discord as a Discord activity. If you're not familiar with Discord activities, it's basically a shared surface that you can all play right in Discord. And what I love about it is that there's no install, there's no friction of having to actually download things or trying to chase people to install your mobile app. It just loads because it's all WebGL inside this shared browser. So when I say lightning in a bottle, we hit some pretty big metrics really quick. This actually is slightly out of date. We're well over 60 million players on Death by AI now that we are about a year and a half in. But we hit 5 million players in the first week, and we hit 20 million players in month number 3. Discord being what it is, it's 200 million monthly active users in Discord, and with the accessibility of them just being able to press a button and play it, we kind of took off. Our own personal Discord server, we went up 140,000 people in the Playroom. You're going to see Playroom and Little Umbrella. Technically, we're both the same company. Playroom's like the tech that we do, and Little Umbrella is like the game. So you'll see that back and forth. And this was just some stats on like our group sizes as we went. So when you have a Discord game go that big, Discord invites you over. So this was us. They brought us in as a premier partner. We were the biggest game on the platform. So we got to hang out there, actually work with their engineers to find ways to improve the activity and find ways. They didn't even have like a marketplace or like a way to really search. So they started putting lots of work into the different surfaces, being able to find other games as other games came online, as they started pushing the activities. This was GDC last year. This was really cool. They built the coolest blockbuster that never existed. And it was cool. It was like it had Wii games. It was a really cool thing. And that's me giving a talk in the Discord booth. That was pretty fun. I added a bunch of like personal stuff because yesterday's, if you guys didn't see Mehdi's presentation yesterday, his PowerPoint game is so good. So I just added a bunch of stuff. Okay, Death by AI. So figured you guys would like to see some videos and some trailers and stuff. So this is the trailer for Death by AI. Hopefully the audio will come through. Oh, it says beta. That's a very old trailer. So the premise of the game, I had spent so much time building an incredibly serious mental model of yourself, people pouring their hearts out with memories. I was really interested in doing something silly. So the premise behind the game, it's very straightforward. The AI gives you a prompt of some sort of scenario. You're being attacked by 100 ducks. You are in a car, you just went off a bridge in the water. And you and your friends type in how you're going to survive. This is multiplayer up to, I think it's 12 now, is 8 then. And everyone, you only have like 140 characters to enter your response. The AI will then come up with the scenario and tell you what happened to all of you and if you lived or died. And then if you live, it's a social party game. I should have started that. We make social party games that are AI driven. Hey, how's it going? So it will tell you what's going on, and then you live or you die, and then you play 3 or 5 rounds, and then whoever lived the most wins. Spoilers, you almost never live. It kills you a lot. My daughter, she was 12 at the time. She's very clever. She found a way to win for like 2 weeks in a row with her friends, where every time she was faced with a scenario, she would say, well, I've got my backpack filled with kittens, and I'm holding all of my adopted orphans. And the AI didn't want to kill her, so she kept living. Where are we? Okay, I should have had this slide up as we were going. So this game, as I said, this was like our lightning in the bottle moments. We got millions and millions of players. This is all generated, obviously, AI generated in real time. And more talk about our integration with Discord. So I kind of already covered this, but putting all of our games in Discord gave us this really large audience. I'm going to skip this slide. I'm going to come back to this slide. This is what we won, really. So congratulations, and actually this was mentioned in yesterday's keynote of like the punishment for having a really good AI game is that you're going to burn all of your cash. So how did we combat this? So let's tackle it in twofold. So when it comes to traditional game development is such a weird thing now because there's like 5 different versions of traditional, but in the late aughts and then the mid-teens, microservicing became like a really popular way to do your architecture. There was lots of Kubernetes clusters of people doing these microservice blades, and that's what we did at Warner Brothers. That's what we did at Gallium. That's not what I did with our infrastructure. In fact, if at Warner Brothers, if any of our games had hit like 20 million players in like the first month, we would have spent hundreds of millions of dollars in our AWS costs. So what we did here is we actually leveraged all of edge computing. I kind of was able to get away with this because the games are so lightweight. They're WebGL games where there's a really thin client running there. So I was able to leverage all of the edge providers, from Cloudflare to the replicas to all the different edges. And what was really cool about edge computing is that as we were worldwide, and with Discord, I'm going to back up a slide. In Discord, you have no idea where your players are. Like the groupings of people in Discord are, who knows where they are geographically. So with edge computing, it will actually pick depending on which provider you're going through, it'll pick the closest edge to all of them to give you the lowest latency. And then, using Vercel and other types of like edge platforms, we're able to run the compute, and we didn't train any of our own models here. This is all using consumer APIs. So I didn't have to like run any kind of really hardcore cluster. So that's how we're able to pull off the scaling of it. Going back to in Discord, this is like really cool, but this is also like one of the problems is that any surface in Discord can show or play one of these games. So it can be in a DM, it can be in a voice channel, it can be in any of the chats. Basically every surface becomes a place where you can get 2 people connected. And so that became like the first problem of scaling. So with this game, we're tackling 2. We're tackling like just your normal everyday infrastructure of running a game that everyone does. And then the next one, which is the AI costs. Okay, so to do this, all right. So we had no idea this was going to do what it did. It was not a one-off, but it was unexpected. We had no idea it was going to get as much adoption as it got. And so that first 3 days, we spent $14,000 on OpenAI. And for the voice, we're using 11 Labs. We don't use either of them anymore. And also another interesting thing, this has gotten a little better. So this information is a little bit out of date, about a year out of date. But one of the issues that we had was being worldwide. It launched on OpenAI models and 11 Lab voice. And there are parts of the world that are not allowed or were not allowed to communicate with the endpoints. So even though we were kind of like moving around on the edge network. If the edge was coming from Brazil, they couldn't communicate with OpenAI at the time. So we had to quickly do like a 48-hour jam session where we started putting in all of these different endpoints for Replicate, OpenAI, InWorld. InWorld became our biggest partner. InWorld is a fantastic partner. They helped us out a lot. So we had to put in really fast algorithms to figure out, and of course the easiest way was try it, you get some sort of 500 error, try something else. That was like the inelegant solution we put in at the beginning. So how to not go broke? How did we not spend all of our money? So the first part is our multi-provider inference strategy. We instantly started talking to everybody who had an API. Everyone that had any sort of LLM that could possibly work. We all became biz dev people very quickly. And what was interesting, and I think this is still true, is that if you've got traffic, if you are generating a lot of tokens, then they are very interested in talking to you, and they're very interested in cutting a deal, because it's kind of one of those, they're looking for customers and we're looking for lower prices. So we were able to really take advantage of being early and being kind of first here, to where we could kind of move around and negotiate a little bit, because everyone wanted their name on our placard. Agnostic prompting layer. Now this, with Death by AI, this was maybe mid-cycle, and this is now something we've adopted with the rest of our games. I'm going to show you some other games here in a minute. So the prompting layer, it comes down to like, what model are you going to use? Well, for anyone who's messed around with several models, whatever prompt you're using, you're going to get a very different outcome. And so we had to write tools that would allow us to change whatever prompts we were using for whichever game mode we are in. So like Death by AI launched with one mode, but now we've got Brotherhood, we've got Team mode, we've got a new one coming out that's called Two-Piece, which I really hope we don't get sued for. And so we have lots of different like scenarios and things we want to do with the game. Well, if you're going with Gemma, if you're going with GPT 3.5 Turbo, or if you're going with like 4.0, or if you're going with any of these models, your prompts need to be crafted specifically for it. And we started locking in, especially with InWorld, we were able to get like access to not just the general API, but like the specific models that we wanted. We tried fine tuning as well. I should probably mention that. We tried fine tuning with our data sets, and that really didn't work out for us. It was slightly more expensive, not that much better, and as everything continued to be scaled and more parameters are being added, we just went with the general models with specific context windows. And then the context became kind of like what Aaron was talking about yesterday with Retail Mage. The context becomes like your most important part, keeping that as you're moving through things. So everything was config driven. From runtime, anything on the fly could, the next game round, like in mid-game, we would do lookups to our configuration service, and it would say, okay, for this next round, you're going to use this endpoint with these models. And we would do that because we got a deal or it was cheaper that day. Dynamic model routing, like we built a dashboard, and this is where vibe coding kind of helped. We built a dashboard where we could get real time of what the tokens would cost of all of the different providers, even providers that we didn't really have a lot of insight into. It was probably lying to us, but it would tell us like who is the cheapest right now. And actually, I never let it do it by itself, but it was set up to where it could start doing that automatically. Instead, it would just ping us, and we hooked it up to Discord where it would ping us and mention us and be like, right now this model is like the token cost is 50% off for this week, and so we would just on the fly change to that. This goes to you may ask about like quality and like QA, like how do you know you're getting the right quality there? And this is the credit to kids on Discord. They are my favorite players so far. One, because I got lucky with them, but they are really receptive to trying new things. They're not as like antagonistic to AI. They're not as antagonistic to new things. They're very willing to try things, and the more it's screwed up, it almost like made it better. So they're the kids. I say kids. They're all kids. Everyone's kids. All the kids were just really receptive, and you get complaints, but nothing more than you would have gotten anywhere else. Config-driven endpoint, that's the switching. So we're switching all this stuff as fast as we can as we went. So this is one of the vibe-coded tools. This one is for another game called The Last Show. I'm not, the game doesn't have, we didn't generate the code for the game with AI. There was a couple of times where I did ask the AI when I had a weird bug. I should also mention that if you're going to do WebGL and for like running in Cloudflare or any of these edge, just be a nerd for an engineer for a second. So mostly I'm like a C-base kind of person, but to run in like Cloudflare or anything, it has to be JavaScript. And I have to say, thank God for TypeScript. It's JavaScript with static types, and I was like, oh, hooray, types. It'll tell me as opposed to just never tell me, and then there's an explosion. So vibe coding, so yeah, I'm rambling a little bit, but it's like sometimes there's a syntax in TypeScript where I'm like, I don't know what this is. And AI is really good at helping with that. But this was vibe coded to help us write the content, write the prompts. Very similar to what Aaron was talking about yesterday of like having like an orchestration of like 4 or 5 or 6 different things in a row to pull off your actions and your activities. That's how our games work as well. Like one prompt to just do something, we'll never do it. Our games are a little bit simpler since they're much more like call and response. They're very much more game showy. Think of like Jackboxy. Ours are more simple than what Retail Mage was doing. So lots of analytics, lots of dashboards. We set up our own like trigger system. So as we tried every single. One of the cool things about being a startup is that everyone gives you free credits until they run out. And when they run out, you just go to their competitor, and then they give you free credits. So for all of you wanting to start a game studio, do that. So we had to write our own like dashboarding layer, our own we call it HQ. It's our own backend for the games. And then we set up like our trigger system, our trigger events for everything. If we got a user, a spike of users out of nowhere, we would get alerted and we might switch to different models. If a model was failing or if something started to become deprecated that we didn't know about, it would start to alert us. And we use Discord as like our main, all of our like AI talks to us via Discord whenever there's a problem or something that we need to switch. Load and price reactive scaling. This was the hourly. There was one day where I think we probably switched between like 50 or 60 different models to keep the prices down. And the prices now, like as all games go, we have a huge surge at the beginning and then it starts to stair step down. Discord's a little bit different though, because the kids get out of school, and so you have another surge from like the end of November until early January, and then they all go back to school, and then you see a surge again because they're in class and they're bored. So you'll get these really surgy kind of things. But as traffic has gone, our cost for running these games is as low as it's ever been. Like some of these we're running entire days where we don't even spend more than $5 on the entire game. And that's for probably, our daily actives on these games are still pretty good. Like in the lowest, we're getting like 5,000 daily actives, but for the most part, we 18 or 20,000 daily actives for most of the games. And during the spikes, that's when you get back to the hundreds of thousands. Say it again?
Of users, not dollars.
Of users. We're going to talk about monetization here in a moment. Oh yeah, and vendor competition leverage. In-World has kind of won our hearts and minds, even though we still have lots of different vendors that we use. They really wanted our business, but also we're one of our main VCs is Andreessen Horowitz. In-World's main VC is Andreessen Horowitz, so it just kind of makes sense to like give them some favor. But vendor competition for you guys starting out, this is, once again, if you've got traffic, if you've got players, if you've got something, they will work with you to try to get you the best price. So how do we monetize it? So I talked about all the money that we're spending. Well, the monetization in Death by AI actually came a little late. Because once again, this was not expected. We didn't expect it to do more than like maybe get some press for us, maybe get our name out there a little bit. And Discord was also not ready for it. This is one of the things that we helped them work with, was to actually build like a marketplace where you could purchase things within Discord, create SKUs that could then be redeemed. They kind of had one, it was kind of working, and when this game blew up, and it wasn't just us, we led the front, but then like there were some other games that came out that were that were very big as well, and everyone was asking for us. The biggest issue that we found is that Discord really didn't want to share any money with Apple. So the only way you can do purchases on Discord is either from the PC or from their web implementation. Mobile, it tells you to go log in on your computer if you want to purchase something. So that was kind of a roadblock, but we brought in Death by AI. We started charging for that game. It was mostly voice. We wanted to keep that as free and as open as possible for everyone. So if you don't pay for the voice when it's doing its text and telling you everything, it's kind of a cute, like, there's some canned sound effects. We call the robot's name is Bobo. And he's got this cute, your fate's been sealed. It's cute. So we sell voice tokens. We have packs. We have sales for it, things like that. So that still brings in pretty decent money. It pays for the game, for the operation costs of the game. Not putting anybody through college, but it's doing good. In the other modes that we put out, we tried playing around with like doing not season passes, but like subscriptions to where if you get it, you can unlock everything, including all the localization. The localization for Death by AI only, or I'm sorry, the voice is only in English on Death by AI. But when we get to the other ones, which is The Last Show and Banana of Doom, we'll talk about here in a minute, the voice is, all the text-to-speech is in 26, 27 languages. It sounds really good. So selling voice options, selling tokens. When we got to The Last Show is very much more game showy. I'll show you that in a second. And so different rounds, different cosmetics for all the players, different avatars. It is a game show, so you can get different podiums. So things like that to sell. And then with The Last Show, we actually also have publishing deals with Amazon for their Luna platform, which they renamed to Game Night, and now it's Amazon Prime Luna Game Night. They keep changing the name of it. It's great. And then for Banana of Doom, which we did launch a light version on Discord, we have the big version that's going to be on Steam. We're going into Steam Fest tomorrow. That's more of a traditional card game, card packs, things like that. So most of our spend is in Discord. Most of it is through PC, but from our metrics, like 65 or 70% of our players are on Discord mobile. So we're hoping that they cave in and allow purchases through that soon. Where are we going next? So Death by AI was big. We're very proud of it. It's what allowed us to be to go from a scrappy startup that was pre-money into a VC-funded startup. We went through, Andreessen Horowitz brought us into Speedrun, which is their accelerator program. So, having 20 million players as you start an accelerator is really cool. It's kind of like, I remember Will Smith talking about when he was a senior in high school, he had the #1 song in the country, and he said that was the best year of his life. It was kind of similar for us. We were the coolest kids in school. And so the next game that came from it, that came after it, was The Last Show. With this one, we wanted to push the limits of like what we thought was possible. So this is a much more complicated game where it's keeping a much tighter context window. It knows who you are. It remembers who you are. We save data about what the players do. We don't do personally identifiable information unless they type in their home address or something, which I can't prevent. And so the game is very personalized, and it will start to make fun of you. This game is kind of mean-spirited. It's really good. And it will make fun of you. It'll joke with you. It will make fun of you as much as you want it to. If you want it to be nice and polite, it'll do its best. But we have 3 different AI personalities. The middle guy is Blip. He's kind of running the show. The guy floating over there is Brain Rot. He's the brain in the jar. And then not up here is Wild, who is our girl on the television. So here's the launch trailer for The Last Show, if you'd like to see that.
Breaking news. Robot has no chill. Run for your life!
Hello, captives. Get ready for The Last Show. And the loser is you! What are your chances of survival?
Sarcasm? That would be terrifying.
Choose your topic, beauty flesh puppet. Childhood trauma never leaves, huh? A possessed doll's catchphrase is, but who made the cut? You're toast. Bye-bye!
Saw you later.
And the winner is... Ouch. Can you survive the last show?
So that one really pushed the limits of it. Pretty fun game to work on. And yeah, we were able to take that and get publishing deals for that game. As I said, Amazon, Netflix is also looking into it, but then Amazon and Netflix, well, they're best friends. They'll work it out. So yeah, that was our next one. Not as big of a splash as, once again, Death by AI was lightning in a bottle, but we still, within the first month, we had already hit 2 million players. This game has been out now for about 7 months, and we're right about 9.5 million players for that game. Daily actives on that game are pretty good. They're somewhere between 8,000 to 15,000, kind of depending on the day. One thing I want to say about like party games, social party games, is that our retention is phenomenal. The retention on that game is no joke. I just checked it this morning. It is 41%. It is, people just keep coming back to this game. And I think it's really just the accessibility. You can play it in Discord with your friends. It's 8 players. You just jump right into it. Pretty fun stuff. Let's see. One of the ways, and this kind of goes back to keeping like an orchestration of how do you build these games in such a way that one is incredibly cheap to run, but also gives you high control over the content of your game. BERT-like models. So if you guys are familiar with embeddings, so when you think of AI, and this has been said several times, where AI is not one thing, it is many, many things. So we can kind of split what this game does into 2 camps. There's completions, which everyone is very familiar with, and then there's embeddings. What I really like embeddings, these are BERT-like models, or small BERT-like models, and an embedding doesn't give you back text. It doesn't, well, I mean, I guess it kind of could, but it doesn't really give you back text. It gives you back a score. And so this would be, back when these were first thought up, like Word2Vec was like, it's not exactly an embedding, but I think it's a really good way to conceptualize it. So you can have a set of 10 things, a set of 2 things, a set of 1,000 things, and they're all English word or whatever language words. And then you add a word, compare a word to it. It will come back and score usually between -1 and 1, how closely related they are. This is depending on the model, it is a multi-dimensional spatial array. So think of the one that we use has 1,500 dimensions. So think of like 3D space. This is 1,500 space, and it's really like how close is the word cat to the word dog? Well, they're probably pretty close, but wolf and dog will be a little closer, and apple will be very far from all of them. But you do get weird things where you'll have a bunch of colors, like you'll say like, purple, red, green, and then you'll say banana, and banana will score really high because banana and orange, it doesn't know the difference between orange, the color, and orange, the produce. So, but we use these to get comparisons. So when people, especially if it's going to be a binary choice, using embeddings to determine what the player is trying to do is a great way to do that. This is also a really cheap way to find hate speech. It's a really cheap way to find like super inappropriate content, because you have basically a word list of things that you do not want to show up in your game. And as they enter things, you then do a comparison, a lookup to an embedding, and it will give you a score. And if it just scores too high, don't allow it. And we don't reject it. We just put something in for them, making fun of them for trying to be really mean to each other. And that's worked out pretty well. And these are incredibly cheap. I mean, we don't spend, I think every day we spend a fraction of a penny running tens of thousands of comparisons. Now my data sets aren't that big. Like when I'm doing a comparison, it is 6 words to a list of 1,000 words or 30 words. So that's how we keep it. But that's one of the ways to keep your costs really down. If you're not familiar with embeddings, I would highly look into them. Completions are cool, but seriously, they're one of the worst tools for the things that you guys are trying to pull off. Okay, what do we got next? So Banana of Doom. I wanted to show this one too. One, kind of plug it because we got it on SteamFest, and we're launching right after GDC. But another reason is because one of the things that were coming up yesterday was, or throughout the talks, is what do you get the player to do? In Death by AI, they typed in 140 characters. They had to be very improv-y. They all liked it, but it is asking a lot of a player to type in a response. You're being attacked by 100 ducks. What do you do? And you're on the spot. It's very improv-y, and while people warm up to it, there's friction there. You have to like get them into it. With the last show, it's even less. It's still typing in some cases. We put a lot more word choices in to where cards would pop up that with kind of like pre-baked responses that they could use or remix on the fly, so it was less like they had to come up with something right on the spot. With Banana of Doom, we've taken the typing completely out, which I'm very happy to finally have a game where I don't have any typing. And so Banana of Doom, this game, once again, trying to use novel approaches to AI, it's got a real, you'll see, it's very Bull-Altro inspired with its deck, but you get a deck of cards, and each card has a word on it. And it's very similar to Death by AI, where there's a contest. It'll say contest being something like worst person to be stuck in an elevator with, or something like that. And then you have to combine the cards together. You have to draw from a pile, and then you submit them. And then we have a version where players vote, and then we have a version where the AI judges you. We call it Banana Judgment. So another novel approach. So I'll play the trailer for that. I thought people might like Sunday morning. I thought they might want to watch TV.
Banana of Doom.
And something interesting about AI is when you get into these games of comparisons, of judgments, of things like that, and it crosses models. It's from Gemma to 4.0 to DaVinci to the in-world models. Grandma's balls always wins. Something about that combination. And we actually talked about like either taking those cards or taking grandma and balls out of or keep balls in, of course, but take grandma out of the game or maybe sell it for a lot of money. Because for whatever reason, the AI can't get enough of grandma's balls. So that's our lineup. Death by AI, last show, Banana of Doom. We also published 2 other games that aren't very AI heavy, so I didn't bring them up. Banana of Doom is on Steam Next Fest. Lots of us have games going on Steam Next Fest. When we're out in the hallway, we should all trade and wishlist each other's, support each other. And that is it. I'm Timothy Johnson, and I would guess, thank you. All the way in the back. The question was, am I worried about the upcoming changes to Discord with the visual ID that they're going to be pushed starting in the next few months? Unfortunately, I don't know what you're talking about. No, I'm kidding. Yeah, we're very worried about it. We are working with them to see if there's wiggle room there. I have a little inside baseball on it, but the short of it is that Discord is trying to IPO, and they're going to do everything they possibly can to make it look really safe for people to then want to trade it on the stock market. So. Most of the executive team at Discord has changed out over the past 2 years. Normally I would be worried about that, except I know the people that came in, and it's a lot of the good people who left Unity, so I'm not too worried about it. But yeah, it's not a great look. I'm hoping that we find a better solution than what they're proposing. Am I worried? I'll worry tomorrow. Yeah, we'll probably take a hit. We've got other like we're doing a big Steam push for the next game, so obviously we're trying to diversify our own holdings, and we're trying to leverage our communities and our player base as much as we can now. We just opened up wishlisting in the game a few weeks ago. Well, I guess maybe about 2 months ago now. We're about 28,000 wishlists, so yeah, we're trying to diversify, but I honestly think like this is kind of I think Discord's going to come to their senses, because this is such a killer place for games. Like if anything, if I can prove it out like this, anyone can do it. So yeah, I think they'll come to their senses. I'm not convinced they're going to go through with it. Great question. So it's about, do we have a lot of latency, especially because the geographic dispersity, all the different surfaces of Discord, how are we dealing with that? I was able to, mostly with Cloudflare, hack Cloudflare to make it act like a game instance. The way I was able to do that is through a system called Durable Objects. And through the Durable Object, I'm actually able to open a socket. We use... it's based on gRPC, but it's a proprietary RPC that we made because it was a little bit faster and I didn't need everything from gRPC. But we use a really lightweight, we use flat buffers, which is a wire protocol to communicate everything with. This is getting a little technical in the weeds, but we were able to like get a really small, very fast WebSocket between all of the sessions. There are things you have to do, and I'm actually doing a workshop a little bit later to show you guys some of this stuff if you want to see that. But Discord has like a DCS, which is like a protection to make sure that no one's going to like man in the middle attack you. So there's things you have to do to like make it work, but it's actually we've got a pretty good way to do it. So it's the latency. I mean, it's not great when you have someone in Oceania and someone in EMEA and then someone in Idaho. That's not great, but these are also like party-based games. I'm not making a twitchy FPS, so it's kind of, and also I have to wait for I don't really wait for the stuff to generate. I pre-generate everything so that you don't have any latency of waiting for anything to, especially speech. I should say that too. When it comes to costs, completions, man, I wish I was just paying for those. TTS, that's where the real money is spent. So, but InWorld's a fantastic partner, and we were able to get, it's public now, but we were able to get like early access to their V3 of their TTS. So we could not pre-generate. While you're waiting, while you're watching something cute happen on the screen, I've already streamed all the byte buffer from the audio to your client, so there's no latency, or little latency. Yeah.
So I enjoyed the talk about
Yeah.
Would you ever move any of this compute on the device, or would you, or is it core to your business model and design model that everything gets generated on server?
Good question. So the question was, well, first he thanked me and said that I had a great presentation. The question was about would I do this on device, moving models to device, and so the answer is yes. And we've actually experimented with the BERT-like models, the very small inference, because that stuff can run on device super easily. We haven't done it yet because while we do have a mobile presence in the app stores, just like everyone else, very few people have downloaded our games there. They just play it streaming through Discord. So Discord didn't want us, we would have to do something special to get access to hardware via the Discord activity. So we haven't tried that yet, but the BERT-like models would be first. Yes, absolutely. But not through Discord. We'd have to figure out a way to access it via their layer, because I am a surface within their app. Their app is built on Electron. Like literally, it's like just a React app that's using Electron to build to device. So I'd have to like work. They'd have to buy us.
All right, we'll take a break. We'll be back in 15 minutes. Thank you.
All right, thanks.
Okay, our next speaker is Tin Vuong from Ohio University. He's undergraduate, I believe, and involved in several bits of research, one of which he'll explain right now.
Good morning, everyone. My name is Tin Vuong. I'm a senior undergraduate computer science student at Ohio University. I'm joined today by Dr. L.Liu, who is my mentor and one of the co-authors of this presentations. And the main presenter was supposed to be a graduate student, Krikit, right here, but since he couldn't make it today, I will be the stand-in presenter. And also with the help of Alex Bukowski as well, who is not here today. So, a little bit about what the project is about. So basically, we are trying to explore LLM's capability in positional reasoning, and we thought that Wordle is like the perfect game to do this. And has anyone here not played Wordle before? Okay, so I'll just go do a very quick demo of what Wordle is like. So if you go to Wordle, so it's basically a word guessing game. So I'll type in a random word, and then gray indicates that that letter is not in the correct word. A yellow indicates that that character is present in the word, but in the wrong position. And green stands for correct character and also position. And so you're given 6 attempts in Wordle, and you have to deduce a 5-letter word. But we also explore another Wordle variant, which is called Fibble. So there's gonna be 1 to 5 lies depending on the level you're playing. So introduce per row in the Wordle guess, in the Fibble guess. So that's why you're given more attempts, 9 attempts. And so this was more like kind of like a classroom discussion project. So we were able to get a lot of submissions from students. So I have 16 here, and so like I mentioned before, we wanted to explore the LLM's capability in positional reasoning, and this is because our hypothesis is that LLM would struggle with word games because of the tokenization problems. So for example, for the word stank, LLMs don't actually see like every single character of that word, or let's see the whole word itself. It's tokenized into 2 different, I guess, group of words there. So ST and an ANK, right? And so if you ask it, is the character N in position 4, it doesn't really know, right? Because before these groups of characters are fed into the neural network, transformers, whatever, they just become numbers, right? And so A and K will be represented by a single number. So there's not really information about whether the character N is in position 4 of the word stank or not. And so our hypothesis is that with Wordle, it will struggle a little bit. But with Fibble, however, when you introduce the lies to the character, so like say, if you say if it shows A is in the correct position, but is actually not, then it increases the search space of the problem, right? And so our hypothesis is that the performance will degrade when deceptive feedback is introduced, and the more lies you introduce, the worse the model is going to perform. Okay, and our evaluation metrics for this problem includes win rates, average guesses per game, invalid guess ratio. So it's trying to guess like A, B, C, D, E, for example. That's not a valid word. And there shouldn't be we didn't really measure prompt size at the end because we tried to keep it as uniform as possible across multiple models, right? So, so for the Wordle results here, we tested it with both commercials and local models from Olama, and he has a few participants, so myself included. I tested this model like yesterday, 100 games of Wordle, local model GOM, 30 billion parameters, and it solved it 100% of the times with an average of 4 tries. And other models, Olama, also had the same performance. And for commercial models, GPT-5, the most recent models, solved it 100% of the times. But if you look at the open source model they released last year, the 20 billion models, and also GPT 4.0, they actually didn't perform as well. And so there are parameter size, model size, and also when the model was released, those two factors also come in play as well. And the really small models, so 4 billion parameters and smaller, that basically barely even solve the game. And so there was one really impressive result from one of our students. So using a model with only 8 billion parameters, he was able to solve Wordle 100% of the time with an average of only 3.7 tries. That is even better than 5.9 from GPT-5. And so the main improvement, I guess, the main techniques that he did was constraint filtering. So meaning like, say, if there's only one possible word in the next guess, so say you have discovered 4 letters, there's only 1 letter left, there's no other valid English word that you could guess beside the correct one, then you don't have to call LLM, right? Like that. And also making sure that the LLM doesn't guess. Let's say if a character is in the correct position and it gives you another character in that position, then you would kind of like pre-prompt it. Tell it like, think again, because this character is in the correct position. Those kinds of things. And for Fibble, the results are quite different. We didn't include average tries here because I think I wasn't really the main presenter of this presentation, and it wasn't included, so my apologies. Fibble 1 was solved by most of the commercial models 100% of the time. But as you can see, when we move on to higher levels, introducing more lines, increasing the search space exponentially, the performance degrades. And interestingly, GPT-5 was able to solve Fibble 5 90% of the time. But other smaller models weren't able to solve them. And for local models, the smaller models, they basically struggle and couldn't even solve it most of the time. And here just more the top performers of the submissions. And yeah. And so one impressive result is in Fibble was from GPT-5 with low reasoning. And as expected, when more lines are introduced, the performance degraded. But interestingly, when introduced with 5 lines, the model was able to solve it better than 3 or 4 lines. And honestly, I couldn't tell you why.
Well, the reason why is because when all feedback slides, you can now don't have to guess which one is that. You know all of them are that. So that actually gives you information. We didn't know in the very beginning. It's only when the result came out that was like, oh, that, yeah.
Yeah, that was nice. Just to summarize the results, all commercial APIs were successfully solving Wordle 100% of the time. Mid-tier models, so models greater than with more than 8 billion parameters, solved it like most of the time, but smaller models achieved pretty much didn't solve them. But one note is that if you prompt the model cleverly enough, so like telling it that, well, if it tries to guess a character which is in the wrong position, then you would reprompt it. Those kinds of things, and also telling it to start with some like really common words that includes a lot of vowels, for example. That would improve its performance. And like I said before, constraint filtering with a smaller model achieve an even better efficiency than just like raw prompting a commercial model. And for Fibble, on the other hand, even the current flagship commercial models fail at the higher level of Fibble, and we believe that this is because of the exponential search space that increases as you make more guesses, and also as more lies are introduced to the game as well. And yeah, even prompt engineering, like trying to make the prompt better, didn't really improve the model's performance. And with this, I would like to show something that's I think is quite interesting by one of the GPT models. So this is one of the logs that we have of Fibble 2 played by a GPT open source model, 20 billion parameters. So 2 lies, 9 tries. Oh.
Thank you.
Yes. How's that for people in the back? All right. Okay, so 2 lies, 9 tries, GPT 20 billion parameters, Olama. It did a bunch of reasoning. They did the results in the middle of the game, but then something that I never expected did happen. So the reasoning through the word, whatever, blah, 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 and then bottom line, guessing on row 6. Oh, and then it started speaking Japanese. Calculating position, velocity for some reason. And I was like, I didn't know Wordle or Fibble was this serious, you know? Yeah. But like, I guess. This was last year, so before they released the guardrail model, the open source guardrail model. So we haven't tried that yet, but that's something that I would love to find out if they've fixed this problem or not. I couldn't tell you. But yeah, just something. Our conclusion is therefore what games do indeed expose LLM's weaknesses in the character level position reasoning, especially for smaller models. Like I don't know if you guys remember this one meme that was really famous like last year, where GPT can count how many R's are in strawberries, you know. So that was kind of like one of the motivations as well. But like I said, Fibble, where there are lies introduces an exponential hypothesis space, so that makes it even harder, right? And using prompt engineering with some constraint filtering, that often outperforms a commercial pure just raw prompting LLM. And so it have validated our hypothesis and the evidence for the DeepSeek's claim that LLMs cannot reliably or consistently understand character level reasoning. And future directions. So I don't know if you've seen from the results page. I'll just go back for a little bit. Since I'll just use this one. Since this was like a class activities, not a lot of students had access to computational resources, GPUs, so they couldn't run as many games as the number of games ran was uneven across students. So what we would like to do is to run 100 games for each of the models, just to be more statistically accurate. And also standardizing the LLM's output, just because different APIs give different formats, and also local models usually struggle with this problem as well. And we do have a real-time leaderboard. I think it should be in one of the links here. Yes. So we do have real-time leaderboards. So in this link right here, drchang.liu.github.io/Wordle Arena. If you go to that link, you can see our current live leaderboard of that is being updated every day, asking LLMs to play Wordle. Yep. And also, we would like to try with other game variants as well. So one of the games is called Clueless. Has anyone here played Clueless? Basically, you guess a word, and it gives you a score to indicating how close you are to the hidden word. And so, if say, for example, the correct word is like piano, and then first you guess movie, that's probably not close. But if you guess music, then it will indicate a higher score. And so you try to get as close as you can to the hidden word. And we didn't really include latency in this in the metrics, because personally I think that shouldn't really be a problem. That doesn't really I guess match our what we're trying to test, our hypothesis, right? So so future directions, including just forcing chain of thought actually improve models' performance, because right now we're just like kind of like prompting the LLM doesn't really tell it to like kind of like go back, think about what you guess, and then see if it makes sense, right? And also trying it with reasoning models as well. And also, can external memory tracking improve the Fibble performance? Because as mentioned before, the exponential search space makes the LLM it kind of like increases the context window of it, and it start hallucinating as well. And just combining multiple models, much larger models. Yeah, and more. It's just more of what was said, and I think that's it. Thank you. Do we have time for questions?
We'll have questions as a panel at the end.
Okay.
Panel discussion, like we did yesterday. Pranav. Is the name right? Yes. W, doing introduction again? Pardon? If you want to use the clicker, go ahead and insert this into USB. If you don't, don't worry about it.
Yeah, I'm just gonna press it.
Coming up, or? We don't have to do introductions. We do introductions at the end of the for the panel. Okay. So this one out.
setup. Okay.
Pranav is a graduate student at NYU at Tandon School, and he's worked on a number of projects, but the one that we're talking about now is creating puzzle maps using yes, wave function collapse, which is the coolest sounding name ever.
So, hi everyone. My name is Pranav Pradhan. I'm a master's student in computer science at NYU, and I'm also researching in Games and Innovation Lab. And I'm going to talk about how we use wave function collapse to generate playable puzzles in Pokemon Fire Red. This work sits at the intersection of procedural content generation and puzzle design for top-down RPGs. Our goal wasn't just to generate maps that look valid, but maps that are actually solvable, interesting, and fun to play. So, to ground this work, we start with Pokemon Fire Red, specifically the Viridian Forest Maze. It's one of the few puzzle-like environments in the game, and that provides a clear baseline for what works and what doesn't. So, when you look at the original Forest Maze, there are a few big limitations. It's not very replayable. There's very little interesting structure once you know the solution, and the game only really has one type of forest-style puzzle map, which are always mazes. That makes it an ideal candidate for procedural content generation. To address this, we turn to procedural content generation, specifically wave function collapse. WFC is a constraint satisfaction method that generates new content by learning local adjacency patterns from a single example. You observe tiles, initialize an unknown grid, and iteratively collapse tiles while respecting the constraints. To apply WFC to Fire Red, we first pass the ROM maps into a tile-based representation. Each tile is assigned an ID, and we learn adjacency rules and frequency weights from the original map. This gives us a traditional rule-based WFC setup. However, the naive WFC has serious problems. The generated maps often aren't challenging, and worse, they're frequently unsolvable. This is a core issue. Visual plausibility doesn't guarantee playability. As you can see, the red box over there is the goal tile, the goal/destination tile, but we can't actually get to it while walking. So this leads directly to a research question: can we use WFC to procedurally generate top-down RPG puzzles that are structurally coherent, complex, and playable? Everything that follows is about answering that question. To explore this space, we didn't design multiple fundamentally different models. Instead, we designed a single WFC-based generation model and explored two different approaches to using it. Each approach progressively adds more structure and gameplay-aware constraints on top of standard WFC. So the core algorithm stays the same, but the way we guide and constrain generation changes how playable and complex the resulting maps are. So we apply WFC to forest map generation using a two-phase approach. In the first phase, we generate a simple high-level structure by explicitly defining entry and exit points and carving a random solution path between them. This guarantees that a valid path this guarantees that there is a valid path through the map. In the second phase, we run the WFC, but with constraints tied to this structure. We define a specific tile set for the solution path, and during collapse, any cell marked as part of the path is only allowed to collapse into the tiles from that set only. This lets WFC fill in the surrounding forest naturally while preserving guaranteed playable path. To increase puzzle complexity, we integrate Sokoban-style rock puzzles into our forest maps. In Sokoban, the player pushes boxes into designated storage locations within a grid-based environment, which makes it a good test case for a structured, constraint-heavy puzzle. We use WFC to generate Sokoban layouts by learning valid local patterns from example puzzles. These layouts are generated independently, verified for correctness, and then embedded into specific regions of the forest map as additional constraint during WFC generation. So in our first approach, which we call optional rock puzzles, we start by generating a guaranteed solution path through the map. Once that path exists, we search for rectangular regions along the map that are suitable for embedding Sokoban puzzles. These regions are passed into a Sokoban generator where all tiles are required to be walkable and valid for pushing mechanics. The generated Sokoban layouts are then overlaid back onto the map as additional constraints. Finally, we assign all marked phase 1 blocks such as solution path tiles, boxes, holes, Sokoban walls and floors, the map, the players and blockers into the respective tile sets and run a final WFC pass to seamlessly integrate everything into a single playable map. To encourage interaction, we introduce a scoring system. Players lose points per move. Entering a puzzle has a small penalty, but solving a puzzle gives a large reward. Importantly, the game can still be completed without solving any puzzles. In our second approach, required rock puzzles, Sokoban puzzles are no longer optional. Instead, they gate player progression. We introduce a candy collection mechanic where the player must solve specific Sokoban puzzles in order to collect candies and unlock the path forward. Once the required candy is collected, the stones in that region can still be freely pushed, which prevents soft locks and keep the environment flexible after the puzzle is solved. To evaluate these models, we focus on 3 properties: solvability, total player moves, and whether alternative paths exist. We use 2-layer connected A-star agent. One layer solves the maze navigation problem and the other solves Sokoban puzzles when encountered. A-star is a standard pathfinding algorithm that balances the path cost and heuristic distance. It's well suited for evaluating solvability and complexity in grid-based games. For the maze, movement costs 1 and entering a puzzle costs half. For Sokoban, movement costs 1, pushes are free, and the heuristic is the sum distance of rocks to the goals. Here you can see the solver in action. The purple path represents the A-star solver's computed solution path through the generated maze. This is the optimal path found by the search algorithm. On the right, we display solver statistics for the Sokoban region. We report the number of solving steps, node expansion, and solving time. Below that, we show the same metrics for full generated map, including the outer maze and embedded puzzle regions. This visualization confirms 2 things. First, that the map is solvable end to end, and second, the solver remains computationally efficient even as structural complexity increases. On the left, the yellow path is the initial carved solution path before WFC, which guarantees solvability. After WFC expands the structure, the purple path on the right shows the A-star solver's optimal route. The fact that it differs from the original path shows that alternative routes naturally emerge, making the maze more exploratory and replayable. Here we compare our A-star solver with 20 human testers to understand how algorithmic difficulty translates to human experiences. Looking first at A-star, as the number of puzzles region increase from 0 to 3, the number of moves increases gradually and solve time rises slightly, but it remains extremely fast under a few seconds, even in the hardest case. This confirms that our maps are computationally solvable and structurally valid. Now we compare that to human performance. Humans take significantly more moves and more time. For example, with 3 puzzle region, A-star solves the map in about 2.5 seconds using roughly 125 moves, while humans take over 75 seconds and around 176 moves on average. This gap is important. It shows that while the map are technically solvable, they remain meaningfully challenging for human players. Here we compare the different approaches using both user questionnaires and gameplay metrics. First, looking at the ranking table, lower is better. ORP consistently ranks best in fun, novelty, visual quality, and overall preference. That tells us players enjoyed optional puzzles the most. RRP, on the other hand, ranks highest in difficulty, which makes sense because puzzles are mandatory. It increases challenge, but that doesn't always translate to higher preference. Interestingly, the baseline WFC generation without structure performs worst across almost all categories. This reinforces our earlier point. Visually plausible maps are not necessarily enjoyable or playable. Now looking at the player-facing metrics, ORP achieves 100% completion rate while vanilla WFC drops to 14%. That's a massive difference in solvability. RRP and ORP both increase completion time and total moves compared to the input map, meaning that they successfully add complexity, but ORP strikes better balance, challenging but still fully completable. So I can show you a demo. So here is the basic Viridian map as we see in the game. There is nothing much to do except for just going through the maze itself. So this is one of our method. So the this is the optional rock puzzle. So if the tester wants to complete, okay. So if the player wants to actually use that to solve the puzzle, then they can, or else they can just skip it. This is the required rock puzzle method. Here the player has to solve the puzzles to unlock the end or get a candy. So he got the rare candy, and now he can go ahead. Yes. So thank you. Do you want my laptop? There's no adapter. Yeah, sure.
I should.
So Lisa is a graduate student in the same program as Pranav, but she's showing work that she did earlier at UC San Diego as part of her thesis project there. This one, my voice in and out, it just going to the recording.
Do you want the clicker?
It's okay. I'll just.
Okay.
I mean, how do I use it?
You just have to.
This clicker.
Yeah.
That looks like that looks good. Dry. Like a fresh dry.
Do you want it?
Sure.
Yeah. Best of luck.
Wait. Pranav, question. How do I see it here? Do I just have to look back?
Oh, okay. Maybe we can do something like this.
You know what? It's okay, and then I click through here.
Yes.
Okay. Hello everyone. So my name is Lisa, and today I'll be presenting my bachelor's thesis project on the effects of randomized resources on trading card games, specifically through studying Genius Invocation TCG, which is a trading card game. So just for background, this is a kind of like moderate complexity trading card game. Like, it's definitely less complex than the more classical study games like Magic the Card Gathering, if you guys have played that, or like maybe Yu-Gi-Oh, right? But it's like relatively new. When I did this study, it was released 2022 as part of version 3.3 of the open world exploration game Genshin Impact, if you guys have played that. And to date, there are over 100+ character cards. So the characters are like the cards where you can see these people, right? And then there's a lot of these accompanying supporting action cards. So there's over 350 of those in the full-size game. And the focus of my presentation is kind of on the randomization that is introduced through dice. So in order to play any cards, there's always a dice cost. And specifically for Genshin, they use 8 different 8-sided dice. And so there's 7 elements in the game. So each character has a specific element that they correspond to, and thus every action that a character takes, it needs to expend a certain number of like a specific type of dice. And then the last side of this 8-sided dice is a side that can basically stand in for any element. This is called the omni side. In this project, I wanted to simplify a lot like the effects of this randomization, so I focused on just one character, and then that character specifically is the cryo dice, so that may be referred to later in the presentation. But yeah, as you can see, like with so many dice, there's definitely like a lot of different combinations. I would say there's around 6,400 like unique combinations that you can make with this 8-sided dice, and that definitely has a big impact as you have to roll like every single round, and there's like 15 rounds in the full game. Cool. And then for the related work, originally I was trying to use this full-size simulator. Someone's been working on it for years and years before. But it's still in progress. Even like now, only about half of the cards and half of the characters have been implemented. They do have a lot of the mechanics, but I think they lack kind of support for like modifying the number of dice that we use, or like kind of like controlling like different parts of the aspect, since their goal from the beginning was just to create a full simulator of the full game. So yeah, I just found that there was not a lot of support for like Stable Baselines 3 or any other libraries or wrappers, so it's difficult to add ready-made reinforcement learning agents. So my goal was to create like a very simple like simulation environment that would allow us to isolate the effects that we wanted, while also like allowing very easy implementation of reinforcement learning agents. So onto the methods, onto the environment design. So this is the gameplay loop. We simplified it from the full game. So in the full game, the setup phase, every single round, you would need to select cards. You would need to then, out of your deck of 30 cards, you would need to select 5 cards, and then you would need to roll your dice. And then you would have the actions, and then after every round, it would go back to the setup phase. So I simplified it a lot. There's only 5 cards that you have in your starting hand. So in the simplified environment, you start with all 5 of them. There's no deck for you to draw cards from, but you still have the dice rolling. That happens in the setup phase. So also the characters involved. So there's one character, Kaya, and he has 3 attacks. So that's 3 possible actions. Each of these has a different cost and a different like damage effect. There are 5 supporting cards in the deck. So there's 2 food cards. There's 3 food cards, because one of them there's going to be 2 copies in the deck. They increase the health points. Then there's a weapon that will increase attack, and then there's an artifact that will decrease the dice cost. So there's one representative at least for every major category in the game. Yeah, so also here's a summary of the simplifications made from the full game to the mini game. So in the full game, you always have 3 characters, and so these characters can have different elements. So there's also a lot of different like elemental reactions too involved in their attacks. But so here we only have 1 character, so we've simplified that aspect. Then I've made it so that there's only 4 dice per turn, because a simpler game doesn't require as many dice. And then we've made it so that you can only play 1 action. So an action would be like doing an attack or playing a card. So you can only do 1 per turn, and then it goes to your opponent. And then, like I said, there's only 5 cards in the deck. So in the mini environment, here's kind of an overview of the cards I introduced. So food, artifacts, and weapons. And then there's 2 main environments that we are comparing between. So the deterministic one, which has really no randomness, and then we have the random environment. So as you can see, they both have the same number of dice, but for the deterministic one, these are all the omni dice. So as you recall, you can use these wherever. They can substitute for any element. And then for the random one, you have 4 random dice, and there's an automatic mulligan, which is like you can re-roll the dice that are not the element you want. This is also present in the full game. Yeah, and then the 3 main attacks that are element specific, we've changed kind of the number of dice. Specifically, you can see on the random side, it does start to require specifically cryo dice. And actually, this for balance-wise, I think it made sense here too, because the burst, which is the most powerful attack, as you can see, it does 4 damage. It only requires 2 cryo dice, and given the automatic reroll, we can expect about 1.5 cryo or omni dice, or like usable dice. So it should not be super hard to use the burst. Yeah. So then onto the experiments part. So setting up this reinforcement learning environment, I was using the petting zoo environment. So that's basically this nice framework for creating multi-agent reinforcement learning environments. It's the multi-agent version of Gymnasium, if you guys have used that. And to set up an environment here, you need to define your observation space and your action space. So it's actually not super big. You can see the actions are the ones that we've outlined, and there's an additional end round action. This is not a skip turn, but it will end your round. So after you do this, there's no cost. You can do it any time, but you cannot play any more actions within this round. And yeah, so we're training the agents through self-play in this environment. And then for any reinforcement learning environment, you also have to set up rewards. So here are the typical win-loss rewards. I gave very high win-loss rewards and then a very small tie penalty, since I thought maybe ties would likely happen given the dice constraints. And then I provided further shaped rewards because the agents you have to give some direction, right, for the agents to learn how to win a full game. So here are some like common strategies or common mistakes that were turned into shaped rewards. So one of them obviously is playing an invalid action. If you don't have the dice required, then you cannot do it, and that comes with a penalty that originally was pretty high because I wanted agents to learn how to not incur this penalty, but it turned out that it made the agents actually too scared to actually play any actions during the training, because they were playing against themselves in the self-play training, and so then they would just always pick end round action to avoid this penalty, and then it actually lost like 100% of the time against the random agent, because the random agent would at least occasionally like play some attacks. There is another action I found that the agents were doing that was just ending the round with no dice available, or sorry, with all of their dice available. So they made no moves. That was bad. And then also if they use a food item with full health, that is obviously like a common sense. It's a waste of their resources. It's a waste of the dice used to play this food card, and it's also then they can't heal later. There are also some rewards given for good actions, like attacking. So attacking comes with a small reward, and then it also comes with an additional reward depending on the damage that they have done to the opponent. So in this case, the damage is ranging from 1 to 5. And then using a support card will also give them a small reward. The agents involved, I've only used the PPO agent, so the Proximal Policy Optimization agent, because within the Stable Baselines 3 library that I wanted to integrate with, only this reinforcement learning algorithm came with like an official masked variant to allow us to use an action mask during the training. And then there's also a random agent as a baseline. And of course, also the masked agent does not have an action mask in the testing. And then finally, for my results, I first ran a balance check in both environments just to tell if there was like a significant first player advantage. I found that there was none, but obviously the randomized environment, it did cause a lot of ties because of the dice constraint once it reached 15 rounds. And then here's the main results. So for the deterministic environment, PPO won overwhelmingly, and actually the masked PPO agent actually performed worse than the unmasked agent. I think this was because the reward landscape probably for the masked player was a lot more like flat, because it never really got penalties from invalid actions, so it never really had a chance to like like it could only try out illegal moves. I think at least that's my hypothesis. And then for the randomized environment, we kind of see the same trend, except there's a lot more ties. Yeah, so here is an additional summary of the other changes I made to get to the shape rewards I did, or why I added rewards for using cards or for not using cards. Yeah, so I guess notably it was just that there was a small hiccup in the middle where we had added this HP bonus, and it was actually like doing more bad than good. And then for the food usage, it was also having this unintentional encouragement effect of encouraging the agent to use their cards even when it was unnecessary. Yeah, so then onto the overall results summary. There's 2,000 games run per environment, so 1,000 where PPO was first player, and then 1,000 where the random agent was the first player. Yes. Okay, so yeah. So in total, the project had 2 custom petting zoo environments. You can insert any like stable baselines theory, like implemented reinforcement learning algorithm in here, and these 2 are both balanced because there's no first player advantage, and there's a clear distinction between the deterministic and randomized environment results. And the code is available online, and I think next steps would be like probably to create more incrementally complex environments to study like how the agents can respond to increasing complexity. I don't think this would necessarily mean more ties, because more mechanics allow you to do things like tuning your dice so that you can get more dice by sacrificing cards, for example. But there's a lot of additional mechanics that were not implemented here. But yeah. Okay, thank you.
Owen, no, 3, 4, 3, 2, 1. Owen Salyer represents the 3rd member of the Ohio University delegation.
Thank you very much. My name is Owen Salyer. I'm a master's student studying computer science at Ohio University. My work is on an LLM agent for playing and explaining chess moves. So briefly, the motivation, obviously, strong game AI in games like chess or Go are very, very good. They can beat human players, but they can't explain themselves. They don't have generally don't have a rationale for why they make a move. On the converse, language models can explain well. They can generate natural language at a high level, but they are not good at these games because they have no method of calculating. So the idea is, can we fine-tune an LLM to combine the competence of an engine at some level and the clarity of an LLM into one system? And this would be good primarily for a coaching aspect. So players that are learning to play, if they make a bad move, or if the AI makes an adversarial move against them, they can explain why that was a good move or why the move punishes a mistake that the player made. Also, spectator value. In a game between 2 grandmasters, if a lower level player wants to watch and enjoy the game, they may not understand why a particular move is good. So potentially an LLM could explain the rationale behind a move in a game. So chess is sort of a classic example of a game AI sandbox. I have a picture there of Garry Kasparov playing Deep Blue in 1997. That was kind of the breakthrough moment where AI could defeat human masters in a game in 1997. Now, Deep Blue is a supercomputer. It ran on about 500 CPU cores. Now you can have Stockfish on your cell phone, and it would beat the best players in the world 100 out of 100, no trouble. So we've come a long way, even in the last 30 years since Deep Blue. But also AlphaZero, about 10 years ago now, from Google DeepMind, purely learned based on reinforcement learning self-play, and used Monte Carlo tree search based off of what it learned in terms of its policy network from playing itself billions of times. So the core idea here is, can we use a chess engine to determine the best moves? Can we use facts algorithmically about the board to generate algorithmic human-style explanations, and then combine those two into one, fine-tune a language model to imitate the engine and the algorithmic explanation generation into a single compact language model. And so, yeah, can a small model generate reasonable moves and rationales? We're using a 4 billion parameter model in this work that's fine-tunable and runnable on consumer-grade hardware. That was kind of my goal here. So this isn't entirely a novel concept. There was a work from last year which created a system for, given two moves fed into an LLM with a position, it would explain which move is better and why. And that's on an 8 billion parameter model. Also ChessGPT from a few years ago, which explained moves that were made. It didn't make moves itself, but it explained moves that were made based on a large corpus of text. So books and videos, expert annotated games, etc. So our pipeline is a bit different. We just look at games which are played. So from Lichess, we grab games which were played by players online. Some subset of players that are just, average 1,000 ELO level players. Some subset of elite players, so into the master realm of 2,300 ELO. And we sample positions from those games. So given a game, randomly select after move 11, here's what the board looks like, and it's white's turn to move. And then do that for a lot of games. We label the best moves in those given positions using Stockfish, which is among the stronger engines today. We label the best move and we label the next few best moves. Then we generate a strategy and a tactic, one sentence for strategy and one sentence for tactic. And we do that automatically, and I can explain a little bit more about that in a second. But given the combination of the best move and the fine-tuned strategy and tactic sentence, we can fine-tune a small model on those. So we just give, for prompt, we give the board state and basic instructions like you're a chess assistant, give the best move in this JSON output structure. And we anticipate a structured decision with rationale. I talked about algorithmically generating strategy and tactic sentences. Strategically, these are things which are long-term advantages for the player whose turn it is. So if you make a move which improves your central control, that doesn't do anything inherently, but in the long term, that could benefit you. And these are things which we can determine if we just look at the board state. If we have certain algorithmic flags set, we can say, does the player playing white have control of the central 4 squares of the chessboard? And if so, we can give it a little bit of a boost. Hey, this move improves central control. We control more of the central squares than we did before. Tactical signals are more one move type things. So if you take your opponent's queen, that's generally a good thing. If you have mate in 2, that's generally a good thing. These are things which we can label as well. As for training, we use Qwen3, 4 billion parameter, the instruct version, so no thinking capability. It has thinking capability, but no explicit thinking steps. it's the 4-bit quantized version of the model just to improve the runtime and the fine-tuning time on my hardware. Fine-tuned with LoRa adapter. There's a built-in LoRa via MLX for Mac, which I used most recently, but I've used QLoRa via bits and bytes when I was running on Windows on a CUDA CPU, or CUDA GPU, sorry. Like I said, it runs on consumer hardware. So I use a 6 gigabyte GPU, about 24 to 30 hours of fine-tuning time for the model on Windows, and then a similar training time on MacBook Air with the other setup. Results does quite well. We have a 36% top 3 move agreement with Stockfish. That's not great, but more happy with the fact that we have 100% compliance with the JSON structure, which I requested, and it 100% of the time plays a legal move. I do attach a list of legal moves and say pick from one of these, but sometimes LLMs struggle to pick from a list of things which you give it. So I'm happy with the fact that it does that. So it does do well in check situations, but obviously your move set is limited when you're in check, so I expect it to do a bit better there. I had this idea. This needs to be further fleshed out in future work, but rather than just prompting the LLM for a move, what if we had a Monte Carlo tree search style agent like AlphaZero at the root, prompt the LLM to give its 5 or 6 best moves, branch into each of those moves, simulate a certain depth, and then at the depth which you're satisfied, have the LLM tell you which side is better. This needs fleshed out more, but I think it's an interesting idea that I can explore in future work. I did create a little bit of a GUI. You can play against either the MCTS version, which is still a work in progress, or the traditional LLM direct, here's your move, here's why. And yeah, it adheres to the rules of chess. I have a brief demo here. So you can see this is the Monte Carlo tree search player. So oftentimes I've noticed the Monte Carlo tree search player doesn't return a strategy or tactic sentence at the top. It just doesn't come up with anything. It also takes a very long time to play moves. You notice it takes 110 seconds to play Rook G8, which is a terrible move in this position. But overall, pretty interesting. And then I switch it back to the LLM mode here at some point. So yeah, now I switch it to LLM mode. I respond. This is a bit quicker. It'll play responding move. So yeah, that only took 7 seconds, which is not too bad, given we're just running on a MacBook. I ran this on my computer, and it gives a reasonable strategy. I would say that does increase center control. That knight sees d4 and e5, which are both central squares, and it does have more pieces active than me. It has 2 knights rather than 1. You'll notice that, given that though, it still is not very good. So I'll attack its knight. Best move is probably to not do what it does, but yeah, that's bad. That hangs a knight in one way. So anyway, I'm happy with what I have here, but it does need work. So small models can operate inside a structured rule system. So given a legal move list, it does return valid JSON, which indicates one of the legal moves which I gave it. And I think that the explainability portion can help with player learning, assuming that we can prove that it matches up with the moves that it's making. It does lack some ability to play strong logical moves in an adversarial role. It will never beat Stockfish, at least not with this setup. It'll never be at a master level with this setup, but with some different ideas, we could potentially get to the point where it's a useful player for practice. Future work for me, I think, is more self-play games. We need more data. I'm fine-tuning an MCTS version of the LLM, so instead of generating a move, a tactic, and a strategy, it generates a move evaluation. So like, how good is this position for you? And then a tactic and a strategy sentence. Given that valuation, we can use that at the depth at our leaf nodes in Monte Carlo tree search to inform which path up is best. And then different models or adapters to handle move, valuation, and strategy. I think this could be useful rather than having one model do all four things. Delegating tasks to specific models could improve performance in the long term. These are the papers I discussed earlier. Thank you.
Presenters up for the panel.
The question is that can I solve the Fibble variant of Wordle? Oh, it depends on how many lies I introduce. I think with one lie, I played it last year, 10 games. I think I solved it 70% of the time. So, yeah, I didn't even attempt that.
Fibble is much harder. I tried. I'm pretty bad with Wordle to begin with, so I couldn't do it. And in one of my classes, I asked students to actually solve it. And there was one guy come out and say, I get everybody in my dorm to do it together, and one word couldn't do it. But there was once I played in class with everybody in the class, like 20 plus students do it together, we were able to solve it. Fibble 1, that's Fibble 1. I know Lisa solved the Fibble 1 before, right? You solved Fibble 1, but the Fibble 2 is really hard. Fibble 2, you have to pull out paper and do these reasonings.
You should try to, you should write a paper on this as an AI benchmark and also release it as an AI benchmark, like basically build the harness and everything for it, and then, because people, I mean, benchmarks that are easy to use don't cost a lot of talking about scale a lot. They are much wanted.
Thank you. We are thinking along that way. So in addition to the Wordle arena that the team showed, we also have a Fibble arena, Fibble 2 arena on the same side, and we run once a day to solve the word of day. So over time, we'll see how these large languages do. So the latest result, Google just came out Gemini 3.1. It solved Wordle, it solved Fibble, it solved Fibble 2. Okay. But they failed the Fibble 3 for now, so we'll see how it does going forward.
Owen, I'm curious as to how much variability you found in the chess moves. Was it generally doing the same things? Was there a great deal of variation?
Yeah, so the question was how much variability was there in the model's chess moves? I found a little bit of variation. I think that it really likes to move knights in the opening. And then I do find it makes sometimes a logical defensive move when it's under pressure. Really likes to move knights though, I think. I think it likes the idea of going as far forward as it can with pieces on the back rank. So I would say that's the general strategy I picked up on, but it is pretty variable in terms of its actions.
Success or failure, not to the interfering dice roll randomizer. So you could make a good early move and be punished because dice roll just randomly made it so that was not great for you. So you can make the right move as the RL agent, but still have failure state because of the dice. Because the dice are kind of interfering and intersecting with good moves. So it's like, how do you solve for the RNG factor when that's out of the hands, even if the RL agent is making better and better moves, because there's this interference happening with the RNG. And I don't know if this was what you were trying to explain with the 6400 or 6400 like permutation outcomes for the dice, but I still don't understand how we get a model to properly be rewarded if it's doing the right thing and still having a bad negative outcome. And maybe you could explain a little bit more of your shaping strategy around that, because I didn't fully grasp.
Good luck repeating that question.
Right.
It's like, how did the dice make it complicated?
Right. I think honestly, I feel like these are kind of like separate in the sense that the actions that you're allowed to take are determined by the dice, but we're kind of like, I don't think I never penalize an agent for, like, there's no objectively good or bad action, right? Like, you have an action space and these 8 actions are all theoretically available, but we're only judging these bad actions in terms of like things that are not related to the dice, right? So like for the food example, right? The dice don't actually affect like whether or not this food action is available. If it's available and you're able to take it, that's plus points, right? But you aren't going to be penalized for not being able to take it because you don't have the dice to eat this food, right? So I guess my answer is also a bit confusing, I'm sorry. But yeah, I feel like the function of the dice was just to kind of change like the actions you had available, but then these like objectively, what I said, like were common sense strategies, right? These are kind of built on top of like your existing action set. So none of these are saying, well, there was this action you could have theoretically taken if you had the dice for it. And then therefore I'm going to give you a penalty for not doing it. It was more just like, if you had this action available to you, you could have gotten this higher number of points, but if you couldn't have taken it, then there's no explicit punishment for that.
Okay, so to follow up, in a slightly more simplified example, if we took any like German style or Euro board game where you could draw dead with the dice, you could have really good strategy in like Catan, right? Really good strategy, do everything right, but draw dead because the way the dice rolls happen just are very unlucky against the expected distribution of dice. So you could have the RL agent doing its job right, but get negative outcomes. So with sparse rewards, you would essentially you discourage that model from following a successful strat. That's my concern. But I don't think I understand enough about how this works to say how we're solving for it. The TCG example you give is complicated by the fact that it has this extremely arcane way of the action space being defined by the dice, much more so than a simplified, like, you get these numbers on the board activate or whatever. So maybe I don't understand the game fully or how this approach works, but that was my question, as uninformed as it is.
I see. I think I understand your question now. So your question is not really like for a single run, like maybe there's like a reward that would like influence the agent. Your question is like, if the agent had this good strategy and they were testing it out, there could be just some run where the dice rolls are so bad that they are, in comparison to other runs, the reward is going to be lower, right?
Yes.
Oh, okay.
This is also like if someone's playing poker, they've got like the amazing hand, and their opponent happens to have an even rarer amazing hand, right?
Right. I guess the kind of hope is that since all these dice rolls are kind of uniform, it's like in expectation, right? You would hope that these extremely rare, extremely bad scenarios, like an agent isn't just going to try this run once, right? Like they're going to just try their strategy once, and if it's really bad, then they just give up on it, right? So you hope that like, even though like it'll try like a few times, right, before it says, okay, I think this is a really bad strategy. So in those few times, it's just so unlikely that the dice are just so bad, like every single time, that it would actually make the agent think, oh, this strategy is something that's bad, not just that I got unlucky. I think.
Examples would you have to run before those dice even know? So he's right. I mean, sometimes I play Catan, and I'm like,
I play Catan with the same
whole concept is eventually, with enough samples, right, the roll of the dice will even out, and so then the individual tactics will start to rise up. How many do you think you would have to run before you could count the dice as being normalized?
Right. So I think in my presentation, I did say that especially for the randomized environment, you would expect 1.5 usable dice per round, right? There's 15 rounds. I guess if you count this like 1.5. Sorry, I'm not gonna on the spot probability calculations, but I don't think it should be too much, right? So,
6 to the 15th plus, yeah, 6 to the 15th plus 6 to the 15th plus 6 to the 15th.
I guess I'm specifically thinking about what the probability is of getting 1.5 or more usable dice in that round. There's 4 dice.
4 to the 16th plus 4 times. Right, 1 to the 16th plus 2 to the 16th.
That's a huge number.
Very
That's a huge number. Yeah. So this
expensive number.
That's why this is a very hard problem to train with reinforcement learning. It needs a lot of GPU to really, yeah.
Okay, last question. Yeah, your keynote. Do that.
This is for the dungeon creator.
Oh, hi.
Okay, so in my former life, like Conway's Game of Life was a giant predictor of like how to create dungeons and things. I don't know if you're familiar with Conway's Game of Life algorithm.
No.
It's from the 70s. It's really cool.
Okay.
And so cellular automata. So I was going to ask, like, did you try cellular automata to generate? Because that's kind of how it was done and still is done in like certain SimCity games. When you're generating like landscapes and features like that, where it actually like grows the roads and it grows the power lines, like when you're trying to just generate a map, right? And it's all based on the seed that you started with.
Mm-hmm.
And sometimes you get really cool results, sometimes you get like really bad results. But I was curious, like, did you try that? Was that like part of your generating these dungeons? Did that inform any of the choices you made?
So the question was that have we tried the cellular automaton algorithm for my project? So we didn't use that first because I didn't know about that till now. But we tried using basic algorithms to get something done in the Pokemon Fire Red space. But the problem we were trying to solve was to inject the Sokoban puzzles in a maze type scenario. So that was our actual goal than just creating a visually plausible good map.
Can you explain the difference between the wave function collapse?
Yeah.
And how it works?
Yeah, so the wave function collapse is a constraint satisfaction method. So let's say we have a tile set of, let's say, 5 tiles. So one is grass, one is wall, one is rock, and etc. So if we have a solution path, so the solution path can never be a wall tile. So the probability of the solution path tiles would be just the grass path or the maze path. So based on that, the adjacent tiles probability would be it can either be a grass path or a wall path, but it cannot be a rock path. Let's say, so rock tile. So the probability decreases and the entropy decreases, and it then eventually collapses into something which is actually based on the constraints that we have given to the algorithm.
Okay, this really sounds a lot like what I described. So
We're at lunchtime. Do you want to, Julian? You want to laugh? Keynote privilege.
I know. I'm not gonna hold like a long talk about this, but I do. Basic problem.
Take the mic. Take the mic so the stream.
Sorry.
The basic problem is that both wave function collapse and Salyer automata are at the core local algorithms that look only at the next tile. And the problem that a lot of these, like Pranav's work here, a problem that a lot of these approaches try to solve is how do you reconcile that local algorithms based on adjacency constraints are good at capturing visual style and various other kinds of style, but it cannot capture global things such as playability. Is this thing reachable from this? So there's been a bunch of different ways of trying to solve this and combine this in different ways. So this is where Pranab is presenting is one way of doing this.
I'm Dr. Luke Dickin. I'm head of AI for Take-Two Interactive. So a little bit more about me. I've been kicking around the industry for about 20 years at this point, and I kind of feel weird saying that out loud because I don't feel old enough to have been doing anything for 20 years, but here we are. My first 3 degrees, which is already too many degrees, were in kind of AI theory kind of stuff. So bachelor's in very theoretical AI. My Master of Science is in kind of more roboticsy theory, Master of Research in very roboticsy theory, and then PhD. Back when I was doing my PhD, you couldn't really do a PhD in games. So it's in simulated virtual environments, because that's how we got away with doing game stuff without saying games. Fortunately, things have changed a little bit these days, and we are now talking about games in a university setting today. And that's something that you didn't really get to do maybe 10 or 15 years ago. So as Andrew was saying, I was the first IGDA board member from outside of North America. That was like 2013. So that's the definition of international we were going with in 2013 was US, maybe Canada. And I was the first guy from Europe on that board. And then I led the IGDA Foundation, which is the charity side of the IGDA, for about 7 years, from 14 through 21. I joined Zynga also in 14, joined as a data scientist, bounced around a bit internally, led the central analytics function for a few years, and then in 2019, we founded an AI R&D group. And that's where 3 of us kind of carved off, sat in the basement, got off everybody's radar. And you may have noticed the conversation about AI has changed a little bit since 2019. So GenAI came to the fore, and we had a whole bunch of executives who said, hey, we've got an AI team. This is your problem now. To which I said, oh, thank you for the box of hand grenades. We are kind of leading governance, or we have been leading governance around AI for Zynga for the last couple of years. There's a lot of AI tech coming out constantly, kind of an onslaught, and it's going to be a theme of kind of talking about this stuff. Some of it is quite sketchy. Most of it is at least somewhat sketchy. And it's our job to kind of make sure that, like, the absolute worst things definitely don't happen, and kind of be the voice of, like, what should be happening and how we should be kind of thinking about these things in a way that is a little bit more human and industry-centric, as Andrew was kind of mentioning earlier. So I do have to get a few disclaimers out the way first. About 4 months ago, we moved over to Take-Two. People have forgotten that Take-Two bought Zynga, mostly because we were the biggest deal in the games industry for all of 10 days. And then Microsoft bought Activision for significantly more money, and suddenly nobody was talking about us anymore. But Zynga is part of the Take-Two family. And 4 months ago, I did move over to lead AI from the parent company. The way that Take-Two is structured is kind of we have the corporate kind of level, and then we have these labels, subsidiaries. They have their own policies. They have their own positions on stuff. I today am not speaking for 2K Games, and I am not speaking for Rockstar Games. And it's very important that I say that out loud up front. My first credit was on GTA 4. That was on the previous slide. That is the only reference we're going to make to GTA today. I am not answering questions. I don't know anything. But I am going to be talking a lot in generalities. And one of the reasons that I'm going to be talking in generalities is we don't want to talk about what we're doing internally. So I come here and I say, hey, these are the kinds of things. So I'm not going to be kind of hitting on very strongly on kind of what we're doing internally, what tools we have, and that kind of thing, because that would have triggered a lot of more conversations with lawyers for me. And I have enough conversations with lawyers, thank you. So we've been talking about AI now for the last day and a bit now. I don't think we've ever sort of taken a step and said, what is AI? So I'm going to do that for us right now. I have a really kind of big tent view on AI. Like my kind of position is anytime a computer makes a decision, that's AI. So by that argument, an if statement is technically AI. Questionable, but one of the things to keep in mind is that the computer making a decision is the attribute of intelligence. And we know that, there are times when the intelligence is not that great. And, an if statement, probably not the most sophisticated thing in the world. Maybe would be sophisticated enough to run Go, but that's okay. Because at the end of the day, some humans are not that smart either. We wouldn't say that Peter Griffin hasn't got the attribute of intelligence, but we would say that, like, from a qualitative point of view, maybe he hasn't got a significant value of intelligence. So it's more about, when we think about AI, we're thinking more about like the attribute rather than the quality. And that justifies me talking about a whole bunch of stuff this morning. So, quick pop quiz. When do you think the first article about game AI was written? Okay. Anybody got a different answer than 1980?
65.
65? Anybody else? We got 80, we got 65. 2004. Okay. $1. 1973. Okay. You guys want to know when the first article on game AI was written? We've been talking about this stuff for 250 years at this point. And that is a point that kind of gets drowned out by a bunch of San Francisco tech bros who want to really convince you that this is something that they invented 2 years ago. In 1770, there was this thing called the Mechanical Turk. The Mechanical Turk was an artificial chess player. And this thing lit up the kind of Bridgerton era kind of social scene. It got toured around castles and ballrooms, and everybody was talking about it because you could sit down and you could play chess against a machine. And that was mind-blowing in 1770, and you can imagine that that was pretty mind-blowing in 1770. Now, about 50 years later, there was a fire. And as a result of the fire in the museum or storage room or whatever it was, they ended up figuring out how this thing worked. And the way that it worked is that it was this kind of, you can see the kind of mannequin of the dude and a big table with a chessboard on top. And it turned out that inside of the table, there was a little space where you could put a person and they could pull a bunch of levers. So this did not actually deliver artificial intelligence, but it's kind of like, it's put it in the zeitgeist since 1770. Now, yesterday's keynote covered a whole bunch of history of AI, so I'm not going to repeat too much of it. But there are a couple of things that didn't come up. And kind of thinking about what the modern era of game AI has looked like. I always reference Miss Pac-Man, which is a game from '82. That was the first time, at least, that we've been able to find that there was non-determinism in the non-player characters. So if you look at the original Pac-Man, you can actually solve that to optimality because the ghosts in that game will respond specifically to your input. So if you go left to begin with, the ghost will always, let's say they go right, they will go right every time. And they will have the same set of responses to the same set of inputs. And that means that for Pac-Man, there is actually optimal ways of playing. And you can go online and you can find these. I don't suggest that you pay that much attention to it because, like, who wants to follow instructions on how to play a game? But that happened. And then Mr. Pac-Man came along and that wasn't true anymore. Those ghosts had personalities and they had biases around how they would respond, but it wasn't deterministic. So for the same set of inputs, you wouldn't necessarily land in the same state. So that's kind of where things started to get a little bit interesting. And then I always like to touch on fear because everybody in the game AI community always likes to touch on fear. It's been 20 years. We probably ought to get over it. But fear is a great example of something from academia making its way into an industry game. So fear uses a system called the Goal-Oriented Action Planner, GOAP. And what that meant was that there was a guy, Jeff Orkin, who's still around today, doing some really interesting stuff at a company called Bitpart.ai, so shout out to Jeff. But GOAP allowed you to kind of combine finite state machines with a more kind of planning-oriented kind of way of substituting things in. So it created a world where the NPCs were actually able to kind of be more responsive, be more kind of intentional in how they were acting. So that's a great example of work that was done in academia for Jeff's thesis, being picked up by, I want to say, Monolith, and kind of put into a game and driven forwards from there. When we talk about game AI, for the last 20 years maybe, we've been talking about this kind of stuff. Making the bad guy shoot back, making the soldiers duck behind cover more realistically. It's been a point of contention for me for many years. Obviously, a couple of years ago, the monkey paw curled, and now we're talking about things from a very different lens. But you know, we've been talking about NPC characters, but there's so much more that we can do with AI. So just a couple of examples here. I know No Man's Sky came up yesterday, very procedurally driven kind of space, a whole bunch of worlds and universes kind of being created procedurally. Left 4 Dead is also a really good example of how we can kind of push the boundaries of how things work in games. So Left 4 Dead is another interesting example of technology moving from academia into the industry. They use what's called a hierarchical concurrent state machine, and that was developed by the University of Idaho as part of a driving simulation system. And it allowed them to kind of control the pacing and be adaptive to user input and still deliver experiences that needed to happen. So you can imagine in a driving simulator, like if you're trying to teach somebody how to drive, then if you've planned a scenario where they get cut off in traffic and you want them to like respond with hard braking and all the rest, you need to be able to do that independent of how they've been driving previous to that. So that has to kind of just happen at the right time in the right way, no matter where that car has come from, no matter where what the velocity of the driver's vehicle is. So they developed this system that allowed them to kind of like modulate a scene on the fly effectively. And the folks at Valve said, hey, that looks really cool. Why don't we make zombies about it? And Left 4 Dead actually follows what's called it follows like a narrative pacing arc of horror movies, which is, I don't know much about this stuff and I'm in a room with a bunch of narrative people, so pardon me while I butcher things for a couple of minutes. So narrative pacing in horror movies kind of, it starts chill, builds up, the intensity builds, and then there's like a peak intensity moment where like all the things are happening and all this stuff is going on. And then like the pace kind of relaxes, the intensity kind of dials down, and you know, your group of teenagers who have been chased through the woods get a couple of minutes reprieve, and then the whole kind of cycle starts over again. Now, how do you bring that into games when, you know, the players are going to do different things and all the rest? Well, you use one of these, or a bunch of these hierarchical concurrent state machines, and you're able to kind of hit that same pacing where even the weather effects, the ammo and stuff that you're picking up in the world, and how many zombies are spawning and how they're interacting with you, are all under control of an AI director. And the director is managing that experience in real time. So these are just a couple of things about what we've been able to do for quite a while. Before folks like Sam Altman turned up, we were doing cool stuff. So that kind of brings me to this taxonomy of game AI, and this is actually something that I probably can say we've kind of got internally at this point. It's kind of trying to break out AI into the components that are it. Because at the moment, everybody wants to talk about this one. But when you're making games, all four of them, and arguably, the three on the left are the more impactful ones, and then the one on the right, questionable. So making sure that when we talk about game AI, we're talking about all of it. We should be using all the tools available to us, not just glomming onto the hot new thing that we read about on TechCrunch, VentureBeat, name a thing. But this is called the Transformer Conference, so we need to talk about some of this generative AI stuff, so let's do it. We've talked yesterday about diffusion models and generative art and chat assistants and LLMs, so I'm not going to go kind of crazy deep on this stuff. You kind of have seen a bit about how it works already. This is kind of like, it didn't come out of nowhere. This is one thing to kind of think about on this slide is like, it felt like everything kind of exploded in kind of maybe 22, 23, but this is building on work that has been coming for a long time. Transformers were, I think, that architecture was maybe 2019, the paper was published. And, adversarial networks have been kicking around for a while. Like the things that are the kind of theoretical algorithmic building blocks have just been kicking around for a little while. And honestly, the big breakthrough was taking those kinds of systems and putting them into a chat interface. That's what OpenAI did that was transformative, was not anything about necessarily the math of the thing, but it was about the UX. However, we've got to acknowledge a whole bunch of lawsuits about this stuff. They have just taken everything from the internet and shoved it into one system, and that probably shouldn't be legal. And we'll find out over the next year or two if it is. So there's a whole bunch of lawsuits, and many of them got referenced yesterday. Consistency is still a problem. Control is still a problem. These are things that are not really solved, and they're baked into the nature of how the technology and the algorithms actually work, to a point where there's a lot of effort being put into solving them in a way that is like, well, can you overcome the inherent infeasibility of the algorithm? Or should we maybe stop just pouring a whole bunch of compute at this and hoping that it all gets solved? So probably, if you're following the AI space, you've probably heard the word agents being thrown around over the last 3 to 6 months. Agentic systems, multi-agent systems. So about 20 years ago, I took a course on multi-agent systems. This diagram is from a paper, I think this one was from 91. And the point I really want to drive home is most of this stuff existed already. All the buzzwords, all the stuff, it's just a bunch of people who are reinventing the wheel yet again. You remember when they decided that they were going to reinvent a bus? And they were going to do like, oh yeah, we're going to do this thing where like, we're going to get big Ubers and we're going to drive them down the street and you can press a button on your app and get on the, yeah, that's a bus. We're going to do this thing where we're going to build a tunnel and we're going to put like a car in it and it can go along and you can get from point A to point B. Yeah, that's a fucking subway. Like, what are we doing here? So we need, this has come up actually a few times yesterday and I'm really happy about that. Because when I say that these lawsuits are outstanding, when I say that they've stolen work from people, like it's important to remember that. I don't know what the answer is because the way these systems work, they just grab everything that they can and then by the time it gets to the finished product, the math has obfuscated what bits of what are being used. So attribution is going to be hard in these current architectures. That's not a reason not to have the conversation. At some point, I've got to be able to look artists at Zynga at Take-Two in the eye and say, hey, you're not why we're putting you out of a job, or I'm not why we're putting you out of a job. And that's an important thing, right? Like, you can draw a line from where we are with AI technology today to the end of capital A art. And that should be scary for everybody at a societal level. The Netflixification of kind of content is maybe not the best thing in the world, but doing that at scale across an entire set of industries could have some really gross implications for everything. We seem to be very much speed-running idiocracy at this point. So, that's great. All right. So the session's called Practical Applications. But honestly, having a rant about some impractical applications is a lot more fun. So that's where we're gonna start. All right. Haven't seen one of these for a little while, but a lot of people kind of think that we're going to take prompt to game. I can write a paragraph, press a button, and get a game. DeepMind's Genie system on the left there has a bunch of prototypes that they've kind of put together. These are actually grabbed from their website. And this is part of the kind of shell game that's played with games. So games are kind of three different things. We've got games as art, games as technical product, and then we've got kind of games as toys. And those three things are quite distinct. This thing on the left is a toy. Like, it's a little platformer that looks good, but it's not a game product, and it's not really a piece of art. It's a toy. So we're using the word game in different ways and kind of in the kind of framing of the thing, obfuscating the fact that, if they can generate this, that's great. They can't generate actual commercial products. That's not a thing that is going to happen really anytime soon. And this system, L.Liu on the right, is a really interesting thing. It's aimed at kids, and it's effectively trying to be GenAI Roblox. And part of my question is like, well, why is Roblox not going to be GenAI Roblox? But what they're doing here is, instead of kind of doing the kind of bait and switch on this being kind of a toy game rather than a game, is that these guys are actually getting a lot of success by really limiting the scope of what that game environment is and can do, and kind of constraining to a whole bunch of, or a small bunch of verbs, gives you more control over the space. So that's kind of how these guys are managing to get prompt to very specific implementations of things. So it's not that it kind of can't be done, it's that in order to kind of make it happen, you really have to be very clever about how you define a game. I think I'm going to piss some people off with the next slide. LLMs for NPC dialogue. And NVIDIA's Covert Protocol demo, which came up yesterday as well. If I have to deal with one more group of people who think that the best thing in the world for games is to take an NPC and anchor an LLM to it, I'm going to lose my mind. This demo, it's fine. Getting hands-on with it, you start to kind of see that some of the stuff that they put online is the good parts of it. Unsurprisingly, that's the game. LLMs anchored to NPCs sounds great, right? It sounds like what should happen. Except, so Sid Meier of Firaxis fame, so obviously Microprose, Firaxis, part of the 2K family, so I am quoting somebody from my own company, but he defines a game as a series of interesting choices. Connecting an NPC to an LLM gives you an awful lot more choices. Doesn't make them interesting. And one of the key things here is that when we're talking about in-game, we're talking about curated experiences. We're talking about systems that are trying to say something. And when you just connect them up to like an all-seeing kind of like, hey, we can just say a bunch of stuff, you lose a lot of the intentionality. You lose a lot of the drive and the point of the thing. And if you look at this Covert Protocol demo, it's very tightly constrained. Taking a step back and thinking about a interview that John Riccatello did when he was, during his stint as Unity CEO, sorry. One of the things that he said was like, wouldn't it be cool if you could play, when you're playing Madden, you could wander around the stadium and like you could like sit in the stands and watch what's happening on the field and talk to the person next to you and like you could get the grandmother's lasagna recipe. No, that wouldn't be cool. Like, I don't start Madden to learn about lasagna. I start Madden, well, I don't start Madden, but like you play Madden for the NFL and for the running the game side of it, not the let's go talk to random people side of it. And this is where like the intentionality of the thing really matters. What are these characters supposed to say? What is their role in the story? Because if you make them fully embodied, you could go out into the real world and talk to fully embodied people out there. It's not super interesting. Vibe coding. Vibe coding is one of the best things in the world ever for about an hour. So for those of you, this came up yesterday as well, but for those of you who don't know, vibe coding is when you sit with one of these assistants and you say, hey, I want to do, you know, X, Y, Z, and it goes off, writes a bunch of code for you, and you run the code, game over. And that's great. So, you know, for a simple project, I want a script that does one thing, great. So one of the things that I do a lot is I DM D&D games, and I'm running one right now that's got, so for the nerds in the room, it's a West Marches game, so there's 26 players in this game, there's a whole bunch of scheduling to kind of figure out, right, I'm going to vibe code a Discord bot. So got up and running, got a thing, got it hooked into Discord, got some basic commands going, right, now I want to anchor into the Calendly API for scheduling. Well, first off, it just made up how that API works. But the more the complexity that got introduced with this bot, the more this thing started just tangling itself up in knots. And then you say, hey, actually, this bit and this bit need to be abstracted out, and I need to refactor this thing. Everything breaks. Because like, once you achieve a certain level of complexity, vibe coding is not going to get it done. But you also don't know how your code base works, and it probably doesn't work the way that it looks like it ought to work because it's not been written by a person, it's been written by an idiotic machine that just went, this works. And that's a problem. Because the more that we rely on the vibe coding side of things, the more that we're going to get tech stacks that we don't understand, that we can't maintain, that are just a disaster. So we're kind of exponentially accruing tech debt when we vibe code. And we were already kind of accruing tech debt a little bit faster than we ought to be. So this is kind of problematic, probably not today, but 18 months from now, wow, that's going to suck for everybody. All right. Regression to the mean is a really interesting thought with GenAI. GenAI has been trained on everything. It's been trained on the entirety of the internet. It's been trained on a whole bunch of images. It's not been trained on the good stuff. It's been trained on the good stuff and the bad stuff and the mediocre stuff. And that's going to look like a Gaussian curve. And that means most of it's going to be mediocre at best. And this kind of ties back into vibe coding and code assistance. You know, one of the things that I've definitely found is that if you're a bad coder, if you don't know how to code, if it's not necessarily, you know, you're not an engineer, you're maybe a designer, great. A coding assistant will make you a mediocre coder. Fantastic. We love that. If you're a good coder, coding assistant will make you a mediocre coder. And this is kind of like the ongoing problem. So in this image here, this is a sailboat. And it's an image out of, I think this one's out of Midjourney from maybe 6 months ago. So argument that maybe things have got better, but they haven't got this much better. This looks boaty as fuck. This looks amazingly like, hey, this is a sailing ship. I know what's going on. We're on the ocean. There's a whole bunch of waves. Great. Now, everything that comes out of an AI system, to me, looks pretty good. I've got the aesthetic sense of a brick. But the thing that I do have, because like my first job was working at a boatyard. I've been doing a lot with boats over the years. I raced sailboats back in Scotland. So I don't know a lot about art, but I know a lot about boats. This is wrong. That being tied off there, that's weird. That shouldn't be done. That is just hanging out. That's not connected to anything. A whole bunch of these ropes do not exist for reasons except to give the vibe of boats. And like, if you don't know what you're looking at, you can look at that and go like, yeah, that's boats. But when you do know what you're looking at, you can look at it and go, wait, hang on, what? Somewhere I've got a different example where the wind is going 180 degrees at different parts of the boat. Like some of it is going to be this way, some of it's coming this way. Because that's not conceptually something that's being represented in these systems. You know, they are just kicking out like, hey, this looks like boats. And if you don't know any better, great. People in your audience, people who are your players, will know better, and this is why a lot of people are dragging, I mean, it's not the only reason, but it's one of the reasons that people are dragging these GenAI systems. It's like they're not producing stuff that is actually coherent. They are producing something that just kind of highlights a vibe. All right, that's the ranting done. And we're a bit short on time, so let's just keep going through some practical applications. So this is the kind of stuff that I think you should be thinking about when you come to actually implement these things. First question I've got for people is like, do you want to deploy this stuff at runtime or do you want to deploy it at dev time? That's a key consideration. There are certainly areas where deploying an AI system at runtime might make sense, but in general, like having it help with development is probably a safer bet. And this actually comes back to the LLM example. So I talked about how the choices wouldn't be that interesting. Particularly in the free-to-play space, it also creates a really big problem for us because it's not a monetized, or generally, it's not going to be a monetized thing. So your players are going to be able to interact with these NPCs, and that inference has to happen somewhere, and it's going to happen in your tech stack, whether you might, at low scale, maybe you're running that kind of on a desktop machine, but at big scale, you'll be running that in the cloud. So what happens the day that your game, whether it's on itch or Steam or wherever, makes it to the front page of Reddit? Or gets pirated, and this actually happened to somebody. Game gets pirated, and suddenly they have a whole bunch of non-paying users in there. But when they talk to those NPCs and they ask all those questions, they're racking up bills. And that's a problem, because now you've got folks who are not paying, but are costing you. And the margins in games are not so big that you can really afford to do that, particularly because, like, if you want people to monetize somewhere else in the game and you've given them a reason to just hang out and chat with a buddy, you're not moving them to where you need them to be. You're just having them sit and accrue a cloud bill for you. That's concerning. So this is one of the reasons that I think that dev time is a better kind of place to deploy this stuff. The other thing is control. If you deploy it at runtime, you don't get any kind of directorial or authorial control over what it's doing. You just have to trust that it's going to do something that is good for users. If you're at dev time, you get to curate the hell out of it, and you can throw the stuff away that isn't useful. So that's kind of practical piece of advice number one. Stick this stuff at runtime. Stick this stuff at dev time, and maybe be a little bit more concerned about kind of thinking it through when you're putting these things inside of the game themselves. Tools or tech. We talk a lot about models. We talk a lot about all the different things that are happening out in the world. Yesterday, Adobe dropped Firefly v4. It's got a whole bunch of improvements. It's great, allegedly. I don't know. Firefly version 5 is going to be a few months around the corner. ChatGPT is going to have some new image things. Diffusion models, Flux, all these things are leapfrogging each other constantly. Stop caring about the models. The models kind of don't matter. They're going to get incrementally better over time. What matters is the tools and the UX and the workflow. At the end of the day, if you're building this stuff to empower artists, which is what we're trying to do, it kind of doesn't matter which model you're using. I mean, for different applications, different things are going to be better suited. But if you're in a world where you can kind of build out over a bunch of them, it doesn't matter which one's on top. But then you can have a consistency of UX, and you can actually build tools for art teams or for dev teams, for anybody who's working in the space that is consistent, that does what they need it to do. Midjourney caught everybody's attention as a Discord bot, basically. You could go onto Discord and you could type in some stuff and you could get an image. Great. That's not a great workflow if you're a dev studio. Like, that's not great to have to then export out of Discord, do the thing. Took a while for Midjourney to put a web interface in. But stuff like this is pretty close to some of the art tools that the teams are using already today. So they're familiar with it. They understand layers. They understand how to export stuff. Show them the new stuff, get them working with it. But at the end of the day, if you treat it as a tool and you don't obsess about the models, then the tool will be the tool a week from now, 6 months from now. And it doesn't matter who's doing what in the space. You are basically future-proofing yourself. An area that we kind of focus on asset generation, right? We focus on kind of how we can use it for concept art. How can we maybe use an LLM for designing narrative stuff? Those are low-hanging fruit of varying quality. But some of the stuff that we don't talk about is how we can use these things elsewhere in games. A lot of games have chat in them. A lot of games that have chat in them have massive moderation problems. I mean, this is not new information about how these games work. Systems like this are effectively natural language parsing. And that means that you've got a really good ability to actually, instead of doing kind of player-facing or asset generation or anything like that, just on the back end, be running systems against your chat feed and be like, okay, well, now we're in a much better, more robust position to find stuff that's bad inside of our game and proactively get involved. That's a big opportunity. That's not something that really gets it talked about in, it gets talked about in places, but when we're talking about it in a setting like this, it's so easy to focus on like, hey, this is how we're going to get 3D models and 2D images and audio. But stuff like this actually is the stuff that we can't do today that isn't really as ethically concerning because like we can't do this. We're not putting people out of a job because we can't do it. So by putting systems like this in, we get a better experience and there's not as much of a human cost to it. And then one thing to always keep in mind is that if you're running a game studio, you're a business. And everything that applies to any kind of enterprise applies to you. Whether that is, an email rewriting assistant, whether it's something that's going to help you parse contracts. I think there's a system called Harvey that's good at that side of things, whether it's helping you with decks, helping you with branding. But these, again, these are the things that are boring as hell, but as a business are becoming kind of table stakes. And that's where there's also kind of not as much emphasis. But grab these things, play with them, be aware that from a 3D object, 2D image kind of point of view, there are legitimate concerns and there's concerns on the training data source. But at the same time, the obvious places that you can see to just grab onto and go from a game dev point of view are not the only ones. And when we think about practical applications of AI in games, we could do so much previously. We could do a lot of stuff with AI that a lot of studios thought was witchcraft and did not want to go near. And one of the things that's cool about this moment is that they all want AI now. Everybody wants to do stuff with AI. Now, in their heads, they mean LLMs, they mean diffusion models, but it's all AI. Level generation is something that we've opened the door to because people are more receptive to the conversation. This is an interesting demo from early 2000s, I believe. This is Silent Hill Shattered Memories. And what's really interesting about Silent Hill Shattered Memories is that they had a very rich personalization system. And that was built around an ML system and a player persona system. It's Silent Hill, so it's kind of horror themed, and it opened in a therapist's office. And the therapist is asking questions and the player character is answering those questions. And the conceit of the thing is that you are kind of getting a psychiatric evaluation. What's actually happening is that the player is getting a psychiatric evaluation. And that created a world where they actually developed a whole bunch of content for this game and they actually switched between it. So this character is this character. And it's this character. And depending on how you kind of tested on that initial psychiatric evaluation, you get a slightly modified experience. Some billboards get swapped out. Some characters get swapped out. There's a slightly different tone shift. Now, the way that they did that was to make 3 sets of everything. It's not the most efficient way of doing it. But at the time, this was groundbreaking. And this was stuff that really kind of showed what personalization can do. Because we were playing different games. And now, we see that in branching narratives. Your playthrough of Baldur's Gate is going to be very different from my playthrough of Baldur's Gate. But that's based on choices, not kind of trying to assess what we think people want. And that's the important thing. My thing for the last 15 years has been that AI in games should follow D&D. The Dungeon Master manages that game experience. They start out by figuring out who's going to sit at the table. The social composition, the psychological profiling of like, well, I'm not going to put that person and that person together because that will go badly. Alternatively, maybe you do that. But a Dungeon Master is controlling the matchmaking, they're controlling the narrative pacing, they're controlling the combat encounters, they're controlling the economy. They're controlling all of these things in a human-led way. And if we think about what AI could be for games, ultimately it's about taking the Dungeon Master human away and replacing it with an AI, at least for me. And that's probably because I grew up as an only child in a bit of a rural situation where I didn't have people to play these games with. So being able to play them with fewer people, that's my jam. But this is stuff that we can do. We've been able to do it long before these new systems showed up, but we didn't compose all the pieces together. And this is kind of leading up to all the stuff that we're talking about. Cool. It's low-hanging fruit. The real question for me, the thing that I want to chase is, okay, what new game experiences can we give people as a result of these technologies? And I haven't got an answer to it. If I had an answer to it, I probably wouldn't be able to tell you. But this is the star in the sky. It's more important than we can make images quicker. We can, make our 3D objects just integrated into our pipeline. It's more important than all of that stuff because this is again stuff that we couldn't do before. We can't do it today either, but we're going to figure it out. So part of what I wanted to give you is a rubric of practicality. When we think about practical applications, how should you be thinking about it? Cost is important. And a thing to keep in mind is a lot of these systems are being sold under cost. Classic private equity and VC model where they did this with Uber. They funded the hell out of Uber. Uber came in super cheap, ran the taxis kind of into the background, and then Uber jacked the prices up because they got you locked in. That's going to happen with a bunch of these things. They are going to become more expensive. How do you control for that? How do you control for users who can touch things, maybe racking up bills like we were talking about earlier? Speed is a big factor. How do you make sure that you can make things fast? I mean, this is the promise of AI, right? You can kind of make your pipelines run a whole lot faster. But do you need to? Maybe, maybe not. So keeping in mind that speed is important, scale is also important. If I want to create a Silent Hill Shattered Memories, making 3 sets of content is 3 times the work. But there's a reason for doing it. So now we're sort of okay, well, let's do it this way. It's faster. Maybe it's a third of the time, which means that we can do 3 in the same amount of time. Control is important. Maintaining that authorial control is critical. Your game is supposed to be a piece of art that is making a point or saying something. Don't let ChatGPT say something for you because that's not remotely interesting. And like I was saying earlier, future-proofing. What's going to happen next is a whole bunch more models are going to get dropped and everybody's going to hype out about them and it's all going to be fine. They're going to be incremental improvements. So how do you make sure that you're agnostic to those improvements? If you're really tightly coupled with OpenAI, you can't benefit from DeepSeek, which came out a couple of months ago. It came out yesterday. DeepSeek came out of left field, and everybody was trying to scramble to react to it. A lot of where my attention is like a layer up, which meant that we could just kind of get DeepSeek deployed, and it was in the tools that we already had. So kind of keeping in mind that that is what's happening. We're in this kind of weird arms race between tech companies, and we're kind of caught in the middle. So making sure that you understand that that advancement is still going to continue. So how do you leverage it? Here's the big thing, though. This is the important one. So the original IBM is a computer can never be held accountable. Therefore, a computer must never make a management decision. I prefer this framing. But this is important. We can't abdicate our decision-making to these systems because they are not decision-making systems. They are predictive systems of spit out the next word. They don't know things. They don't understand facts. That's not a concept that's kind of part of the math. So one of the kind of core things that I often push back on is like, are we actually automating a business decision here? Because that's a terrible idea. Let's not do that. Let's make sure that it is assistive to a human, maybe, but the human can say, whoa, don't think that's right. Let's not do that. I've certainly seen proposals for like, well, we asked ChatGPT what game we should make. That's really bad. Don't do that. This is something that we're seeing across industries, right? AI is being introduced into insurance claim approvals and more often denials. That seems not great. Actual humans need to make decisions. These things can inform them, but if they're making the decisions, wow, things are going to end up real bad. Idiocracy might be the best case if we go down that route. The Matrix is maybe where we land up. So I did want to kind of leave you with some final thoughts, and I know I'm a little bit over, but I'll just jam through this as quick as I can. This is Pixar. And the moment that we're in right now feels a lot to me like where Pixar was maybe 20, 30 years ago. So Pixar started as a spin-out from the University of Utah. There's a bit more history and backstory to it. Creativity Inc. is a really good book if you're interested in this stuff. But the punchline is that the Pixar folks, Ed Catmull and his co-founders, wanted to understand what movie making with digital tools would look like. And at the time, the state of the art was Disney animation. Like Disney has always been the pinnacle of this stuff. And what they would do is they had a whole bunch of artists who sat and drew frame by frame. Now there's a world where you say, okay, we're going to be digital. And you can imagine the executives saying it in exactly that way. And what you do is you take Photoshop and you give them like a tablet and you say, cool, you're doing this digitally now and you're still drawing frame by frame, but you're doing it in Photoshop. Congratulations, digital. That's not what good ended up looking like. Good ended up looking like stuff like Maya, stuff like Autodesk, actually building 3D scenes and then rendering it out as 2D. What we're seeing today is today's workflows getting AI crammed into them, mostly to satisfy investors. Half of the features that are being rammed down our throats are not actually that useful. But they're trying to fit it into an existing workflow. What is the new workflow? What does it look like to make games in an AI kind of native way? That's a big outstanding question. It probably does not look like Photoshop, Perforce, all the things. It doesn't look like the tool chain we have today. We don't know what it's going to look like, though. The magic trick is done. Everybody wants to think that AI is this thing on the left. It's just going to go up and up and up and up and up. The next ChatGPT, the next Claude is going to be exponentially better than the previous one. It's not. Unless we fundamentally change the architecture, and that's some of what's kind of starting to happen in some of these papers, we're here. And we're actually here because everybody sort of started paying attention maybe here, but AI started here. AI started, best part of 60 years ago, 70 years ago. This is not a new thing. This is not something that's taken off and going up through the roof. It's something where we've had a step function, we've had a transition into these new systems, but now they're starting to plateau. They've been talking about ChatGPT 5 for a long time and how amazing it's going to be. It ain't here yet, and they've been talking about it like it's a real thing for a while. Where is it? And the answer probably is that they're hyping up their company to juice their valuation. And this next thing is probably a little bit better, sure. But is it like transformationally better? Probably not. The transformation has happened. Until we have some new massive breakthrough, we're not going to see that step function again. I want all these tech bros off my lawn. We're still here. And we've been here before. In the AI space, we have this notion of AI winters and AI summers, because this cycle happens to us constantly. Everybody hypes the hell out of machine learning or neural nets or expert systems from maybe 20, 30 years ago. It's the new thing. It's going to transform everything. It's going to be the thing. And then it doesn't. And we end up here. And nobody's funding this stuff. Nobody wants to know because it all got overhyped and overblown and it could never deliver on those promises. But here is where the interesting stuff happens. When you cut through that hype, when you get back to this is what these systems do well, and this is what these systems will never do well, so let's stop talking about them, and I can actually focus on the real opportunity. But wow, you need everybody here to calm down. So that kind of transitions into just a kind of quick shout out to my team. We're 25 people. We've got a range of AI folks, engineers. We've got some product managers and producers now. But we're kind of pushing on the boundaries of some of this stuff, and we're also pushing against the kind of inevitable tide of some of the other stuff. I'm not going to go through our projects. There is some stuff published around Spell Forest because we actually got some software patents on that, which meant we could talk about it because it's fully been disclosed. We are going to be growing through the year, so we are going to be opening some roles later on, probably next month. And we've hired our interns for this summer, but we do have postgrad internships generally. They'll be opening up in the fall. So that's kind of the this is the justification for why I'm here. I'm here on a recruitment trip. So let me leave you with these. This is kind of as best of an encapsulation as I can give you. Everybody's paying attention to the trees. Look at the forest. Look at the entire thing. Don't focus on what's happening with just the one tree, because everything across the board is impactful. Now, I keep kind of referencing the ethics stuff and the copyright lawsuits and all the rest. Genie's out the bottle. It's not going back in. There could be a ruling tomorrow from the Supreme Court that all these things are illegal, and they are still out there, they are still available, and maybe you can't run them on AWS because AWS will get sued, but you can run them somewhere and you can grab them from somewhere. This genie's not going back in the bottle, as much as you might want it to, as much as we all might want it to some extent. The final thing is this. These things are dangerous. And one of the big concerns that I have is the lack of any kind of rigor or common sense being applied by some of these tech companies. Look, you can deep fake a video. Cool. What are the social implications of that? Because that's scary as hell. I think of this stuff as plutonium. Now, there's cool stuff you can do with plutonium. There's also some really dodgy stuff, and in either case, you're probably going to end up really screwed if you're the one doing it with plutonium. It's not to say that it's inherently bad. It's not to say that it's inherently good. You know, it keeps coming up that, you know, AI is just a tool. To some extent, that's true. But tools can be used for bad and for good. And it's important to be mindful that just because it's a tool doesn't abdicate our responsibility to use those tools effectively and ethically. And I think that might be it. Yeah, okay. So if you're interested in those roles that are coming up, follow me on Blue Sky or on LinkedIn. I'm deliberately not giving you my email address because, as the conference organizers are aware, not super on top of my email. But yeah, I guess I don't know how we are for time, but find me through the day if.
Questions, Doug? Do you want to push back a couple more minutes for? Sure. All right. Well, thank you, Luke. If you have questions, we'll shout them out to Luke. He'll repeat them into the mic for the live stream. So.
The what, sorry?
I'll bring that around later.
Oh, okay.
Yeah, I don't know if everyone can hear me. I don't have
I'll repeat.
Okay. Yeah, I just wanted to ask if you wanted to give any comment about matchmaking and what might be possible in this new era with, you know, diminishing toxicity, promoting coalescing teams, or finding better matches.
Yeah, so the question is, like, how does matchmaking change under GenAI? And I think the answer is it kind of doesn't. It's one of those things where, like, matchmaking with Big Tent AI, super good. But the techniques that are actually going to work there are more on the machine learning side of things than they are, like, the neural net spitting out stuff. What might be interesting is how we think about players. And how we think about something that's describing players in order to feed into a matchmaking system. So I could imagine that there might be something there in terms of, like, hey, summarize this player's behavior so that I can then feed it into a matchmaking system. But the matchmaking is always going to be math, I think.
Yeah.
So, you know, I just want to ask, my general problem with AI is that, like, when you make a thing, the AI doesn't know why you're making the thing. So, like, when it comes to generative AI, do you think there's going to be a point anytime soon where it's just like, okay, I'm making a game about, I'm making a game that's a commentary on, I don't know, religious tensions and stuff like that. Do you ever think there's going to be a point where the AI is like, okay, I understand your perspective and I can construct a story, like I can construct a space opera that's essentially telling you the same thing about that, and it being like something that feels human-like versus it still being just like LLM garbage.
So for the stream, the question is, and I'm going to summarize, yell at me if I get it wrong. So the question is kind of like the intentionality. The intentionality of kind of inferring context from prompts in order to kind of produce more intentional output, I guess. I think there are ways that could be a thing. I think that in general, it requires a kind of additional layer of complexity that I think is going to be hard to actually achieve. But you could imagine that rather than a single holistic system, you could almost imagine like buzzword alert agents, but like one agent that's about intention feeding forwards into something that's about background that's kind of, so you could squint and kind of see a hypothetical world where you can compose a system like that. Is it going to be effective? Question mark.
Okay, I'll ask the last one. So in the chat, loved it, by the way. Someone talking about intentionality specifically said that what you said, please plate that in gold, crochet it on a pillow, and I will sleep on it every night.
Okay, so, sure, okay.
But one area we didn't really touch on was AI for QA.
Yes.
So all of us who make multiplayer games, we've used our own AI to test the multiplayer forever. But are these is there a role for any of these new tools really to come into the QA process?
It's a great question. Model AI got referenced yesterday. Really big fans of Model. They have a really good team over there, and they are pretty stacked. A lot of the interesting work in QA is more focused on reinforcement learning. Now, what the GenAI element can get you, and I believe Model has this feature and showed it to us at
Hey, glad everyone enjoyed lunch. Thank you to everybody for making this all happen. Thanks to our volunteers and the staff, which included Dove Jacobson, yay! Dr. Victoria LaGrange, yay! Dr. Dylan Goldblatt, who's ignoring us right now apparently, but we'll give him a cheer anyway, yay! And myself, Andrew Greenberg, in the GGDA. So, a few housekeeping orders, and I guess I'm not on the live stream, but that means I have to be kind of standing right in front of them, and that'd be kind of obnoxious. I'll wave. Pretend it's Julian talking while this is all happening. So, as Julian was saying, we do have T-shirts still left, but apparently they're all women's sizes, and for some reasons they're oddly short. So if you want one, and you've got someone in your life to give them to, let us know, and we will hand them on off. We are almost out of T-shirts. Would love to not carry any of them back, since they don't fit me or make me look that attractive these days. All right, next order of business. After this are the workshops. We'll only be streaming one of the workshops. That'll be Tim's on Discord, using Discord for Game Gen, so keep tuned for that one. The others, because you're not here, are those of you watching live stream, you don't get to enjoy it, but everybody here does. And they're going to be in the classrooms. The classrooms. You'll walk out of this room to the right. You'll see a sign saying classrooms. You'll go past that sign till you come to the next set of signs saying classrooms, and it's down that classroom hall. So check those out. Very good workshops. Looking forward to all of them, and I'm sorry I cannot be in all of them. Yeah, question. Yes, just the one Discord one. The rest, I'll see about recording another one, but it won't be streamed. Yep, absolutely. All right, and with that, I'm going to turn it over to our esteemed group of panelists to introduce themselves and let us know what is coming next in the world of AI and game development.
Alrighty. Well, howdy everyone, both here and on the stream. How's it going? My name is Mike Geig. I am principal advocate at Unity Technologies, and yeah, we'll get into the whole what's coming later next. I don't feel like I'm supposed to be answering that right now, but that's who I am. If anyone ever wants to email me, I'm just Mike at Unity. I've been there quite some time. What's up?
Hey, I'm Julian Togelius, for those who didn't see me yesterday, or for those who did and quickly forgot. I'm a professor at New York University, and also startup founder and various things, and I work on AI and games since forever. But I'm not really a game developer. What's coming next? Half-Life 3.
Should have put you on the end. Oh boy. Hi everyone, I'm Timothy Johnson. I am the CTO of Little Umbrella. We make social games that are driven by AI. If you saw my talk earlier, then you know a little bit about it. If you haven't, if you're watching on stream, go back 2 hours. Yeah, there you go.
I'm Aaron. I'm CTO co-founder of Jam & Tea Studios. We make AI video games. Our first one is Retail Mage. I also co-host a podcast called Playing with Inference, where we've actually had some of these guests here. So if you haven't gotten enough of them yet, you can go to Playing with Inference and get a whole another hour of them, where we look at the intersection of generative AI and the game industry.
Nice.
Are we starting with generalized questions?
Yeah, Mike, what's the future?
Check the conversation where you left off.
Well, I know exactly where the future is. It's in Mike. Here you go.
So, I want to preface by saying that I backed HD DVD. I thought for certain HD in his title would make it win over a Blu-ray. I don't even know what that is. Luckily, it didn't matter because all physical media died shortly thereafter, and now everything is streaming. But I still collect vinyl because that's apparently what cool people do. Even though, yeah, it just is way more inconvenient to listen to. So I know the point is the sacrifice, right? So that's where the future is, sacrifice. When it comes to the future, I am notoriously bad at guessing. I think I've been wrong every single time I've ever made a guess about technology, even though I've been very, very certain. So I don't want to postulate or even assume. I have no idea, right? And the funny thing is, I don't think any of us know. I think the next great idea is going to come from some little kid who's going to have some brilliant idea, and then the world's going to go, that makes sense. Why didn't I think about that? That's so obvious. And then a whole new genre or whatever will explode forth, the sort of Minecraft student project, whatever, that just reinvents things. So the future is open, I guess, and it's really up to people to innovate and try things and figure out what doesn't work more often than not, to then figure out what does. And that's how I view it. So if you were hoping I was going to give you some insights, I don't have it because I'm wrong often.
I mean, as for myself, my best way of trying to avoid being wrong is to just not commit to anything and just not really have strong opinions. I'm very bad at not having strong opinions. I have all kinds of weird strong opinions, but I hold them quite loosely, and sometimes I take them just to annoy people. So back like 10 years ago, I used to go to humanity-style game dev conferences, so like game studies conferences, and tell them, oh, we're working on replacing all of you, and then they would start throwing things at me. I don't do that anymore because this time it could be taken seriously, and they may throw like hard items at me. And then I would go to AI conferences and tell them that they know nothing, which I still like doing that. But okay, so let me pick out a concrete thing, and it's not Half-Life 3, it's neural game engines. So for those of you who have been watching this space, there's been a series of this is very convenient because I was planning to include some of that in my talk, but didn't have time. So I'll say it now instead. There's been a series of work over the last 2 years or so where a large neural network, typically a diffusion transformer, but sometimes just a diffusion model, has been used to kind of generate the game itself. To run the game as a game engine. And the thing that made people sit up and really take note was something called Game N Gen. So game and the letter N and Gen, which was a diffusion model trained on Doom. And in that you could play Doom on a consumer GPU. Of course, it was a crappy version of Doom. The rendering was off and blurry. It needed like 100 times more compute, or maybe 1,000 times more compute than the original Doom did, because you needed a big, beefy GPU to run it, whereas the original Doom ran on like nothing, basically, by today's standard. And it also notoriously has, I recommend you to play with it. It's actually really fun because basically it has very little temporal consistency. So the best thing in this, it looks and feels just like Doom, except it's blurry and weird. And then you face this terrible enemy. What are you going to do? Are you going to shoot him? You can also just turn around, do a 180, and then turn back. And chances are... Yeah, you can look down. Yeah. Chances are he's not there anymore because it has no memory. But this was something that I know that people in large game studios took very seriously, and I know some people who went ahead and just re-implemented the whole thing just to see what it could do, and it's like $40,000 of compute, I heard. So where was it going with this? So. Earlier this year, meaning like a few weeks ago, Google released Genie 3, a generative world model where you can prompt it and you get like a game world you can play in to some extent. And it has all kinds of issues. It needs like huge amount of compute to run. The prompt following isn't very good. You certainly won't get a good game. You're restricted to a very limited move set. There's all kinds of things. I played last summer with a pre-release sort of closed demo version and enjoyed taking it to the breaking point, which was very easy. But the fact that it works at all and that it's visually so good as it is, it looks beautiful. It's like, it's like what people who don't play games believe that video games are like. They look amazing, but the gameplay is like not there. Now this made stocks drop. A lot of game developers and other companies such as Unity and others, the stock just dropped a lot because people were thinking that, oh, AI is coming for games and eating it. This is not what I think is happening. So I wanted to kick off with letting my peers, dear colleagues here, have their opinions. Where are neural game engines taking us? I have a bunch of opinions, but I'll wait with those because they're wrong.
You call me your peer. Take that, Mrs. Diamond from the first grade.
I'm happy I'm not the oldest here.
It's time to let it go.
So to go into that, the future, I've got two quick things to say about it. So last 2 weeks, AI has had two amazing things come out about it, or AI, it's whatever. The news about AI, you know what I mean. Claude 4.6, which is the coding agent, I believe it was 16 agents that had even like some management agents and like different agents. I believe it was in a matter of 2 weeks or maybe a little bit longer, completely by themselves, using Rust, created a Turing complete C compiler from scratch, just with the prompt, I want a Turing complete C compiler. And I believe that the electricity cost was somewhere around $60,000 or $70,000, and it took about two-ish weeks. If you think about what kind of low-level engineer you would need, or how many you would need, 16 of them in this case, and how much they make per year, they would take a lot longer than 2 weeks. So the savings are amazing, and that is just one of those really cool things. There was another thing that came out that they tried many, many, many different models over a long period of time, including the newest models. And they tried to get AI to, without just a prompt, do what a contractor would do. This would be contract work for many, many different types of industry. Just like stuff you would normally have a 1099 person come in just to do something. Could they do it? And it was something I believe is greater than 96% failure rate. And the failure rates weren't like, oh, it just missed it by a little bit. It was a large miss. And so we had both of these things happen at the same time in the news this week. So how do I feel about the future? I feel that this right here shows us that, at least in my optimistic mind, that we are looking at tool sets that are going to help productivity and maybe unblock certain things to certain people, but I don't see replacement. I don't even see really downsizing. I mean, you're going to have a lot of C-level people that sell all of their shares in Unity and normal people who don't understand it. But I think that they're just going to make bad management decisions. And the good thing about bad management decisions in public companies is that those people get turned over pretty fast. There's a guy at Hewlett-Packard who killed their entire tablet industry in one day because he was a cloud guy. This is like from the late 2000s. And he was not CEO of HP for very long. So that's my outlook, is that these two facts are true at the same time, and it's going to be more about productivity.
I want to go on the neural game engines, Julian. So I'm going to first have a safe prediction, which is that the bitter lesson is one that we tend to learn over and over. So if we go on a long enough horizon, will these models be able to do something interesting? I don't know that I want to bet against that, right? But I cannot predict the date. So typically for bitter lesson, you're thinking about the lifetime, like someone's academic career, right? So decades of time. Do you bet against generalized models solving a problem? And the answer is you probably shouldn't. Over that kind of time horizon, they tend to win. So will we get to a point where we have a generalized model that can holodeck up, a game? Maybe. I don't want to say that will never happen. What I will say is that for the at least even medium term. So if you're building a product today or a game today, I don't think that we can build. I don't think that it's going to disrupt games today. And the reason are a couple of things. I think there's a challenge for even if we train on models. So if we took this tech and we trained it on everything up to the mid 2000s, would it be able to generate Minecraft if it had never seen Minecraft? Right? Like, could you create a new game genre out of this? So that's one. I think there's a challenge there. I'm not saying that we can't, we can do novel stuff. I'm not saying it's never impossible, but I think that'll be one of the really challenging bits. Even if we get everything else right, even if it's able to generate other types of games. And there's also the pragmatic, we were talking about this as well too, is that this technology can be very, very expensive to run in real time. So, we already have challenges doing game streaming, like game pixel streaming. So if you want to run like a game in the cloud and it is streamed down, whether that's through products like Amazon Luna or the earlier attempt by Google Stadia, that's actually still very expensive. Like we're barely able to kind of figure that all out as an industry. It still hasn't really become mainstream. And that's without, you'd have to do all of that and run these models within the same unit economics. So it's a very challenging problem to take this technology and make it practical for the game industry. But I do think there's going to be interesting things we learn from it. Right, I think there'll be interesting ways that we can use video and video models and world models in maybe subsets of generating, or as a reference for a generated world, a generated physical state, and how what might happen if the players do X or Y. I think it's a very technical problem yet, and I'm very curious. I think that'll be one of the first areas we start to see applications.
So, kind of on that, and I guess I do have a prediction about the future, and it almost came off. And maybe I hope I'm not wrong this time. We'll see. You say like if you trained a model up to like the mid 2000s, whatever, could it create Minecraft, right? And I saw you shake your head. I think it absolutely could, because we know about Minecraft. And we can prompt it to do the things that would make Minecraft, right? And that's what I'm saying. It's just like well, we're not coming up with very interesting, compelling AI and game ideas yet, because the idea doesn't exist yet. And once it becomes common knowledge to all of us, it'll be very easy to get AI to do that, right? And so it just sort of supports the idea that AI as an augmentation to a human being is sort of this path forward, right?
Prompt it with create Infiniminer.
What's that?
Create Infiniminer.
Yeah, that's what I'm saying. Is finding a way to utilize these tools in a way that you provide the creative spark that it doesn't have, because AI doesn't make things, right? It just combines things. Is a very efficient way to increase your workflow. And I use that to say, like, AI isn't generally taking people's jobs, but people using AI absolutely are taking people's jobs because they're more efficient, right? They bring one piece of it and they let AI do the solved parts already. I used to joke around a couple years ago, why am I still designing AI every time I make it, or UI every time I make a demo? Why am I making a UI why isn't this solved? We know what UI elements are. Why am I making a new one every time? And now with AI, just go make a UI for this. It goes, cool, I know what type of game you're making. Here's a UI. And I'm like, sweet, right? It is solved now. And it's great because I hate making UI. So I don't really know where I was going with that, but basically, I believe the idea is just like the AI tools are able to be this workforce, right? It doesn't necessarily replace. Just like game engines, right? They extract away all the low-level operating system code, so you don't have to know how to tell Windows to render a thing or tell the GPU to render a thing. You don't have to know how to do the very solved physics. You just tell the game engine to do it. Now the AI will extract away the low-level engine stuff, where you can just be like, AI, tell the engine to do these things. I don't need to know how to do them. And it makes things pretty interesting and actually sped up my workflows pretty considerably just in the demos and things that I make. So I think it's pretty cool. Now, in terms of why the stock dropped because of Genie, just goes to show you how fake the stock market is and how based on absolutely nothing it is. Just a bunch of tech bros just speculating on things who don't get it, because honestly, across the board, everyone who made games, everyone across our community sites, Reddits, everything went, so what? But the industry went, game engines are dead. And it's like, what? This thing that's 720p runs at 20 frames a second, game engines are dead right now? Okay, I guess, right? It's even talking about like the using prompts to generate entire games. I often will field phone calls or interviews from like investment firms, and they always want to ask me the same question. They beat around the bush. They ask a whole bunch of other things, but I'm just waiting for them to get to the one. Get to the question. The one question you want to ask me. And the question is always, well, you could do text to image and text to video. Why not text to video game? And my response to them is always like, through programming, all things are possible, right? Sure. Why not? But the fact that you're asking me that question just proves how boring of a question that actually is, right? Because you thought of it, right? And notoriously, investment folks don't get the tech, they just get the buzzwords, right? You could make it. Is there a market for it? I don't know. Making the games anymore isn't even the hardest part. It's marketing them and all that stuff anyway. So, yeah, like, and the communities are showing us how much they don't want AI slop and stuff like that. So, all of this to say, I know there's a lot of concern. There's a lot of stuff like this Genie stuff and everything, a lot of confusion and a lot of fires being fueled by blog posts and stuff like that. But I think we're going to be okay. I think that's my prediction, is we're going to use this like any other tool, and we're going to normalize it, and we're going to find some really awesome things to do with it, and we're going to be okay. I guess.
Me too.
But I'm a terrible guesser, so take that for what it is.
I'll let go of Mrs. Diamond. You let go of the tech bros.
Yeah, I mean, I very much agree with the high-level sentiment here, and we're all going to be okay. Interesting. Sorry, I was just lost in my kind of more detailed thing about the neural game mentions. So I just want to return to that. Sorry, but I mean, but it actually starts from this thing. Hey, prompt to game. Yes, I also thought that was a super interesting idea 10 years ago, and I did work on, like, how can we generate a new game from nothing at all? Like, that was like, like 20 years ago. I was like, this is a very cool question to explore. It is an interesting question, but exploring it just teaches you that how hard it is to get it right. And I did a bunch of work like long time ago with, like, can you sort of formalize a game design space, write up a simple kind of like game generation script, try to have algorithms, try to create it so it's a correct game? Yes, it is. Yes, you can. But it's going to be terrible, not even playable. Okay, so are you then can you play test it? Yes, but the problem with play testing it is that you don't have a way of playing the particular game you're creating, because you haven't created it yet. It's very much like catch-22 here. Can't you come up with some generic game playing method? Yes or no. If you have the right hooks into the engine and the right affordances and the right way to simulate it, and basically use planning, you can to some extent, but it's going to be in a very generic way. And we often got stuck in like generating a bunch of games that were like, technically they had a skill, technically they were playable. Technically they had a kind of skill curve. Technically they had a bunch of these things. They were just like completely uninteresting to humans and completely unintelligible sometimes. Now with LLMs in the loop, then you can kind of get away from the unintelligibility, because they can produce things that look like games you've seen before. But that does not mean they're fun. And it turns out that so much of creating games is like this there's a myriad of little design decisions and this continual testing, and always just like, test this and test back, and you were wrong and you have to backstep. And, if you've been in a game development process, you know how very far from a straight line it is, and how what comes out typically is not very close to what you imagined originally.
or it doesn't play like it was imagined. So something like a neural game engine, where you try to sort of, hey, a prompt in, and you get this like fantastic thing that is playable to some extent and looks great, but it really doesn't give you the level of control you need. And it also and it also doesn't give you the iterative thing you need, because you can't just go in and sort of change the prompt and have these very localized changes. But you know what does that? A game engine, an actual game engine. Okay, I disclaimer, I do own stock in Unity. But so that's what. But neural game engines are very cool for prototyping. I think they're going to be really cool for that. Like like you can just basically, hey, here's a crazy idea, and and then you can play a bit with it, and then get new ideas. Yeah.
Super quick. So the prototyping thing real quick. My art director, he was in games, and then he's been in Disney forever, like Pixar, Disney. And then he came back to games, and he had a real opinion about generated AI art, and which was valid, and everyone should have their own opinion about it. I think his is probably correct. But he changed his mind a little bit, because I generated a few things to show him what I wanted him to think about when I was designing, because I'm always like, well, make it like, you ever seen Alien, and it looks like the inside of a truck stop? Yeah, like that. Like, make it like that. And that's terrible direction.
But we all have a different vivid picture.
Right.
That's the problem.
And so he changed his mind, because I generated some things. He's like, I actually like this, because now I can see what you want, and I can say no to it. And then do his own thing. And then the vibe coding on the other way for designers that can't code, where they want to put a prototype together and they prototype it. I mean, you can never ship that code, but they can show it to an engineer and be like this. And now we get like, okay, your GDD did not describe this, and now I can do it. So I like it for the prototyping aspect.
I want to keep going on some of what Julian's been going here, and to preface, so we don't miss it completely, on the sense of like, what is the future of AI and games in general? My sense is that the impact is going to hit the industry first before it hits players. Right? It'll change how we make games before it changes how we play them. I wish that were actually opposite, to be honest. But I think as the industry, we need to learn how to use them. My studio and Tim's, like a lot of us are very focused on, well, how does it change the relationship with players? How does it change the kind of games we can make? But I think we're going to see it change and impact to the industry first. I say that because I'm going to probably ignore that part. That's the part that like is happening right now. It's very, very interesting. But I'm focused on the future for players and how we as developers create that future for players by introducing the technology, which is, to Julian, your point of like, so what do these neural game engines really do? And so the question I have for the rest of us here is a halfway step. So if we look at the, let's take Left 4 Dead's AI director, right? And let's imagine that we give it generative AI superpowers, whatever that means to you, right? So because one of the ideas that we've explored is that anytime in the game industry, when we can speed up the feedback loop between a designer and a player, that changes the industry. So when that feedback loop was slow because we had to press a disk and ship it out to stores, and then finally we find out what players think, and then finally we are able to ship another like game or another DLC, that feedback loop is very slow. And then we move to things like live service games and faster. So the question is, can we put a proxy for the game designer in the game? The same way the Left 4 Dead AI director is in some ways a proxy for the game designer to decide zombies should spawn right now. So can we become a better proxy? Can we build a better proxy for the game designer? And that's not building a whole game. It's not building a whole game, right, but it's building something. It's changing the something. Do you think that's even possible? Do you think that that's an interesting space? As a halfway point between, here's a prompt to game, but here's a game that's running and we're going to improve or change it in real time. Does generative AI have a place in that spot?
Tools like that exist, like Game Tune, right?
So tools like that exist. GameTune is a thing that basically watches a significant amount of player behaviors, notices like, okay, everyone drops and it doesn't come back after level 4. Why? Let's start making tweaks to level 4. Oh, that had a positive impact. It can do this, like sort of A/B. Now, and those are things that existed before generative AI. So my point is just that, yeah, they were kind of successful before generative AI. So with it, absolutely. I think.
What about in real time?
You mean without learning first? Or just in-game. Like saying, okay, this player seems to be losing interest. Let's amp it up or down. Right. Sure, through programming, all things are possible. Why not, right? Like I think it's an interesting model. Kind of like some of the other reinforcement learning problems. I think the challenge is getting it to not draw false conclusions about what it's seeing in the player. But absolutely. But like even if you were to do something like this player normally has 95% accuracy when shooting zombies rate, and that's dropped by about 10%. They're getting tired, right? So let me just ease back, or let me crank up the shooting assist or whatever to keep them in that zone, to keep them feeling like they're killing it, even though they're physically fatiguing. Sure, right? Like, yeah, if a person's like, man, I thought I was getting tired, but then I'm just killing it, right? And they don't even see it, then absolutely, right? It's all smoke and mirrors anyway. So I think that it's a very compelling use case, honestly.
All the speedrunners are going to be staying up 48 hours and then starting to play the game.
And that's the problem. You've just identified the issue with something like that. Yeah, exactly. Okay. Touche. That's a good point. That's a good point. Really, the dominant strategy is obviously to turn it on, go away for a little while, come back. Everyone played Dead or Alive 3. There was a fighting game from like early 2000s, right? And then they had Dead or Alive Beach Volleyball, which is a whole different thing. But Dead or Alive 3. And what was interesting about that game is it had a form of like, it learned how you fought during the first stages until you got to the end boss, this alpha, whatever, that could take on the attacks of anything. And the key to beating that boss was playing all the way up to the last boss, and then handing the controller to your friend. Because the system learned you had a hard time beating that end boss, but your friend would just low kick, now it's dead, right? Because it's like, what is happening, right? It trained this entire time to fight you, and it's not fighting you. So there are certainly interesting and dominant strategies for it, but in a nutshell, yes, a very compelling case for certain.
Yeah, adding on, I didn't know about that Dead or Alive 3 example, but that's brilliant. And of course, the same thing would go for a reinforcement learning player, obviously. So yeah. No, I think like Dead or Alive is such a great case. It is a great game, but there's 4 types of zombies or something. I would expect in the future to play Dead or Alive, whoever resurrects that franchise. Left 4 Dead, yeah. Left 4 Dead or Alive, whatever.
One of those things.
Left 4 Dead, yes. Yeah.
Oh, that sounded like an LLM answer.
Yeah.
Oh, well,
that's a great observation. Okay, let's rewind. Left 4 Dead is brilliant, but why don't I get zombies that answer to my specific fears? And like that I haven't seen before, that nobody haven't seen before, and that the game has a reasonable reason to think that I would have a hard time, but not too hard to play against, and that would sort of click with me in some interesting way, and just generate the whole thing, everything, behavior pattern, exterior, whatever, on the fly. The same thing for the environments and stuff like this. We've built a bunch of series of prototypes throughout the years in like very simple game environments, simple dungeon games, Super Mario Bros, whatever we can, look, as an academic, whatever you can get by on with like simple, that doesn't require to make real assets or real programming effort or whatever. And yeah, we have a bunch of methods for that. No one has really tried anything like it. And I have for a long time, my working hypothesis has been that this has been technically possible for a long time, but game designers are worried about doing this because it means losing too much control.
Yes. I in fact, actually, I find that when I work with game designers and in general, one of the challenges, it's not like we haven't had machine learning, right? You know, like we've had neural networks and things like that. Why is this a tool that we've not used in the game industry as much? And there are a lot of reasons, but one of them is about tuning and control. When you tell a game designer that, you know, you're introducing some machine learning model, whether it's a large language model, a transformer, or something else, and the designer's like, I want it to do this. And you're like, well, it's going to do that about 80% of the time. They're like, no. You don't understand. Like when you look at, you know, those of us in the game industry, sometimes I love my game designers. Some of the specs can be very, very specific. You know, like you look at like sports games or something. It's like, okay, when a person's in this spot, and then someone else is guarding over here, and then this is happening, then the AI should make this choice, unless, right, this isn't true, you know, and they had this thing that happened 3 seasons ago, you know, and that will be part of the spec for that AI character in a sports game. So when you have that level of specificity that you're used to being able to tune that experience, letting go is very, very challenging. The principle that we give our game designers and folks that we work with is to think of 3 nexus of control. Typically, we would have the control between the player and the designer, right? You decide, when does a player get freedom of choice at this moment? When does the designer get the freedom of choice? So when is there a cinematic, or when is it like we're going to railroad them to a choice another? The question is, if you add in a third entity, which is the AI, that gets to make an intermediate choice between those two, how do you introduce that as a systemic idea in your game design? Right? So where is the control at this moment in the game? The player, the AI, or the designer? And when you ask that explicitly in different moments of the game, I think it helps you come up with, clarify what the AI is doing and what do you want it to do in this moment. And treat it more like an explicit partner the way the designer is.
So in Death by AI and then a lot in the last show, we, at the end of every round, I actually run a small analysis of every player based on what they just input into the system and how they appeared to respond to it. Now, my games are simple. These are party games where it's very much call and response. But you may have noticed I think I'm funny. And so I try to put that into my games. And so and my games are slightly mean-spirited because whatever, that's fun. So, but not harmful. Where I'm going with this is that analysis becomes part of the context window of the next choice that the AI is going to make when it comes to generating a question, or if it's going to make a comment. I have a lot of just commentary, whereas the game, usually I'm doing something else in the background that's going to take a minute. And so because that's happening, I will throw the AI will say something to kind of fill the time. Fits because it's like a game show, so it sounds like, you know, a commercial break kind of deal. But if based on what you've been saying to the AI, it adapts that. So it adds that to the context window. So I have the type of thing I want it to say, and it'll flavor it. So it's not as in-depth as what you're talking about, but I am in real time reacting. And what we call that, or what I call it, I guess, is we have the ability to do infinite personalization without changing what's supposed to be. So I know everyone, not everyone, a lot of people are really excited about talking to NPCs forever. And a lot of people are really, most people just want to mess with the NPC, especially if it's like a Star Trek game. They just want to walk up to C.Lui and be like, so what do you think about the Mets? You know, so a lot of people just want to break it and see what happens with it. But if it learns that you just want to keep breaking it, then C.Lui could respond kind of in universe and be like, I've got no time for sports, Captain. And that's what we're kind of doing with our personalization. oh my.
I'll just add on the NPC thing. The other part that I'll give, I've said this before, but advice on this for game developers in this space is, the way I like to phrase it is I think we need less chatbots and more holodecks. So when and this has been brought up actually over the last, throughout this conference, is that, you know, when you just add a large language model, when you just add a chatbot essentially to a game, you open up certain opportunities, but you create a lot of other problems, right? And we've talked sometimes in the case of, you know, the framing problem, you know, what knowledge do they know, right? And we had some examples of how you can put in guardrails. But that's only one of the problems. So the example I like to give is that if you add the, you know, now you have the LLM-backed blacksmith in Skyrim or something, and you walk up to them and you're like, start a conversation. It's very reasonable that the large language model could generate something like, I'm kind of out of coal and I could use more. So the question for the player is that now a quest? Right? And if the player responds to that dynamic dialogue from the blacksmith who says, I need some more coal, if the player goes out and gathers coal and brings it back to the blacksmith, do they complete a quest? Do they get XP? How much XP? What gold do they get? Or how does that affect your game economy that you've tuned so carefully? And so we need to think about these games holistically, right? So think of it less like a smart character, but a smart game. And you think about the entire game system, it's almost viral, what happens when you start to introduce machine learning into your video game. You can't just add it on, right? It needs to be something that you thought about from the beginning of how it's going to affect balance and design, because the designers are going to have to work with this. And so that's one of my other bits of advice in my experience working with it. You have to consider it a first principle. If you're going to introduce this technology into your game, you need to understand how it works from a game systems perspective.
Another thing too, and I'll start off by just saying that I don't want games like Left 4 Dead to generate zombies based on like how I play, because I really don't want to encourage AI to think of efficient ways to kill us. Like, I just find that that's not maybe a good thing to do. But beyond that though, like it does bring up a very interesting technical problem. Like, has anyone ever seen any of the simulations of a computer learning how to make a human walk? And we don't walk efficiently, right? The things the computers determine through simulation, the most efficient way for a human to walk, is terrifying to look at. But if we did it, it would be the most efficient way for us to walk. We just don't, because biologically, we're a mess, just like everything else on the planet, right? And so you almost have to train an AI on biological limitations, evolution, like all these things, in order to get it to make zombies that are compelling and interesting without being the most efficient blob mass that just flies at you and skewers you, because that's what it was told to do, right? Like the Sentinels from Matrix, the most efficient killing machines, right? Based on what machines have figured out. Like, if we need to tell it what constraints it has, and I think that's a problem that's much better solved by procedural generation as opposed to AI, right? Because with procedural generation, we just create those constraints. Like No Man's Sky, I've been playing a lot of that lately, and yeah, it generates all these different creatures and all these different planets, but there's still like repeating patterns because there's some biological constraints of the creatures in the game, right? So it's an interesting problem, but I don't know that that's necessarily the best problem for AI to solve, as opposed to what you were saying about smart games in general, where this is a piece within the entirety of the puzzle, as opposed to this one piece being replaced. Did that part need to happen? But that's just kind of my take on it. I've not seen it done well. Maybe I'm completely wrong, right? Usually, again, completely wrong. Maybe smart NPCs would be amazing. I always just think, like, I don't want to talk to an NPC about anything. I can do that in real life. I can get in a cab and talk to the driver about anything. I don't. I'm not going to do it in a game either, but I'm a different type of player maybe. So I'll be interesting to see how it goes, but I think, yeah, the real kind of piece is this holistic view. But if no one else has anything else, I did have a question for you guys. So, and actually I'm just going to put you on the spot, because you were talking outside about how AI service providers are not necessarily geared to serve games very well. And I just wanted to kind of give you an opportunity, because I thought it was really interesting when you said it to me, and I was like, I didn't even think about that. I'd love to give you an opportunity to talk about that.
I just want to say after this, maybe we should have questions from the audience. Yeah.
Okay, yeah, good point.
Yeah, I will say that if you're looking at building games with this technology, I mean, there are great partners. We worked with AWS quite a bit, actually, for Jam&T. We've worked with other partners that have been mentioned, like InWorld, Google, Microsoft. That they actually have a lot of things. But if you're pushing the boundary, you may find that the cost and latency problems may push you to having developed some of your own technology. Like the things that work right now for coding agents and a bunch of other agentic technology right now is amazing for the enterprise. It works really great for the enterprise. There's a lot of return on investment that's possible there. That does not mean that same technology is going to work efficiently in a game engine or in a game state. And so to actually answer your question on that and go back to your other point, one of the reasons why you may have to develop some of your own technology is because we are building murder bots. We may need a AI character who is willing to generate dialogue, generate planning or decisions that may break guardrails on other enterprise or other models for very good reasons, right? And so that is actually, I think, one of the questions when I bring it up with some of the AI providers, we get a good laugh out of it, but it's also true. They have very good reasons why they should not train their models to kill humans, and yet in a video game, I might actually need AI NPCs to do evil things. And so how do I do that in a way that's responsible, right? And so.
I'm trying to build champions, and you're making.
Yeah, so I think there are a bunch of interesting problems that are unique to the game industry. In fact, sometimes we'll also find, you'll find sometimes a little more overlap in our problem space as you with robotics or autonomous vehicles due to the real-time nature. So I would also recommend people look into those areas of research as well.
Do you want to open up to questions?
Yeah, questions.
I got a great one on that very thing. So it's great this morning about Phil Spencer and Sarah.
Do you want to take a mic?
Sure.
It's kind of like in order for there to be good, there has to be evil. So you're training evil.
So the question is, I just read a great blog from a friend of mine saying the reason that Sarabond and Phil Spencer were removed, not that they had been doing a bad job, and the reason that the head of AI was moved in was because Microsoft was going to start using all the gameplay data to train robots. Would love to get you guys to respond on that, because your Killbot thing is just couldn't let it go.
This will end well. I mean, how could it not? Like, Microsoft's got a sterling track record, so why not? I don't know. I had not heard about that. The first thing I did when I saw like Copilot and all this other stuff appearing in my windows was like, absolutely not, and went into registry and turned all that stuff off. There's probably a secret registry key that's still on and it's still listening to me, but yeah, I mean, I think the biggest challenge for people, for players, for consumers of the future is how do you not get taken advantage of by AI and big companies? That's the real challenge. Otherwise, you just have Microsoft harvesting all your data and anyone else who wants to do it as well. And that's not great.
My initial, I've never heard of this either, but my initial reaction is that training on players' data and what players do is unlikely to be useful, because that's not what the problems are in robotics. Like, we're not like, how do you take cover and shoot at these guys, and especially how do you do it bad? No, but the real problems in robotics is like, how do you open a door handle? So yeah, by kicking it in, exactly. So it's. I could imagine that they want to use lots of, or I'm fairly certain that they want to use lots of gameplay videos with associated actions to train world models, aka neural game engines, and then use those in robotic simulation, which is fine, and I dare say innocuous. I do not own any Microsoft stock, but I'm fine with that. The other part, like how do you actually, what you just said, Mike, doing all this and not just becoming like a data provider for like large companies that know and all your data can be held against you and whatever. Yes, that's a big thing. I am hoping for a future where we can do a lot more locally, and I want, say, like Apple, Nintendo, Sony, and so on to win this, to basically make sure to enable people to really use strong local models for all this and do everything on device. Nice thing about the game industry is that the economics of the game industry is kind of pushing for it. Yeah. Because, the people don't want to pay token costs for the games. What we need, hardware manufacturers who are listening, do is please add more video RAM. That's what we need.
I want to add one thing real quick here, and then please, sorry, I'll I'm hogging the mic. But one of the things this quick Unity plug here, because I work there. We have this thing, the developer data framework is a thing that we've implemented recently because we want people to have absolute control over their data and what it can be used for, with the hope that once you have full control over your data as a developer, that you're cool sharing it with us. But we want that to be an explicit decision that you make, understanding the impacts of that, understanding that then you are responsible for any data you collect from your players, make sure you're adhering to laws and stuff like that. But the idea is that we don't want to steal data, right? And our hope is that we can get other companies to do the same. This should not be a sneaky, I've installed a thing on your system without you knowing it, now I'm harvesting your data. This should be an open conversation of your data is valuable to us and it's valuable to you. I hope I'm giving you something for your data that makes you want to share it to me, to give me that data. And then it becomes a much more open and honest conversation. And I hope that's the route we can help people go. So that we can do things like training on real valuable data without just ingesting a bunch of garbage as well.
I don't have much to add other than that's terrible training data for robots. Harry Potter Wizards Unite, we modeled the Pegasus or the unicorn as one of the. And producer on my team, she owns many horses and she does dressage. And the artist came over and said, doesn't this unicorn look great? It was like on its back legs and running around. And she's like, you've never seen a horse before. I thought it looked great. She's like, it's a dog, not a horse. I was like, oh, all right.
I will add there is, and I think Julian, you had mentioned this yesterday. There is a long history, though, of the game industry and AI as a general technology or computer science field overlap there, and that the two are areas where we share a lot of explorations and discoveries. So I do think that the game industry is a place where we can push the boundaries. That there are interesting things we can learn in the game industry that are applicable broader, whether it's robotics or anywhere else. We can solve a lot of interesting problems in games in ways that we can push the boundaries. I'm not going to drive somebody's car off the road. I'm not going to give them the wrong blood type inside of my video game. There's a lot of things that I can push the boundaries on what I will allow a machine learning model to do, and also do it in a human-machine interface. So like how do humans interact with this? How do people interact with this? I can learn that in a way in a video game that's actually a lot safer than in a lot of the other ways that we're trying to push this technology. So I actually would encourage people to be rather ambitious in what we can do in the game industry, because we really can. Do we have other questions?
All right, real quick. It's good hearing everyone's comments on AI and how it's impacting the industry, but would love to hear examples, maybe tangible examples of how has AI, whether it's a chatbot, an agent, Claude Code, OpenClaw, tangibly impact to make your game better as of today. If you guys have specific examples, I know you talked about the one with the using the image generator, but if you guys have that for making the game better or even optimizing your workflow, maybe that would be good to hear.
Did you clarify? It's for the development of the game.
Yes.
Yeah. Let you go next, or anyone could go after me. So vibe coding the tools. So in games, the games are interesting because the data that's required for games is going to be very specific to that game. Like you can make Unity, which is an engine that can do any game, but like the data that drives it is going to be specific to what you need. And so tools engineers have been around for a very long time. They're invaluable. But like vibe coding, like abilities to like very quickly build an interface to edit super complicated JSON or very super complicated data sets, that has been invaluable. That sped me up like crazy. I didn't even know, over 4th of July last year, I was like, what's this lovable? And I had 5 credits, free credits. And I was like, because I was like, oh man, I have to write this editor. I don't want to, because I was hand editing JSON, which everyone knows is flawless. And so I was like, let me just try Lovable. And then within half an hour, I had a really good only for me, I could never like sell this to anyone, but only for me, like start to an editor. So that really helped like crank out, because like our rounds all of my games are data driven. So everything that's in the game comes from some piece of data that drives decisions or whatever, right? So I was able to crank out a lot of content with that tool that would have taken me probably a week or two to build the interface, because I also suck at UI.
Fair. So it's been a long time since I've made commercial games, but I make a ton of technical demos and projects like that. So for the purposes of this conversation, we'll say that counts. And honestly, I haven't found that the AI has helped me solve particularly difficult, nuanced problems, but it has allowed me to focus on those problems by doing all the other garbage, right? So it's like I'll create a character controller, or I'll create some mechanic, and I'll be able to say, you know what? Generate 16 variations of this thing for me to test. And then, boom, there's 16 versions and different scenes, and I go through each one. I go, oh, I really like this one. All right, okay, this one's cool. We're going to make this the primary one. I need some enemies. Give me some enemies, all these different attributes. And it generates a whole bunch of random enemies of different attributes. I'm like, cool, now I can test this, right? So there's that. And there's also just sort of like and this is we hear people say this all the time, almost like a colleague for creative prototyping, where you're like, all right, make this gun sound. I don't like this gun sound. Make it sound a little more realistic. And it's like, well, here's the sound of a sniper rifle. You like that? I'm like, yeah. And it's like, you want me to make the rest of the thing a sniper rifle? I'm like, yeah. And now I got a sniper rifle. I'm like, oh, I hadn't even considered using a sniper rifle. This is a lot of fun, right? And so that's an example I'll show you here in like an hour. And so it is a great like sort of companion to game dev. But again, when there's nuanced problems and stuff, that's still where, I step forward and I handle those things. But in terms of even just creating some of the tools, like there's so many times you have an empty level and it's not even important to the demo, but I want stuff in here. And so I'm like, make a script that's going to scatter items in an intelligent way, procedurally or whatever, and it creates all the code for me, and I just hit a button and boop, there's just stuff scattered. And I'm like, cool, now I got a level. I didn't have to do anything. That's sweet, right?
I have two more. Sorry, real quick. I'll give it to you. I can't believe I forgot this. Unit tests. Like the fact that the thing writes unit tests for you, and I mean, granted, you have to look, because it'll just be like, and it passed. You're like, return true, you jerk. So you have to stay on it. But unit tests are a great one, and documentation is another one. Like being able to like auto document your code, those are invaluable.
Yeah, no, it's great. No, these are, yeah. Again, preface, I'm not a game developer. I run a research lab. And we do a lot of like, some of what we do, my PhD students and others are like of medium to very high programming capability. And I've seen things like in the type of medium research capability, medium programming level of like, I didn't know how to do this, I vibe coded it, here's this whole little, because much of what we do are like game prototypes with like AI tucked into it in one way or another. And I vibe coded it and it's okay. And I tried improving it and then we got into the problem because I couldn't, communication between me and Claude broke down basically. And then they're like, okay, eventually throw out all the own code and rewrite it from scratch. And you all know that the code is better second time you write it. In fact, this is true even if Claude wrote it the first time. Which is kind of interesting. The other thing is that, and often like when it's more machine learning focused stuff and with the stronger coders, then it's something like, it let me do the shit so I can focus on the real hard technical problem. Sometimes I prototype things myself. I have an idea, prototype things, and it's kind of annoying because I find that it's very hard for me to get it to do exactly what I wanted to do, maybe because I have weird ideas. But then I kind of like, I was doing a platformer a couple of weeks ago over the weekend, and it was just like, this is not going where I wanted it to go. And then I started just giving it bizarre prompts like, hey, make it post-structuralist. And I want a commentator track by an idiot and stuff like this. And then it gets really interesting. I mean, it's not useful, but it's fun.
To your question. When we were developing Retail Mage in 2024, we did not use a lot of AI tools to develop it at the time. In 2025, we started using AI, primarily Claude Code, but a few other tools for prototyping quite regularly. My co-founder, Carl, is, I would say, to the degree there is a proficient vibe coder, thing, he is one. I tend to not like the term vibe coding that much as well, because I think there is a form of programming these days in concert with with particularly some of the very latest models. I think we saw a phase change in November, December with some of the new models, and then again recently. And if you have not used the latest models out of Claude or Codex, then you're probably outdated in what they're capable of doing. At any given moment right now, I am probably running 3 or 4 different agent sessions. I will run as many as 5 to 20 at any given time on different projects that I'm moving between. We've actually developed in concert with a couple other friends a way that we can now actually share those sessions, essentially pair program in the team and hand off between different Claude or Codex or similar agentic sessions on a remote development box using a web dashboard. We've moved we do prototyping often in JavaScript, but increasingly we're doing it in Godot. We think we have enough of a workflow that we can do prototyping in Godot pretty well, and for like early rapid prototyping of game concepts. I do almost all my SRE DevOps works with agentic code assistance as well too, mostly using Pulumi instead of Terraform, but similar kind of concepts. So we absolutely use these day to day, and our art director currently has. He's trained Lores at this point on his art style to be able to rapidly iterate concept art.
It's a good point about vibe coding. It's almost kind of setting, like when you used to call people script kiddies, right? Like, I'm not a vibe coder. It takes skill to understand what you're doing. So anyway, that's my own personal problem. But I just want to let you all know that if you want to significantly improve your quality of life, whenever you have AI generate code for you, tell it to write the comments as if it was Werner Herzog. I assure you, your life will get better across the board. I actually have an AI that rewrites all of Unity's marketing stuff as Werner Herzog just to test it out. And I've actually gotten some pretty good ideas that way. So I'm just throwing it out there. It's worth it. Yes. Oh, yes. This out of the darkness comes an instantiated object. Its life unknown. Its purpose dubious. It's in harsh contrast to the lushness of life.
That's scary. All right. Thanks again to our panel. Great discussion. Wonderful stuff. We're now moving into the workshop phase. The information on the website is correct for the workshop schedule. Timothy Johnson will be in here with Discord activities and Playroom Tech Stack, which we will be live streaming, and that'll be our last live stream of the day. In Classroom 1, you've heard the discussions on Flux and Laura. Anatoly has been using Flux plus Laura to generate characters using his IP that can continue to support his IP in his games. You want to learn how to do that and significantly increase the amount of art you own in your games. Check that out in Classroom 1. Classroom 2, limited capacity. That is AWS running spec-driven development in action, building with Kira. Again, the workshops are down and to the right. Go past the first classroom sign, go to the second set of classroom signs, and it'll be down that hall. So head on out, and Timothy, you want to come up here? We'll set you up. Do it. Grab it.
Hey guys, if you haven't gotten enough of me, hello. So what we're going to do, I'm going to kind of just freestyle it with you guys here, and walk you through, because like actually in my head I was like, all right, I've got a course, we're all going to have Unity, we're going to build the game, we're going to put the game up on there, it's going to be in Discord, and we're going to be done. And I was like, it's 1 hour. And we're all at different skill levels. So I'm going to get us all set up. We're all going to get going. And some of us might get there, some of us might not, but we're all just going to talk about, I'm going to show you, we're probably just going to play a game as well, a Discord activity game, so you guys can all see it. I've got plenty of stuff, videos, tutorials, that you guys can follow along with at home, lots and lots. So the website, it's hard to see, but it is joinplayroom.com, all one word. This is my company, so I'm Little Umbrella. Playroom. So as I said, you're going to hear Playroom and Little Umbrella be kind of interchanged. So we started, like, the origin of the company is that we wanted to make game dev tools, multiplayer tools, and so we created Playroom. And so then we ate our own dog food and we started, created a game, and so that was way more popular, better than the tool. So. But the tool still powers it, and you can use it too. You don't have to use this tool. I'm just going to show it to you now. It's a really easy way to get a Discord activity started. So yeah, if you want to go to joinplayroom.com, go ahead and create an account. And what I'm going to do is I'm going to take a look at everyone who's signed up for an account today. I'm just going to give you guys an enterprise account. Normally it's like $125 a month. You can just have it free for, let's say a year. You're welcome. All right, so. Get started for free. You should be able to create an account. Oh yeah, see, that's what I'm talking about. I only have an hour. The Wi-Fi. I am actually on my phone's hotspot. So.
And we have it. If you had the know before you go, which is at the bottom of that email, you've got to do this whole Kennesaw setup. Okay. At the very end of the know before you go.
Okay. So this is the first site here, but also I'm gonna put that down. Hopefully that's not making too much noise. Okay, so join Playroom. The other thing that you want to go to is you'll want to go to discord.com/developers. And if you, all right, so let me back up. Does everyone here have a Discord account? If you don't, then just follow along. But the point of this lab together is to talk about Discord activities. Creating your own Discord activity. You can create it with Unity. You can create it with anything that can create a WebGL build, including just a literally HTML website, can be an activity. So what I'm going to do is walk us through, show you what that's like, and then like one of those cooking shows, we'll just jump to a finished one and we'll play it. So when you have to sign up to be a Discord developer. It is free to become a Discord developer. So you'll want to go to discord.com/developers and follow the sign up process. And what we'll do is I'll make this bigger for me. Okay. When you are in, this is the Playroom dashboard. So what you can do in Playroom is you can create games. And Playroom does kind kind of two separate things for you. One is a place, or three separate things for you. It's an API that gives you the ability to have our networking stack, the Playroom network stack. It gives you the ability to have our authentication, which can be authenticating just through yourself or through Google or through Discord. It allows you to set up a Discord activity very quickly, but you don't have to do a Discord activity. It actually handles hosting for you as well. So it's kind of like the other sites like itch.io and stuff like that, where you can just kind of create an account and then upload a game. Same thing with our tools here. So the creating a new account, or I'm sorry, once you have an account created, there is, and it's going to say the tier is hobby. That's fine. I'll upgrade you guys after today. But if you click on new project, it'll bring up the tell us about your game. You give it a project name and a description. Let's say call it Transformer 2026, and the description is, yeah, man. And I have several games in here. There we go. It'll give you a game ID. It'll give you a title, description, and you'll notice that it's already live. Hooray! We've done it. You've created a game on the Playroom stack, and this is the link to it. You'll have HTTPS, whatever you just called it, .playroom.gg. If I go there now, not found. So it's live, but there's nothing hosted. It's just an empty site at the moment.
Is the name global? I also typed in Transformer 2026. It says game existed. So this name is global, right? Not just for me.
You're correct. You have to pick a different name. Thank you for pointing that out.
You'd be Transformer 2024 because I'm Transformer 2025.
Now we give you some metrics down at the bottom of your daily active users, monthly active users. That's just kind of wrapped into it. Underneath this we have hosting. Hosting is very simple. You take your files and you literally just drag it here, and then you are done. Whatever you drag here, it is live immediately. It's very much like itch.io. This enables shared array buffer support. If you don't need to click it, don't worry about it. Don't click it. It is for Unity WebGL builds that require the shared array buffer, which sometimes is required, sometimes it's not, but it's Unity specific, that checkbox there. You'll also see that we have a tab here for Discord activities. And so we have easy steps to follow. The first one being to create a Discord application. So here it tells you to go to the Discord developer portal and create an application. And I have lots of applications, but we'll make a new one. So when you are logged into Discord and you've got your once you've signed up as a developer, you'll be able to get into their portal. Their tools are just like maybe a week ahead of our tools, meaning that they're pretty good. They're not great. So you'll see that there are teams, there's embedded debuggers, things like that, and then they have their documentation, which is also very helpful. So in their documentation, I'll just talk about that real quick. What we're going to be doing is they've got three pieces. They've got three kind of categories of documentation. There's going to be like just using Discord, which is like if you didn't know, Discord actually started as a game. So under the hood in their API, they never renamed anything. It's all still very game related. So Discord servers, as everyone calls them in the world, they're actually guilds. And so everything has a guild ID because this used to be their guild system, right? So there's like the section here that talks about like how you communicate with the guild. Like if you're trying to make like a Discord bot where you want it to post to the channel, or if you want to talk about or communicate with the users, if you want to create / commands for your bot within Discord, that's like one section. We're not going to do that today. The next section that they have is brand new. It's about a year old now, and it is for their what do they call it? It is the social SDK. That is for, we're not doing that either. That is for their SDK that gets built into like a Unity build or an Unreal build, where you actually have like Discord functions. The SDK is within your game itself. What we're going to be doing is instead the third one, which is the Discord activity. That's the documentation we're going to go through there. We're not going to go through the documentation, but there it is. All right, so we click New Application. Let's create a new one. I'm going to call this Tim's Super Transformer. And I agree, and I click Create. Yes, I'm a human. And inside here, we have all sorts of cool stuff we can do. We can upload the app icon. We have a description. You can tag it, which is how it gets found in the store. You have your application ID, which is going to be important later. Your public key. It also gives you some metrics as well. How many people, how many servers, once again, server being Discord server, how many of them have installed it, how many users. They've got lots of cool things here. We're going to be using some of these endpoints later. Let's go back to let's go back to the Playroom. Well, that's the wrong one. There we go. So copy, all right, so create our application. In step 2, we copy the OAuth credentials. So copy the client ID and client secret from the OAuth 2 tab in Discord into the field below. So I will go back and do that. Go to the OAuth 2 tab. Wait, what did it want? Client ID and client secret. Oh, my multi-factor. So, never give out your Discord secret to anybody, because then they'll own your bot. They'll own your app. Okay, so once you've set your key and secret, you add the redirect UI under the OAuth 2 tab. You add the following one, which this is my redirect UI. I'll talk more about what that is in a second. And then Discord gives you a nice little thing at the bottom. Careful, you have unsaved changes, so if you have anything. So go ahead and save it.
So add what undirect redirect UI?
Yep, so there's going to be a redirect UI here in your Playroom.
Oh, from the other side.
Yep. Yeah, so what we've done is we've kind of made an easy, you can do this all yourself with your own code, but what happens is that when there's a lot of security.
Take the mic.
Oh, sorry. I'm so loud. There's a lot of security in Discord, and we're going to see that as well. So they're super, super paranoid about, I mean, seriously, we're opening up our own web browser inside Discord. That's a lot of shenanigans can happen there. So what happens is when we get to the part where we actually open the activity, there's several handshakes that has to go across to make sure that there's no like man-in-the-middle attack. We're only going to be able to access resources that we specify. I'm going to show you that here in a second. So like if you need to call an API like, you know, google.com or whatever, right? Whatever your openai.com, we're going to have to like set that up here as well. Otherwise, it all just gets blocked. They have a thing called DCS, which blocks all outgoing traffic. And then when your players fire up the Discord activity, it's going to challenge them with a bunch of permissions as well, saying, hey, this app or this activity wants to access your whatever we specify. So I mean, it's going to be stuff that you've probably seen before, but there's a lot that we have to like set up in order to make this happen. You could do this once again. You don't have to use my platform, but if you do, we've made it much easier to pull this off by just adding a couple of things into an API call. You can do it yourself as well with the Discord embedded SDK, which you can download yourself. So there's like multiple options. I'm not trying to just hawk my stuff here. Okay. So, we'll get to that here in a minute. Okay, so enabling activities and mapping the Playroom backend. This is the two pieces that we need. So we're going to put these into the Discord app. So this first one is the route mapping. Once again, this is to get the Discord DCS to be happy with us because we are telling Discord's players to go to another website. Very scary for them. So there's a route mapping, which is going to be your name.playroom.gg, and then this prefix. This is for the WebSocket that our tech uses. So we connect to Playroom with the WebSocket. So both of these things, let's do the route mapping first. Is the prefix the same as the subdomain? It's the prefix is going to be just slash, right? So we're doing a mapping. We're saying whenever we want to go to here, let me just show you. So I'm going to paste this in here. So whenever we tell the Discord activity go to root, just slash, Discord knows, oh, you really mean you want to go to transformer2026.playroom.gg, right? So this is just an internal mapping for Discord. And where I did this was here in URL mappings. Does this make sense so far? I know I'm kind of dry and it's like Bueller, but if you have questions, just shout them out. This isn't a class. This is a.
I still don't understand the prefix. It's not a subdomain.
The prefix is not a subdomain. And we'll see this when we get the activity started. But once the activity goes, they throw a crazy number .discord app.sys. They have a long thing, and then it's just this is how they map it internally. It'll make sense. Let's get through it. Sure. Okay, so we need to add the root, and then we need to add the WebSocket. So add another URL mapping. So it's going to be /_WS, ws.joinplayroom.com. And then we'll save the changes. For people who are going to get lost, let me... If we go back to the front page of Playroom, there's a documentation button. It's going to take you to docs.joinplayroom.com. And we've got lots and lots and lots of docs, as well as lots of different libraries that you can use across pretty much any game engine, right? So we've got Unity, Godot, 3JS, React Fiber, React3 Fiber, Spline. So we've got a library for everything. So each one has its own like instructions. But we also have, where's Discord? Discord's in here somewhere. There it is. If you click on the Discord tab, there is this video. This is not us. This was someone who just really liked our stuff. He has a video about how to make a Fall Guys clone using our tech on Discord. And he goes through all these steps as well. He's more entertaining than I am. So if you guys get lost or you want to go back to it, these resources, these are all pretty good. These are all up to date as well. Okay, so we've got that, and enable Discord in your game. And enabling Discord in your game is literally when we get to the code part. When we're being cute when you start a game. It's Playroom .insert coin, and when you insert coin, it's literally a flag. You say Discord equals true, and if you say Discord equals true, it's going to try to use all this stuff to authenticate with Discord to make sure everything works properly. So once you've done that, you are actually, congratulations, you now have a Discord activity. So you may say, okay, cool. What does that mean? So let me fire up Discord here. Don't switch. I have things going on here. What is this? That is a Discord thing. Let me find a dead server from a million years ago. So if you go to a surface in your game now, not use that. Did it not get loaded in yet? There's the installation page of how your users install the app. So there's two different ways that you can get in. Before you actually make your game live, there's these URLs that are kind of generated that will allow you to install your activity either into your own Discord server or wherever you want to install it. It looks like a bot. It's identical to a bot. And then once it's in that server, you will have the ability to find it in the surface. Like, let me show you here. So if you click on this icon here, whoops. Like if you just go to any chat like box, any of these surfaces, you're going to see a game style icon, and you're going to see, well, this is actually customized to you, like based on whatever you did last. It'll show you apps in the server. It'll show you the recent ones. And then it has a list of things. You'll be able to search for it and see your own. Once you have, there's a spot in Discord where you can then try to publish it live. They actually want to review it first before it goes live. And then it will show up as a searchable Discord activity. But until then, you have to publish it through them first. But it's just a checkbox through this application. Let's do. So since Death by AI is on the store, in the Discord site, you saw where you could put in the name and the application. You can put in the app icon. This is what's going to show up. If you have a trailer or something, you can have that as well. But let's do the ones that we just created. So. If I click on the copy button next to the install link, and I paste it in the browser, if you guys all do that, now be careful whichever Discord server you're in. If you have the ability to, it's going to instantly try to install it there. So go to your own Discord server or wherever you want. And it's going to then pop up, okay, Tim's Super Transformer, add it to my apps, add it to server. Actually, I want to add it to my apps. That's new. This will allow the developer of Tim's Super Transformer to create commands, send you direct messages, solve a mystery. I'm going to authorize it. Success. Open app. I clicked open app. What happened? Okay, well, here it is. Tim's Super Transformer. Traditionally, there's a start button right there. Well, there should be a start button right here. We'll figure that out here in a second. But at that point, congratulations. You now have a Discord activity, and it's done. All we didn't do is create the game or upload anything. So if you saw earlier where we have the hosting link, if I was to fire that activity up, what we would see is this not found inside Discord because it's literally nothing's being mapped there. I'm going to restart Discord and see if that helps. Did anyone have a launch button? No. Told you I was winging this, right? Discord decided to update. You know what? I said add to my apps. I'm going to add to this server. Okay, well, maybe that's my problem. So I'm just going to add it to the server instead of just adding it to my apps, which is going to be, which one am I on? And this one. You know, typically that's all it takes. So what I'm going to do is skip to where we pretend it worked. Yeah, it's supposed to be a launch button. I don't know why it's not working here. Well, what we should see is this. Now, this is Death by AI, and this is literally the exact same steps you just went through is what we went through here, except when I built the game, I dragged all the files up to that part in the hosting. I dropped it in, and there it is. So we'll get back to that in a second, but I did want to show you what it looks like. So this is in Discord. And I'm playing by myself here, but if I was in a call with all of you, you would see that I've got this running and you would have the ability to join it, just like it was like sharing it, watching a stream or something. It's the exact same thing, and then you would be in the exact same game instance as I am. And if you've never seen the game, should we play it in the GGDA one? That way everyone can come in. Are you guys all in the GGDA?
It is kind of hidden, so you gotta generally be friends to add folks to it, unfortunately.
Oh.
I tell you where we can do it. There's one called ATL Games Plaza.
ATL Games Plaza.
You should be able to find ATL Games Plaza. We're very public. Well, that's for indie games that have been developed here who don't want to host their own Discord. It's not in GGDA.
Okay.
We can do it in GGDA. I know it does.
know if you're in Discord.
Wow, that's the thing.
Can people find ATL Games Plaza?
How are we searching for that?
Down at the Discover on the bottom.
Oh, right, there we are.
There's a way to do it there. I know there is.
ATL Games Plaza.
Hit the search magnifying glass. Obviously, I'm going to find it because I already have it. No results found.
Yeah.
ATL Games Plaza. That's annoying. Yeah, I'm afraid that most of the people are in here are not GGDA Discord server members. You're in it? Yeah. All right. Who here is in the GGDA Discord? Is. Yeah. All right. We got 3 in the GGDA, 4 in the GGDA Discord.
We could join the Playroom one. That's open.
All right, do Playroom. Oh, I can't find ATL Games Plus. That's crazy. But it is true.
You can find it if you like type into Google and not Discord.
Ah, you're smart. Google ATL Games Plaza Discord.
There's like a newsletter.
There you go. And then you'll find my newsletter with a link, or my news thing. To join the server, go here. Yep. Smartness. Someone at this conference has a brain.
ATL Games Plaza?
Well, yeah. Look, ATL Games Plaza Discord search.
Okay, I'm in. Thank you.
All right.
Oh, here it is.
Yeah. And we've got it set it up for gaming, so grab any of those miscellaneous game rooms, Tim.
I'm going to go into Miss Game Room 1, and I'm going to mute my deal. And then, as you guys join, I'm starting the Death by AI activity, and you should all see it. If everyone can mute, please. Yeah, you're.
Authorize. Give Tim all of your personal data. Windows Defender is blocked sometimes.
All right, all the marshmallows are starting to come in. It's just WASD to move around.
How do you play? I'm in here.
There's a confirm button. It's really small on there. You see that? The really tiny confirm button in the middle of the scroll bar. Nope. I get an ad for banana. Then I get something.
Playing free avatar. How to play?
Yeah, so we're just waiting for the game to start. I'm just waiting for everyone to come in.
No, what's your username? Chang?
Yeah, Chang. Thank you.
Okay, is everybody in who wants to be in? Everybody waiting? All right. So we'll go ahead and play a game together. I'm going to hit start. And I get to choose the scenario since I'm the room host. We'll just do that. So an avalanche is heading toward you. Now, enter your survival strategy. You have 140 characters and about a minute.
Tim. Yeah, kittens and orphans. Hide behind kittens and orphans. Three, two, one. I feel judged, Tim.
Your fate has been sealed.
You have a picture of a seal there, come on. That's me.
L.Liu tries to go to a bunter, buy food and water before that, shut down power.
L.Liu's quick thinking to buy food, water, and shut down the power buys them precious moments. But the relentless avalanche crashes down before they can reach a bunker or find safety. The snow engulfs them in a deafening roar, leaving no chance for escape. Death claims them in an instant. Their resourcefulness was admirable, but unfortunately, it wasn't enough to survive nature's deadly fury. In the end, L.Liu did not survive.
Say it again?
Is there any way to tell which endpoint you're using right now?
If I jump into a different dashboard, I probably could figure it out. Okay, girlfriend tries to, I'm going to run, and as soon as the snow is slowly falling, I'll slide smoothly into a cave.
Girlfriend sprints to escape the looming avalanche, their heart pounding with adrenaline. Just as the snow begins to fall heavily, they manage a swift, graceful slide into the cave, narrowly avoiding the crashing white wave. Unfortunately, the cave collapses moments later under the relentless snow, trapping girlfriend inside. Their survival is uncertain as the snow seals their fate. In the end, girlfriend did not survive.
So which large language model is called to do this?
I'm pretty sure this is using Google's one.
Gemini.
Like 2.4 or 2.3 or 2.4. It's an older Gemini. Okay. L.Liu, dig a hole and build a wall, but really an avalanche in summer is just a figment of our imagination, so we can will it out of existence.
L.Liu-041 attempts to dig a hole and build a wall, convinced that the avalanche is merely a summer illusion that can be willfully eradicated. However, as the snow and debris surge forward with unstoppable force, their efforts are futile, and the avalanche crushes through their defenses. Sadly, L.Liu-041's resolve cannot withstand the relentless nature of reality, and they meet their end beneath the crushing weight of falling snow. In the end, L.Liu-041 did not survive.
No one survived yet. All right. Andrew, convince all of my 20 friends to stand in front of me and block the rocks while I run away.
Andrew Greenberg, Maine, HDEA/GGDA quickly shouts a desperate warning, rallying their 20 friends to form a human shield against the surging avalanche. With brave determination, the friends stand firm, absorbing the crushing weight of snow and debris, giving Andrew a precious seconds to escape. Miraculously, their courageous sacrifice averts disaster, and Andrew manages to scramble to safety, though they are deeply shaken by the cost paid to survive. In the end, Andrew Greenberg, HDI, and #X2F, GGDA survived.
You did it! Andrew survived.
Now you can slide down me to safety.
Okay, Stoic, cryo myself before I suffocate underneath the ice and wake up in the year 206. Well, time is apparently toroidal. It's gonna reset.
Stoic's desperate attempt to cryo themselves in a bid to escape the suffocating avalanche momentarily halts their impending doom, but the force of the snow proves too overwhelming, crushing their body beneath the icy weight. As the snow settles, the faint glow of their cryopod is swallowed by the relentless glacier, sealing their fate in icy eternity. Unfortunately, Stoic perishes, their daring yet ill-fated effort thwarted by the ruthless power of nature. In the end, Stoic did not survive.
All right, only one survivor so far. Arctica. hop on my snowboard and start shredding down the mountain and get an Olympic medal.
Optica leaps onto their snowboard with daring agility, attempting to shred down the mountain as the roaring avalanche looms closer. Despite their bold move, the chaos of the snow and crushing force of the avalanche overwhelmed their efforts, leaving no chance for survival. Unfortunately, Optica's daring stunt ends in tragedy, succumbing to the relentless onslaught of the snow. In the end, Optica did not survive.
Posthumously. Okay, me. Using Andrew as a sled, I jump onto him and ride his back to the bottom.
Tim of the North crouched behind a fallen tree, desperately attempting to use Andrew as a makeshift sled by jumping onto his back to ride to safety. As the avalanche roared closer, their daring gamble paid off momentarily, and they hurtled down the snow-covered slope. Unfortunately, the sheer force of the snow overtook them before they could reach safety, engulfing both and sealing their fate in a tragic but exhilarating escape attempt.
Exhilarating.
In the end, Tim of the North did not survive.
Did not survive.
Okay, so we have one survivor. So that's what I really like about Discord activities. We were all able to jump in. No one had to install, well, I mean, if you forget the setup we just did about our own activities, no one had to install anything. Just jump in and play. Pretty fun. Did you guys want to try Banana of Doom?
We got 5 minutes.
We have 5 minutes?
Questions?
Oh yeah, maybe we should do questions.
I'm glad you Banana of Doom, there's no questions. People want to do Banana of Doom, but they want to ask questions.
We can also play Banana of the Doom later. Like, I mean,
Banana of Doom or questions?
I know I barely set anything up. But
Banana of Doom.
Banana of Doom. All right, let's do it. All right, stay in that channel. I'm going to start up Banana of Doom.
Banana of Doom.
Now this is an earlier version, and the Happy Holidays was supposed to come down February 1st. Someone's getting fired. So yeah, you WASD will run around the planet. If you hit the space bar, you'll throw a card at other people. Girlfriend, Stoic, Octica. You guys playing for the very first time, there's a Fatui where you're probably opening card packs. It's supposed to make you feel magical, so feel magical.
Can you turn off the death by AI activity?
Everyone has to leave it.
Oh.
So, let's see, one person is still in there. MD Ashik Raman? Is that someone who's...
Death by AI can leave it, that'd be great.
Yeah, you can go ahead and exit Death by AI.
Mother.
These are all little bananas.
Alien mother.
All right, everybody let me know when you're through the tutorial, and or not the, well, the Fatui. Oops. Is everybody through the opening their cards? No, you're still opening cards? Okay. As you see, we give you a whole bunch of cards to start with, different, and all the art is hand-drawn. This is not generated art. There is a limit of 12, so it could be... How many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9, so there should be room for a couple more.
What am I pressing to get in?
Did you hit the join button? It should just be like hitting the
Join server puts me on your server. That's how I join. I'm seeing.
Oh no, you're in.
Okay. It's not seeing my name on the site.
Yeah. Maybe, you know what, we probably ran out of room.
Okay.
Are you running here? WASD and try to run around. There you go. Yeah, there you are.
Okay, thanks.
For whatever reason, you're not in the leaderboard on the left, but... Okay, you guys ready to start?
Yep.
All right, here we go. Starting game. He said starting the game. There we go. Did you know sometimes Unity's buttons are hard to press? This is actually made in Unity, by the way. Okay, so just to show you how it works. Contest, worst visitor coming through the chimney tonight. So you can click on the cards, like party and strong and normal, and then you rearrange the cards. And then if you click on the word, if it has an ability to modify into like parties, partied, partying, right? And so what you're doing is you're trying to combine cards together to create the best answer. And then you can throw cards away, just drag them down and get rid of it. To get more cards, go to the top, and then it's random, but and you can only hold 10 in your hand at a time. But you can do beans, modifiers, miscellaneous, and then the linkers are words that don't have any art, like and, the, they, things that just put stuff together. All right, what is our thing here? I have 22 seconds. Worst visitor through the chimney tonight. They should combine together and then drag it to the top and play it. You should have seen them get merged together. And I'm the only one who's submitted, so no one submitted cards.
Ain't like yours either.
Okay, so here's me. I should win by default. Yay! Oh, okay. Well, don't hit the combine button anymore. Put them up there and then hit quick play.
Quick play.
Yeah, maybe the combine button might be broken right now. This is an older build. Okay, so we'll do a different one. The most alarming holiday miracle. So yeah, let's just everyone try to just do this. Pick a couple of cards. And then hit quick play. And that should put combine the cards and put them up top. And then you should be able to click the I'm ready button.
Oh, it looks like this round the cards already were combined with things I already had from the last round.
Okay, so just drag it. You can drag it up to the top and then click I'm ready. This is the submit area up here.
Okay. So now I have 4 words in that card.
Well, now you have 4 words in the card.
Yeah.
A little bit of a learning curve. Sorry, guys. I'm going to work on the fatui.
So this
I know.
game was created using your platform.
Yeah, and we made this. Yeah, and it was made with my tools, and I made this. Yeah. And the cards, once you combine them together, if you kind of hover over them, the shader's got this like lenticular effect where you can kind of see both cards based on what you're doing.
So what's the main feature of your tool? I know it helps us collect the pipeline while things together.
Yeah, it helps you publish this in Discord. You just created the activity, so that technically works now. So you can network everything together. It's all of the authentication with Discord. Okay, so I missed this one, but it tells us a little story. So you're a hard story banana strong, a banana that can bench press a sleigh is impressive but hardly alarming. Where D2 Kivo's snakes, dogs, melon. A melon full of snakes and dogs is the stuff of holiday nightmares, making it a true miracle of alarming proportions. So the AI is judging who should have won.
Okay.
And so they won. So let's see the next card. Snakes, dog, melon versus a fish human for a most alarming holiday miracle. Fish human wins. Snakes, dog, melon, a fruity reptilian canine parade that raises eyebrows but not heart rates. Fish human, an aquatic biped miracle that leaves everyone floundering in existential dread. So, little witty banter as it's judging you. You failed to make a card. Milk morning, okay. Okay, fish human was more alarming. A fish evolving into a human's overnight is a miracle so alarming Darwin would need a holiday himself. Milk morning, a morning where milk flows from the taps is more of a breakfast convenience than an alarming miracle. Knife at party. Okay, this is pretty good. All right, rightfully so. Fish human, just another day at the beach for Poseidon. Knife at a party, nothing says festive like a surprise carving demonstration. Doggy story. Knife wielding Santa. Tessa started singing carols. All right. French fries. Knife of the party. It's the most alarming. Into a survival thriller. While delicious, it's more of a fast food dream. And then my partying sausage.
Partying sausage.
Party versus party.
Whoa!
Yes. I got the streak buster and the final blow. A sharp reminder that not all surprises are festive. Partying sausage is a meaty miracle that defies both culinary logic and holiday decorum. And then, since I won, I get to pick the next topic. And so this is how you play. So, a text you should never send your boss.
Hey, Tim, when you're done with yours, come on over here.
Yeah. Drag it so you make it this ham alien, make it alien ham. And then you can either click play.
Okay.
And just click on it once to add it to the sentence. Click in, click in, alien ham in. Like melon or whatever, right? And then when you get 8 seconds, so support something. And then I'm ready.
Me and UI.
Okay, ham and alien versus broccoli spoon rich mother.
This will be the last game before Unity comes up.
Right on. Sounds like a cryptic grocery list or a peculiar family reunion. Ham and alien is a text you would have your boss questioning your sanity and possibly your employment status. Day bad. Intergalactic culinary crisis. Pessimistic weather report. And career-ending text. Nice. Free points. That is strong. Motivational poster gone wrong. Tiny snake by Blue They Melon. A cryptic poem. Milk this ball. Oh. Boo. Milk this ball. An avant-garde dairy sports proposal. So that is Banana of Doom. You can play it in Discord all you like. We've got another version with more stuff coming out on Steam. But yeah, I'll go ahead and end the game there. But that's Discord activities, and as you saw, what I really like about them is that like, once you get through that first hurdle of setting it up, like if you upload your WebGL game folder up on Playroom, it'll just be there, and everyone will there's nothing to install. They just click join, and then it works. Pretty cool. All right, thanks everyone.
Yay. That's it for our